Dimmi. Ok, ma che hanno fatto? Ma com'è possibile che le cose belle e buone? Ah, poi, mo che avevano apparato, come hanno apparato? Ma boh, ma quello può essere semplicemente che quello spengono, buttano giù tutti i livelli, avrei rotto il cazzo conmigo. Non mi appara una adattatura, roba. Perché sennò... No, mo faccio partire. No, partimmo che ancora non stanno parlando, stanno facendo... Di che?
Tu che hai fatto questa
Pausa. No, solo uno.
Solo uno. Perché qua divido, perché tu tieni
Perché questi sono frizzati.
tu tieni fare forza per
Perché a te che fanno?
come si spiega?
Non lo so.
Scusate.
Che devi scusare?
Se dice a quelli là in un minuto vai chiudere voi. Ma
No, questo qua... Ah, ok, questi sono i share. Ma io le posso ancora controllare? È un po' scomoda questa visualizzazione a colonna in questo scenario, perché però vabbè. Ma io perché qua vedo spettro e qua non sento niente però?
Hello, good morning. Welcome. We have the privilege of having the first session at this new and improved live meeting. And we're really happy to see you all here in person. So, oh, sorry, I'm getting emotional. No, that's for later. Anyways, we have a short tutorial planned about IPv6 security. We wanted to tackle 8 of the most mentioned myths in IPv6 security and try to debunk them, or at least not try, we're going to debunk them. And because learning only happens when you check your knowledge, we also have a little exam after the tutorial. So not only are you going to sit there and nod and say, yes, yes, I understand, but afterwards you're going to have to press a button and show that you understand, okay? So here's the deal. I'm going to invite Jad and Matt up to the stage. They're going to do their part, talking, explaining, hopefully making it clear why an IPv6 myth is not true. And afterwards, I will be taking an exam. So see you in a while. Jad, Matt, take it away.
Let's see, good morning, everyone. Let's see if it works. It does. All right. Just by a show of hands, can you let me know if you have previous experience in IPv6? Well, we're at the right meeting, so I expect. All right, so there's one disclaimer for this. Usually this presentation is a subset of the IPv6 security course that we give, and usually we expect like the prerequisites at least is that you have already witnessed the basic IPv6 and the advanced IPv6 course. So there are some notions there here where we expect you to be already familiar with it, but in case you have any questions about this or you want us to revisit it, please just feel free to interrupt us. So before we start with the slides, you're going to see these icons on the screens. So we try to approach our learning from 3 points of view. The first one being the explaining what the attack vector is, and that's the blue icon. Sometimes you're going to put the malicious hat on, and you'll see the attacker icon. And when we talk about how we can prevent some types of attacks, then at this point in time, you'll see the green icon. So sometimes we might be visiting the same topic, but from 3 different points of view. All right. Okay, so what we will be doing today, just like Gerardo mentioned, is demystifying the IPv6 security. There are 8 statements in total. We're not going to call them myth right out of the box. Some might have a certain degree of truth, some might be completely wrong, but we'll see one by one. All right, so the first IPv6 security statement that we will tackle today is the following. IPv6 is more secure than IPv4. We've all heard it, we've all been there, right? And IPv6 has a better security and it's built in right out of the box. Now, the reason behind this statement that we usually encounter is that RFC 4294, when it went out, it said IPsec is a must. So all IPv6 nodes must support IPsec, right? And if IPsec is there, then this makes IPv6 inherently more secure than IPv4. So this is what we used to hear in the industry and in our circles. But the reality is different. So IPsec, even though it was not a built-in part of IPv4 ever since it was standardized, it was available for IPv6 and IPv4. Now, if we only look at the literature, we can also notice that RFC 8504, and let's say downgraded the level of support of IPsec for IPv6 nodes. So now it's a should, it's not a must anymore. And then the inherent problem here is that we cannot use IPsec on the internet on a global scale because we don't have a global PKI system that could support this, right? And there's another reason behind that, like why didn't IPsec pick up really with IPv6? Like its use cases were just as similar in IPv4, where we used it for IPsec tunnels, VPN tunnels, and the such. But one of the selling points for IPv6 was that, you know, the Internet of Things and these small connected devices, these dumb devices, they are going to explode and we will need IPv6 everywhere. And so we cannot expect that to have IPsec enabled with the CPU, with the computing requirements that it needs on such small and resource-constrained devices, right? So the reality is that IPsec is available. It is available for both IPv4 and IPv6, and it is used for security in IPv6 protocols just as it was used for IPv4 in one way or another, right? So the fact is that we need a change of mindset. So it's not always a question, is IPv6 more secure than IPv4? Is IPv4 more secure than IPv6 because people know more about IPv4? It's a different ballgame, right? So what we say is that IPv6 as a protocol by itself is not more or less secure than IPv4. It depends on your operational practices. It depends on the premises of your network and so on. And knowledge of the protocol itself is the best security measure. Because yes, we do agree that there are some new mechanisms that were introduced in IPv6, such as like the NDP, the status configuration, etc. And this comes with a whole set of security measures that should accompany. Now, as we said, the best security tool is knowledge, so build your knowledge on that. IPv6 security is a moving target. We see a lot of moving parts in IPv6. We still see new standardization, new functionalities. We have the extension headers. We have the whole thing about fragmentation. So it's moving all the time, and we have to keep up with this. Also, IPv6 is happening. Now, we are in Germany now, where we expect a very high, good level of IPv6 adoption, and that's the case also mostly in Europe. Personally, I'm based out of the Dubai office of the RIPE NCC, and in that part of the world, IPv6 is still, let's say, developing in its developing stages. We have some countries that have really good IPv6 adoption, like the UAE or KSA, but also we have some other countries with almost 0% of IPv6. And usually when we go and talk to them, they say, you know, IPv6, we don't see a lot of IPv6 traffic, so security now is not really necessary, but IPv6 is happening. We're going to see that in later stages and slides down the road. And we have to build our knowledge for it, even if we are not actively deploying IPv6 at this point in time. Because at the end of the day, we always talk about the scalability of the internet, the growth of the internet, and I don't think that we can agree on another statement than IPv6 will be fueling the growth of the internet going forward. All right, let's move to the second security statement, which is our beloved NAT. So IPv6 has no NAT, and there are global addresses used, and that's why I'm exposed to attacks from the internet. Now, our intention is not to start an intense religious war on this statement, but we'll try to tackle it as politically as we can. So the reason why people might say this is that the IPv6 has reintroduced the end-to-end paradigm in the IP connections, right? So a source will talk to a destination. There are no middle boxes that can tamper with the headers, change the IP addresses. So, you know, we are using global unicast addresses, which are the equivalent of public IP addresses in IPv4, and everything's nice. We are all connected to the internet. There are no nets, so we are exposed to any types of attacks. The reality is, and bear with me, NAT does not equal security. I know it could hurt the feelings of many people, but it's a reality, right? The reality is global addressing does not imply global reachability. And since we are all mature and mature network operators, we understand that the security function should be implemented at different levels, at the host level, at the perimeter. We have the firewalls configurations. We have all sorts of things to look at. And it's not just NAT. So we, as network operators, we are responsible for the reachability. And at this point, we're talking about filtering, right? Now, I will take a couple of minutes to talk about filtering because this is very important in IPv6. Now, with the introduction of the IPv6 address space, we have a lot of IP addresses, right? So this is the amount. I'm not going to entertain you and try to say this number. It's big, very big. And because of the nature of the IPv6 address spaces, we have end-to-end connectivity restored, right? But there's also another aspect that we have to consider, which is that we have different type of addresses in IPv6, just like we had in IPv4. but with a different twist, a different flavor in IPv6. So we have link local addresses, we have the GUA, the global unicast addresses, and we also have the multicast addresses. And each one of them, you know, they come with a different perspective when it comes to security. But there's also a new nuance with IPv6, and that's the address scope, which really did not exist per se in IPv4. So in IPv6, we have different types of addresses, but also think about the scope as where do these addresses live? So there are some v6 addresses that, for example, only live at the interface level. Some others, they live on the link, the layer 2. Some are restricted by the layer 3 domain. Some can live only within a certain organizational scope. And some others are global. Now, when we say global, doesn't necessarily mean that they should be rooted on the internet. And this is something we should always keep in mind. For example, the ULAs, which are the equivalents of the private IP addresses, they have a global scope, but are not routable on the internet. So always keep this in mind. And this would also help us when we start designing our filtering approach. So we have different types of IPv6 addresses, and each one of these IPv6 addresses have a certain scope. So they live within a certain boundary. So we can leverage this as a first line of defense whenever we start talking about filtering. Moving forward. So some security tips related to filtering, and then we're going to dive a little bit in each different category of filtering. Try to use hard to guess interface IDs, right? I hate to break it to you, but you're not the first one to figure out that we can use 1 and 2 and then 3 or sequential addressing. In order to fight against this, or in order to fight against malicious players trying to figure out your interface IDs, do not use sequential things, do not use easy to guess IIDs, do not use the modified UA64, which is basically using your MAC address in order to generate your 64 bits interface IDs. We have a section on this later on, but this is important to mention at this point in time. Use IPS and IDS as much as possible to detect scanning. We are going to see that in IPv6 networks, there are some special smart techniques to do scanning. And you will need intrusion prevention and detection systems in order to fight against that. Do filter packets where appropriate. And I'm going to repeat myself here. You have to filter at different levels: host, parameter, data center, external, internal, everywhere. And be careful with routing protocols. We also have a part some slides on this later on. And use the /64 size for IPv6 subnet prefixes. This is going to make brute scanning something of the past. Now, filtering in IPv6 is very important, as I said, because we have the whole concept of the end-to-end paradigm, and because we don't have NAT and so on. And right out of the box so far, we can say that a good addressing plan in IPv6 will go a long way forward when it comes to facilitate your filtering, right? So if you spend some time, if you really thought about your addressing plan before you started doing the assignments and the actual deployment of IPv6, then you will be able to do better filtering down the road. So let's say you have all your customers coming from /48, you have your POP coming from different /39 or whatever. In this case, if you like to do filtering, then you can do it on the big IP blocks instead of doing on the individual customer parts and so on. Now, in IPv6, there are new filters that you have to take into account that did not exist, or you didn't need to use them in IPv4, and that's because IPv6, when it was brought in the industry and it was being developed, there are some new mechanisms that were associated with it. For example, we have IPv6 extension headers. We have the fragmentation filtering, because in IPv6, the source does the fragmentation. The network does not touch the packets in terms of fragmentation and so. And we also have the whole thing about transition mechanisms and having dual stack networks, and that also comes with security risks. So let's start with the first topic here, ICMP v6. I don't know about you, but before joining the RIPE NCC, I used to deploy networks for customers. I worked in a solution integrator, and I've seen so many cases where the client wanted to disable ICMP completely, right? Because yeah, that was the sensible thing for them to do. If you do this in IPv6, I can almost guarantee that you're going to break all of the IPv6 network, because there are a lot of mechanisms in IPv6. One of them are, like, for example, the neighbor discovery protocol messages that run on top of ICMPv6. We also have other things like the PassMTU discovery and so on that also leverages ICMPv6. So filter it very carefully. And when you start filtering ICMPv6, you have to understand that it's not like, different flavors of chips, we have this and that and that. No, in reality, we have different types of ICMPv6 messages, and then there are also codes associated for them. So let's say, for example, we are talking about the error messages in ICMPv6, and we're specifying error messages. As you can see, we can have different types. Let's say destination unreachable is the first type. It's indicated by type number 1. And then you can see that there might be different codes. So why is the destination unreachable? Is it that we don't have a route to destination? And then in this case, the code is 0. Is the port unreachable? Code number 4, and so on and so forth. So right at the very beginning, when you want to start designing your filtering approach, and more specifically the ICMPv6 filtering, you have to understand that there are different types of errors, different types of messages, and then different codes. And this will play a role when you start designing your filtering approaches. Now, this is just like one recommendation taken for what ICMPv6 messages should you allow and what you should filter, basically. And this is not set in stone. This is just one of the recommendations out there, but this can change super easily depending on your network premises, what you are running inside your network. If you have, for example, servers in a data center and you want to allow neighbor discovery messages back and forth, if you have, for example, a firewall at the host level and you would still like to allow NDP messages. So this is not something set in stone. But typically, what you would like to allow in your network are, for example, destination unreachable, of course, packet too big. So basically, so that you can do the PassMTU discovery, you have to allow time exceeded, parameter problem, etc. And then we get to our favorite part, which is, the ping and the echo reply, echo request, and so. This you can allow it if you'd like to do troubleshooting purposes, but like rate limited, of course, and do this where you absolutely think it is necessary, right? And then we have the set of the neighbor discovery messages like the router solicitation, the router advertisement, the neighbor solicitation, neighbor advertisement, and redirect. Typically, on top of your head, you wouldn't want these messages on your perimeter firewall, right? So you only allow it if you expect messages to be crossing across a certain security boundary, right? So keep this in mind. Now let's talk about extension headers. Extension headers was supposed to be the nice thing, the cool thing about IPv6 headers. We simplified the basic header, and then if we needed more functionality, we shoved it in the extension headers that we might or might not use. So extension headers are really cool. They are flexible, but when we say flexible, we can think a little bit about some complexity when it comes to security mechanisms. So there are certain rules to follow. Extension headers have to be present in a certain order. They cannot be present more than one time, except for one destination options. Matt will be talking about this later on. So with the introduction of extension headers, now your firewalls and even your security mechanism devices, they should be able to recognize all the extension headers and do filtering based on them. So for example, if your firewall sees a router header 0, which is deprecated, then the default action should be that you should drop this message or this packet. Also, Matt will be touching on this later on. Firewalls should follow all of the chain of the headers, so not only the basic header, they should go through all of them together, and they should not allow forbidden combination of headers. Like, for example, if we have the fragmentation header twice, this should not be allowed. Some of the attack vectors or the attacks that we can leverage using fragments, for example, if the upper layer info is not in the first fragment, okay, so basically the attacker can create tiny fragments and the layer 3 headers and the extension headers and so on, they are not all in the first fragment. So this is one of the attacks that can be done in order to bypass the firewalls. The other type of attacks is when you have two fragmentations header. So let's say you have a fragment inside a fragment. So you can hide the malicious payload and the fragments on the inside, and then you can bypass the security measures. And the third vector of attack is, for example, to have a fragmentation inside a tunnel. So you'd have an encapsulation header on top, and that would, mask what is inside. Now, these are the type of attacks. How can we solve them in IPv6? So RFC 7112 says that all the header chain should be in the first fragment. In other terms, the first fragment of a series of fragments should have the basic IPv6 headers, all the extension headers, all the way up to the layer 4 information. All right, so that if a firewall is presented with such type of packets, the firewall can look at the whole chain and decide, oh, okay, this is what this packet is about. Let me see if I filter it or not. Fragments inside fragments, this should not be allowed in IPv6. If you see it, just throw it in the garbage. Fragmentation inside the tunnel, well, this happens due to many practical operational requirements. So your firewalls or your security devices should be in a position that supports inspection of the encapsulated traffic. Filtering, transition mechanisms, and dual stack. We all like a good argument about transition mechanism, which one is good, which one is bad. We will not get into this, but keep in mind that there are a lot of transition mechanisms out there. Some of them, even some legacy of them, they used to establish themselves automatically, even without someone actively configuring them. So there was a case where you can see some tunnels being set up without the network operator's desire to have them there. So you might need to filter them. So let's say, for example, you would like to filter 6N4 or 624 or 6RD or the ISATAP or the Teredo, then we give you some of the filtering rules on the right that would help you to do such a thing. Now, if you like more of this, we also included the RFC that includes the recommendations out there, but also the protocol numbers from the IANA in case you would like to tackle a certain protocol and do your filtering based on this. So, in a nutshell, IPv6 packet filtering, it is more important in IPv6 because of the nature of the global reachability, because of all the new protocols that are there. But we should always keep in mind that there are some common practices in IPv4. And if you are really into the security lectures or the security guidelines nowadays, they would tell you try to come up with security policies that are not based on IP addresses, but more related to the identity or the type of traffic and so on. So keep in mind that there are some common IPv4 practices that you should bring also to your IPv6 networks. And of course, the new IPv6 consideration that we mentioned so far, just like the extension headers, like the transition mechanisms, the ICMPv6 playing a bigger role in IPv6, all of these you have to take into consideration. Well, I speak a lot. So, third security statement, IPv6 networks are too big to scan. Right? This is one of the easy selling points in IPv6. And the reason behind that, I've already touched base on this, is that let's say a common LAN or a VLAN or layer 3 domain uses a /64, all right? A /64, in other terms, it contains 2 to the power 64 IPv6 addresses. So that's a lot of IP addresses. And I remember doing a research one time, like how long would it need to for someone to brute scan just one /64? And I think it was in the order of 300 to 400 years or something like this. So we're not there, right? So the reality is brute scanning is not possible, but there are new scanning techniques out there, and it also depends how you generate your IP addresses. So let's start by that. An IPv6 address is 128 bits, right? We all know this. And there are two parts of it, just like in IPv4. The first part being the network prefix, that's the first 64 bits. And then you have the other 64 bits, which is the IID, the interface ID. Now, bear with me, and that's basic math. If somebody wants to find out your IP addresses, they have to find out both parts of it. So let's start with the network prefix, right? In order to find out the network prefix, and that's the easy part, there are some different approaches. One of them is, for example, looking at trace routes, right? You can see the first /64. Even if you see one IP address is out of the /64, you can deduce the /64 and then focus your work on this prefix. You can do DNS. You can leverage the DNS direct resolutions or even reverse resolution. So you can go into the IPv6 ARPA branch and then see what are the prefixes that you can deduce from there. But there are also things related to human behavior. For example, common patterns in addressing plans. Are you using sequential ones? 1 and then 2 and then 3? Are you embedding IPv4 prefixes like the network part inside the network prefix in IPv6? There are some commonalities, but there's a lot more that you can do here. You can go at the RIPE database or the other RAR databases, and you can see there. You can see if you're running a server, you have the logs there. If you have a mailing list, you can see the IPv6 addresses in the headers. You can deduce the network prefixes in 1,001 ways. Now let's focus more on the interface IDs, because this is where most of the work would be, and that's where the 2 to the power 64 IPv6 addresses are. So as we said, brute force is no longer possible, but we do have different things to consider there. So what are our current options to configure the last 64 bits, which are the interface IDs? Let's start with the easy ones, manually, so you configure them yourself, or you use DHCP-v6. This is in some way similar to what you have in IPv4. Now comes the auto configuration part, like the new thing that was introduced in IPv6. So at the very beginning, we had the stable IID for the Slack. So that's the first one, and that's the modified EUI64, which basically where we use the MAC address in order to generate the last 64 bits. That was easy to set up, but it came with a whole set of privacy issues. Like if I know your MAC address, then I can figure out what your interface ID is. And then your interface ID would be the same whether you are connected at your office, at Starbucks, at home. So it's easy to track and so on. So because of this, the community came up with the temporary address extensions. That's the third one for Slack, which basically means that you get temporary IP addresses. They will keep changing every amount of time. Every time you close your laptop and you open it, you'll have a new IP addresses and so on. This is awesome for security, but this is a nightmare for network administrators, or for example, if you're in a corporate environment and you need to enforce certain set of rules. So that's why there was a need for stable IDs, but they should be IP addresses that are not tied to a certain identification and that are not trackable. And this is the second one, which is called the stable semantically opaque, and that's the RFC 7217. Now, there are some other techniques like CGA, cryptographically generated addresses, or the hash-based addresses. There's a lot of math including there, but they are not being used extensively, so we'll not touch base on them. So now the recommendation out there is that if you are to use automatic generation of IP addresses, go for the semantically opaque addresses, which basically they have no value or meaning. So if you take a look at the last 64 bits, they don't mean anything. You cannot deduce anything out of it, right? And if you look at the RFC, there are 3 rules for an IP address to be considered as such. The first one being different for each interface and the same network prefix. That might be intuitive. The second one, not related to any fixed interface identifier. And this is the main difference with the modified EUI64 ones, because they are not related to MAC addresses, for example. And the third one is always the same when the same interface is connected to the same network. So that's the stable part, right? So every time you bring your laptop to your office, you're going to get the last 64, the same last 64. If you take your laptop and go back home, you're going to get a different slash 64, but it will always be the same as long as you connect to the same SSID with the same network parameters and so on. So this is now widely used and it is standardized for stable addresses as per RFC 8064. So this is one of the recommendations out there. Now, guessing the IIDs, what can an attacker do? And you see here the red icon in order to guess your last 64 bits. Well, they are not going to do a brute force scan, and we've already established this. But if you are using the UI64, then you're making it way easier for them to do it. Why? Because out of the 64 bits, you have the OUI, that's the first 24 bits of your MAC address. Then you have the FFFE, that's 16 bits. So already with minimal effort, the attacker can know 40 bits, the first 40 bits of your IID. So they don't have to scan using all 64 bits. At this point in time, they only need to scan the last 24 bits. So that's the first one. Now, if you use the low bits or the trivials like double column 1 at the very end, 2, etc., the attacker can get a sense of this and, you know, start guessing your IP addresses. If you use IPv4 based, like if you try to transport IPv4 addresses and you put them inside your IPv6 addresses, and I have to say that I was guilty of this in my previous job when we started designing IPv6 networks. We used part of it, but not in the IIDs. We used it in the network prefix, so we didn't mess up really bad. But yeah, this if an attacker notices this, they can start scanning your IPv4 network, bring the IPv4 addresses, and then try to guess your IPv6 addresses. Service port. So if you want to include the port number of the service that is running on your machine or on your server, and you put it inside the IPv6 address at the very end. Now the attackers, if they see this and they identify it as a pattern, they can start guessing what other types of service you're on, because, you know, port numbers are known, they should, to a certain extent. Wordly addresses, we like to think that we are being creative and use Face and Book and Cafe and Babe inside our networks. But if an attacker looks at this and they identify such patterns, well, it would make their guessing game a little bit easier. All right, and of course there's the sequential bits. I will not elaborate more on this. So these are the things that can be done in order to guess your IP addresses, but there's also the DNS part. We'll talk a little bit about this here. So the other techniques is to actually scan the network. So doing traffic snooping, you can see the IP addresses going back and forth. If you are running a dual stack network, so I can guess your IPv4 address, see the associated to the MAC address, then look at the IPv6 traffic, see the MAC address, and then deduce your IPv6 address for it. Routing protocols, in case there's a misconfiguration in your routing protocol and you're starting announcing your network or your network prefixes to your LAN, then if an attacker is there, they can know the different networks that are running inside your organization. Local protocols, and this is related to DNS services. Like, for example, if you have LLMNR, so link local multicast name resolution, or for example, this is widely used in Windows machines. If you have MDNS, multicast DNS, so this is widely used in Mac OS and I think BSD, or if you have, for example, the DNS service discovery, so that's the DNS SD. So you can look at, you can listen to the traffic locally, and then you can figure out what type of machines you have. But also, if you look at the resolution and so on, you can find out the IPv6 addresses, host names, and so on. And of course, there's the local scanning, but that's also common in IPv4. All right, getting to the last one. Gerardo, how much time do I still have? I have some time. All right, so the last statement of my part is IPv6 is too new to be attacked, right? Like there are some countries that still don't have IPv6, so it's perfect. It's still pristine. And the reason is because there's a lack of knowledge about IPv6. It is actually happening. And the reality is that there are tools out there, there are threats, attacks, security patches, best current practices, documents, guidelines, you name it, right? You have to be prepared for IPv6 attacks. And this is something that Matt will be touching on later on today. IPv6 is happening. I'm pretty sure you have been bombarded with these slides and this graph. For example, this is from Google. We can see, I think here we're at around 40% of global IPv6 traffic towards Google services being run on IPv6. You have a list of countries, like for example, India, almost touching 60% of their traffic on IPv6. You have here at the top right, the list of ASs and the percentage of IPv6 deployment that they have. So here you can see that in some network operators, such as big mobile operators, we are seeing percentages of 80, 90, or even 95, 99% of IPv6 deployments. So IPv6 is happening. We've seen in previous RIPE meetings, like organizations presenting, saying we're doing IPv6 only networks, we're doing hosting solutions only based on IPv6. So we are there. Shameless marketing plug, we also have an IPv6 only SSID here in case you want to live on the dangerous side and use it. And so are IPv6 security threats. So this has been taken from a service that is now no longer publicly available, but we did manage to take a snapshot before it's happening. And you can see that among the top attacks that were happening at that point in time, you can see IPv6 addresses, whether they are unwanted email and spam, or there's a suspected traffic analysis. We can see that IPv6 has made its way up to the top of the security threats in one way or another. But it's not only spam, and so we've also been seeing IPv6 DDoS attacks, right? And there was a famous article in the Register in 2018 saying it has begun. This is the first IPv6 DDoS attack that we see. But in reality, there was also another article in 2012 saying that, yeah, this is the first attack in IPv6. We're not debating who came first, but IPv6 is happening on the public internet. And unfortunately, it is being leveraged to mount DDoS attacks and other types of attacks as well. So with this in mind, I pass the ball to Matt.
Okay, morning everybody. So I'll pick up where Jad has left off. He's a little taller than me, that's better. So yeah, I'll pick up where Jad left off. The next security statement we want to take a look at, IPv6 is just IPv4 with 128-bit addresses. There's nothing new. Well, in a sense, there's some truth to that. Routing and switching work in exactly the same way in IPv6 as they do in IPv4. We have packets, we have a source, we have a destination, we need to move them from one place to the other. So fundamentally, IPv6 is not that different to IPv4. However, in reality, there is a whole new addressing architecture, and there are many new associated protocols. So let's start taking a look at some of these associated protocols and the potential benefits and also threats that they bring. So as we mentioned, there's a lot of similarities between v6 and v4, but when we think about security, we need to think about the things that don't change with IPv6. So for example, packet sniffing. Packet sniffing in IPv6 packets is just the same as packet sniffing in IPv4 packets. We need to think about the things that do have some changes, such as network scanning. Jad's already spoken about this. If you want to do network scanning in IPv6, it's a very different ball game to doing network scanning in IPv4 with just 4.2 billion addresses to worry about. And of course, there's the new threats to IPv6, such as new protocols, NDP, the Neighbor Discovery Protocol, MLD, Multicast Listener Discovery. These are things we don't have to think about in IPv4. These are things we don't concern ourselves about. And with IPv6, we need to take that into consideration, and we need to make sure we plan for that when we're preparing our security. First off, let's talk a little bit about extension headers. So in IPv6, you have a basic header for the IPv6 packet with a source and a destination address and some other basic information. If you want to pass any additional information with the packet, it has to go in extension headers. These extension headers are daisy chained after the basic header. And as Jad previously mentioned, there are some rules to this. One basic rule would be that all extension headers should only appear once. That's a simple rule to get us started with. Unfortunately, of course, there's exceptions to that, and you can see one on the screen already. We have destination options mentioned in the second header and also as the final header. So although there are rules, there are exceptions to the rules as well, and we need to take these into consideration. Also, Jad mentioned there are certain combinations of these that shouldn't be repeated. So certain extension headers should not appear after other extension headers. You can read the details of all of these in the RFCs. We're not here to dig into detail about the specifications for each extension header right now. But you need to investigate this carefully and make sure that what you're looking for is what you are receiving. So what you expect to receive is what you're actually receiving in your network. So we get a lot of flexibility with the extension headers. We can do a lot more. We can be a lot more clever about how we route our traffic, but we also need to be more careful about how we do it. The flexibility is great, but the complexity means we have to take more security considerations into account. The most important message, and the one that we will be drilling again and again and again today, is that your security devices, whether they be hardware or software, must be able to process the entire chain of extension headers. And your firewalls must be able to filter on these. This is one of the big stumbling blocks that people run into when they start using IPv6. They discover that either they aren't able to inspect the headers in order to see what they're looking for, or they're not able to actually take action upon that once they see something that they want to remove. Let's take a start by looking at the routing header. So the routing header is one of the available extension headers in IPv6. It allows you to say, okay, I would like this packet to be routed to this destination, but along the way, I would like it to stop at this router. And you can specify that in the routing header. What's important for us here, as I say, we're not digging into the packets, but what's important is the segments left, the 8 bits available for segments left. This is where you can specify which routers you want the packet to visit along its path. There's 8 bits available for this, which means we've got 8 bits to potentially work with. Okay, so how can this work? Well, with routing header 0, you can use this to add additional hops along the path, and a malicious party could potentially use this for an amplification denial of service attack. So it would look a little like this. So you've got your malicious hacker on the left-hand side. He's at the source. He crafts a packet with a source address and a destination address. They're both fine, legitimate source and destination addresses. And then in the routing header 0, there are 128 options to add another location to visit along the path. In this example, the attacker has decided, okay, in the first option, I'm going to say I want you to go and visit router A. In the next header, I'm going to ask you to go to router B, and then back to A again, and then to B, and then back to A, and then to B. And this continues for each packet 128 separate times, which can create a denial of service attack on the link between A and B. It will also use up resources on these devices in order to be able to continue processing the packet over and over again. And ultimately, the packet will be delivered to its destination. So this is something that needs inspection to be able to spot this. The packet goes from source to destination. So at a glance, everything appears to be fine. But along the way, it's creating a massive issue between routers A and B. So how would we go about solving this? Well, there's one very simple solution to this, and Jad already mentioned it, and it was mentioned on the previous slide. Routing header 0 has been deprecated. Okay, great. Problem solved, right? Right? If something's deprecated by an RFC, it can't ever happen. Yeah? That's why we never see any private address space being announced to the global internet, because there's RFCs saying you're not allowed to do that. No. In reality, we know that this only takes us so far. What's important is that the vendors and the people who are making the equipment actually implement these RFCs in their equipment. And how are you going to make sure they do that? You're going to make sure they do that by checking, because nobody trusts an account manager. Nobody trusts a salesman. If you say, will this be okay? They're likely to say yes. So you're going to want to check this for yourselves. You're going to want to make sure that everything is doing what you expect it to do. So that's just one example of an extension header. Other issues that we have with extension headers would be, for example, the fragment headers. So fragmentation in IPv6 works completely differently to IPv4. In IPv6, fragmentation is done by the hosts. The routers along the path don't do any fragmentation. So there's a fragment header. This is the extension header that's added to the packet, which states there is going to be additional fragments of this packet so that they can be brought back together at the destination. What's important to us here is the 13-bit fragment offset and the 1-bit M flag, which, as you can see, is set to 1 if there's additional fragments to come, and it's set to 0 if this is the final fragment being sent. So this allows a host to send a packet along a link, discover that the MTU is too low. It will receive an error message via ICMPv6, which, as Jad mentioned, we won't be filtering out, so that we receive that fragment too big message. The host will then fragment the packet and send it out with the additional fragment header attached to it. Great, that's helpful to us. But again, there are threats associated with this. First up, overlapping fragments. We show here the fragment offset, the 13-bit fragment offset. This is where information is put into the header to say this is the part of the fragment that is contained within this packet. And then the next packet will have a slightly different fragment offset, and it should tag on quite nicely to the previous fragment. However, this can be manipulated, and a fragment can be sent out which overlaps with the previous fragment, perhaps fully, perhaps only partially. But the destination hosts will handle this in different ways depending on what the destination is. Some will handle it well, some will not handle it so well. So this is one attack vector. Another attack vector would be not sending the final fragment. So not setting the M bit to 0 when you send the last fragment. So instead of sending it to 0, you just send out the final fragment with the M bit set to 1. The destination is going to sit there saying, okay, well, I've got several fragments here, just waiting for one more, at least one more. Waiting for at least one more, waiting for at least one more. How long does it wait? How many resources does it take up? So this is another attack vector that's possible through the extension headers using the fragmentation header. There's also the possibility of atomic fragments. So these are fragments which are sent as a single fragment, but with the M bit set to 0. So again, it's expecting something, and it doesn't know how to deal with it at the destination. Now, as before, there are some solutions to this. There are some things that can help us, and as always, they're in the RFCs. So with overlapping fragments, what do we want to do? Well, overlapping fragments aren't allowed in IPv6. RFC 5722, these should all be discarded. Again, the RFC says they're not allowed, so hopefully they won't be sent in the first place, but if they are being sent, make sure that your firewalls, your IDS can detect that those fragments are being sent, and make sure your firewalls can take action on that and actually drop them. Not sending the last fragment, this can be handled through timers. So set let's say a 60-second timer and discard all of the fragments that have been received if the final fragment doesn't come through or the next fragment doesn't come through. And with atomic fragments, they should absolutely be processed in isolation from all other fragments. So those are the first couple of examples of protocols which we don't see in IPv4, but we do see in IPv6 and some of the threats associated with them. Something else that can be done with extension headers is bypassing the filtering of router announcements. So Jad mentioned previously that you should filter very carefully in your network, and you don't want devices on your network or outside of your network trying to claim to be routers if they're not. So router advertisement filtering is something that's very important. But how are you going to identify that? Well, typically, you would expect to see a basic IPv6 header, and the next header would be 58, which would be the ICMPv6 packet containing the router advertisement. And your firewall would detect that, and it would say, okay, I'm dropping any router advertisements at the firewall, so I'm going to drop this packet. But again, a malicious hacker could come along and say, okay, well, I'm going to add an additional extension header before the ICMPv6 packet. I'm going to put in a destination options packet with some information in there. Doesn't matter what. So long as there is a destination options packet, then the firewall could quite easily receive the original packet, say, okay, I've got my basic IPv6 header, I'm happy with that. What's the next header? Well, according to the packet, the next header is 60. Okay, well, 60 isn't an ICMPv6 header, so I'm just going to allow that through. That's good, I don't have any problems with it. I don't identify any ICMPv6 router advertisement header in here. So it's important to make sure that, as we've said before, you can do the detection that's required to find these, and hackers can add one or more extension headers before the actual ICMPv6 header that the device is typically looking for. This could also be further complicated by adding fragmentation. So again, here we see the basic IPv6 header with a fragment and the next extension header, and beyond the fragment, the destination options. And so even if your intrusion detection system does identify multiple different extension headers, if it can deal with somebody putting in an additional extension header before the ICMPv6 packet header, sorry, will it be able to do that if it's fragmented? How will the host handle the fragments arriving like this? Will the host receive the fragments separately, one by one, compile them at the end, and only then discover that there's a router advertisement in here that should have been filtered out? So these are all things that need to be considered when you're thinking about extension headers. Again, we have RFCs, which state that fragmented neighbor discovery packets are forbidden. They shouldn't be allowed. They need to be detected and dropped by the firewalls or other IPSs. Other attacks with extension headers, Jad mentioned this right at the beginning, the header chain should go into the first fragment. So you should always expect to see the full header chain within the first fragment. And there are other recommendations to avoid these type of attacks in RFC 7113. But most importantly, and I said we'd repeat it, I'm going to repeat it again, make sure that your security tools are capable of inspecting the full header chain when you're considering IPv6, because the extension headers can be used in many, many different attack vectors. One more thing before we move on from this. So we've looked a lot at extension headers, but there are other protocols within IPv6 that are new within IPv6. One of those obviously is neighbor discovery. We didn't have any neighbor discovery protocol in IPv4. So when we're talking about neighbor discovery protocol, we've got neighbor solicitation and neighbor advertisement spoofing. So this can be done in the neighbor solicitation packet by changing the source link layer information within the packet to indicate that the neighbor solicitation is coming from somewhere other than it's actually coming from, and therefore any response to that neighbor solicitation will go to the wrong location. And exactly the same thing can be done the other way around by spoofing the target link layer option in the neighbor advertisement packet. This can be used as a redirection or a denial of service attack if the attacker is just targeting one device. If the attacker is actually targeting two devices on the network, then they can potentially perform a man-in-the-middle attack as well. Now, obviously, it's important to note that this type of attack can only really be performed if the attacker is actually on your network. This is something that's very, very difficult to do from outside of the network. But nevertheless, you need to be aware of NDP threats and you need to be aware of what steps you need to take to try and prevent them. So the first, the most obvious thing is the hop limit. You can almost consider this to be something that's built into IPv6. If the hop limit is anything other than 255, then any NDP packet should just be immediately discarded. Other NDP vulnerabilities you'll find documented in RFCs 3756 and 6583. There are many of them. They are varied. But as I say, most of them can only be implemented once an attacker is already within your network and is already able to do things on the layer 2 and layer 3 within your network. All of the specifications will say to use IPsec. Wouldn't it be nice? Unfortunately, the whole public key infrastructure for everybody to run IPsec throughout their entire network just simply isn't in place at the moment. We also have SEND, Secure Neighbor Discovery. Again, it's a lovely idea in theory. It would certainly prevent a lot of the threats that we see out there today. But again, practically, it's not something that's widely available at the moment. A lot of operating systems still can't support it. So there's a lot of work still to do in this area. But what's most important, what you should really take away from this is that if you are concerned about security in your IPv6 network, pay a lot of attention to the new protocols that are being introduced. ICMP v6, NDP, MLD, DHCP v6. These are all things that you didn't have running in your network before. And so they will all need to be addressed right from scratch when you're talking about IPv6 security. Okay, on to the next statement. So IPv6 support is a yes/no question. So does it support IPv6? Yeah, of course it does. Is that good enough? Not really. I would argue no. If somebody says, yes, this supports IPv6, I have a few follow-up questions to that. How does it support it? To what extent does it support it? Can it handle this system that I use? Does it also support it if there are multiple extension headers? Does it support elements of multicast listener discovery? There's lots of detail here that we really need to be concerned about. There are many immature implementations out there of IPv6. So is it implemented the way you expect it to be implemented? The feature may be there, but how about the implementation of that feature? Is it going to be interoperable with the different components that you have running within your network? And of course, this is a topic that's familiar to anybody involved in security. You can have some security guidelines, you can have some security definitions, but it absolutely depends on your own network, what you want to be deploying there. Everybody's network is different. And how can you go about looking at this? Well, there are tools available out there that can help you with this. So you might select what you want to use, and then you want to do some testing. And you can do some testing using some widely available security tools. Oh. I'm missing a slide. Unexpected. Okay, but there are many security tools available out there. You've got packet generators, you've got packet sniffers, you've got specialized toolkits specifically for IPv6, like THC IPv6, the IPv6 toolkit. There are scanners out there that you can use to scan your network and look for devices which are perhaps numbered in a way that you weren't expecting. Jad talked before about using words and common numbers in your network. If you don't want to have these, you can use scanners to try and identify them. And of course, the intrusion detection and prevention systems that you would expect. One of the most important documents when you're looking at security in your network, in fact, when you're looking at implementing IPv6, even regardless of security, I would say is RIPE 772. This is a document that's been prepared by members of the community, and it talks about what you should expect to find and what you should ask for when you're talking about vendors about your IPv6 network. Now, it takes all of the devices in the network, breaks them down into different categories so that you can go through them and say, okay, have I considered this? Do I need to consider this in my network? So first of all, looking at hosts. Am I going to run IPsec on my hosts? Have I filtered my hosts so that they don't use RH0, router header 0? That's been deprecated, so we don't want to be seeing any of that. Have I dealt with overlapping fragments? Have I considered atomic fragments? How about neighbor discovery fragmentation? Is there something I need to do there? Have I considered the entire header chain? Is everything considered there? Do I have stable IDs? How have I chosen to implement the stable IDs? Is it the semantically opaque IDs that Jad was recommending earlier, or have I chosen another mechanism for doing this? How about address extensions? Are there things I should be disabling in my hosts because I'm not using them? If there are parts of the IPv6 protocol that you're not using, by all means disable them. From a security point of view, that's always your best bet. Then beyond the hosts, we start looking at switches. Of course, you need to take all of the host considerations into account as well, because your switch can be a destination and therefore a host. But on top of that, do I need to implement any new IPv6 access control lists on my switches? Do I want to have some first hop security there? Do I want to implement RA guard to prevent rogue router announcements? Do I want DHCP-v6 guard? That's a hard one to say early on a Monday morning. Am I concerned about IPv6 snooping? Do I want to be inspecting the IPv6 packets that are coming in and out of my switches? Am I using source or prefix guard here? Do I want destination guard? Do I want to do an MLD snooping? Do I want a DHCP-v6 shield? All of these are things that you need to consider around the switch. Even though they're usually layer 2 devices, sometimes layer 3, there's a lot of additional considerations to take into account here. On the routers themselves, again, they can be hosts. You will definitely want ingress filtering and reverse path forwarding. You will want DHCP-v6 relay, perhaps. If your router is acting as a DHCP-v6 relay, then there are additional considerations and RFCs specifically documenting those. How about your routing protocol? Are you using OSPF v3? Are you using ISIS? Are you using multi-protocol BGP? Which additional considerations do you need to take into account? Again, they will differ depending on what you're using in your network. Then there's the security equipment itself. Again, it can be a host. Can it identify everything it needs to in the header chain? Is it supporting extension headers and the inspection of them? Does it have the fine-grained filtering necessary for ICMP v6? So can it pick everything that it wants to pick out of ICMP v6? Can it filter what you want to filter? Can it allow what you want to allow? How about encapsulated traffic? Can it inspect that and make interventions where necessary? And of course, IPv6 traffic filtering. And of course, lastly but not leastly, the CPE itself, the routers, the security equipments, and DHCP v6 servers Are you using this? Are there any privacy issues associated with using these in this way? So if we take a look at a broad network here, on the forwarding plane, we've got native IPv6 traffic, which is coming in. It will need to be filtered at the firewall. You'll have intrusion detection and intrusion prevention systems, which will be inspecting the traffic. And you'll have the first hop security on your switches. Then over on the control plane side of things, how are you handling your BGP? Which IGPs are you using in your network? Do you need to take into consideration neighbor discovery protocol and multicast listener discovery here? When you get down to the switches and devices themselves, are you using NDP here? Are you using DHCP v6? How are you addressing all of these devices in your network? Do you need to put any additional controls in place to make sure that these lower level protocols aren't being abused? Okay, the next statement. IPv6 is not a security problem in my IPv4 only network. So many people might say, well, my network is only designed and configured for IPv4. I haven't turned on any IPv6 in my network, so I'm good. Yeah? Anyone feeling comfortable with that? I hope not. If you are feeling comfortable with that right now and you're running IPv4 only network, you might want to go back and check a few things. Because in all reality, IPv6 is not only available, but is the default in many hosts. Also in servers, other devices in your network. Generally speaking, you will power them up and they will immediately start communicating over IPv6. Whether you've enabled this or not, whether you thought it was there or not, and this can generate a lot of unwanted IPv6 traffic on the network. And it's very important that you protect yourself right away from day one. You might start seeing VPNs or tunnels popping up over IPv6. If the host can speak IPv6 and the destination can speak IPv6, then you might be able to encapsulate that and send it via a tunnel or a VPN. You might have undesired local IPv6 traffic. So the MLD, the multicast listener discovery, which your devices are using to look for messages from routers and other devices on the network, that will all be going over IPv6. If you're not aware of this, you might have unwanted traffic in there. There might be some kind of transition mechanisms going on. There might be some transition mechanisms that you didn't intend to be there, which are automatically configuring themselves. And of course, you'll get problems here with rogue router announcements. If you think that your network isn't doing IPv6, but your routers are sending out IPv6 router announcements on the local link, and devices are receiving them and configuring a connection with them, you could have devices connected through your router externally with absolutely no visibility to what's going on. So it's very important that you make sure you're aware of this and essentially treat your network as dual stacked. Every network needs to be considered to be dual stacked today. What that means is that you will have a bigger attack surface area for your network. If it's IPv4 only, IPv6 only, then your attack area is a lot smaller. If it's dual stack, it's a lot bigger. You need to make sure that you're protecting things correctly. It means that you will have globally unique addresses. You can't rely on NAT within your network to obscure things anymore. Everything is globally unique and globally reachable. And it's also possible that a malicious attacker could use one version of IP to attack the other. So when you're looking at these things, make sure that you're protecting IPv6 at exactly the same level, at least the same level that you're protecting IPv4 in your network. So everything that you do for IPv4, make sure you're doing it for IPv6. Make sure that you filter end to end. Filtering takes on so much more importance in dual stacked networks. You must be filtering everything correctly. You must be filtering router advertisements at your edges. You don't want to be sending these out into other networks. And don't trust IPv4 only. There's no such thing anymore. It's not possible to run a purely IPv4 only network. unless you want to be going around manually controlling every single device that anybody introduces into your network. And I'd like to think that those days are long gone. So last but not least, it is not possible to secure an IPv6 network. There's just not enough resources or features available in order to secure an IPv6 network, so it's not worth even bothering. So this is a statement that people tend to come up with when they really believe that IPv6 is something completely different to IPv4, and that they only need to start thinking about it when they start using it. And those people will often say, yeah, well, I wanted to use IPv6 a few years ago, and I spoke to some people about it, and they said, yeah, there's no real resources yet, and the features don't work properly on the firewalls. So yeah, just don't worry about it for now. Those days are very much gone. These days, we need independent IP security policies. There are best current practices available, there's resources, and there are features. We've already covered a lot of them and talked about a lot of them today. I want to repeat something I've already touched on, that whilst IPv6 is similar to v4, when it comes to security, there are some things which won't change at all. There are some things which will change with v6, and there are some things which will be entirely new. Let's take, for example, router advertisements. This is an example of things that when people say there's no security options available, well, we just simply go and look at router advertisements. What can you do to prevent rogue router advertisements? Well, first of all, you can monitor the link, and you can see advertisements coming from places they shouldn't be coming from. That will be your first indication that there are rogue RAs in your network. Secondly, you could use send. If you can get it to work, great. Use secure neighbor discovery. That will prevent rogue router announcements. You could go back to manually configuring everything in your network and completely disable auto configuration. That would be a mechanism to prevent rogue router advertisements. Probably a painful one I wouldn't really encourage anyone to pursue, but especially if you have a part of your network that needs to be particularly secure, that might be an option. You can use host packet filtering. You can use the router preference option, which allows different preference levels for router advertisements. And you could set the ones that you know are correct to a higher preference than others on the network. You can use access control lists on switches. And you can use mechanisms like RA Guard, which use router advertisement snooping on the switches. So this is 7 different possible solutions which could be used to prevent rogue router advertisements on your network. So to say that there aren't security options available for IPv6 definitely isn't correct today. There are lots of options available to us today. Which ones you want to use very much depend on your own network. Another example would be the first hop security on switches. Lots of different techniques available. RA Guard, which I just mentioned, which is essentially snooping on the interfaces of the switches and saying, I am going to allow router advertisements on this interface because that's where I've configured my router, and I'm going to disallow them on all other interfaces because I know that I'm not going to put any routers there. That would be one technique available. You can use additional snooping and neighbor discovery inspection and DHCP-v6 snooping. You could look at source and prefix guard. You can set up destination guard. You can do MLD snooping. All of these mechanisms can be used as first hop security on the switches. So again, there are options here. If you want to think about, okay, well, how about my routing security? How am I going to deal with that? Well, all of the various protocols, your various IGPs, so going from RIP-NG through OSPF-v3, ISIS, multi-protocol BGP, they all have authentication options available. IPsec for RIP-NG, OSPF and ISIS, I think, are quite heavily used as IGPs, and there are options available here, some deprecated, some still optional. And multi-protocol BGP, plenty of possibilities here as well. So there's no one security for IPv6. There are multiple options depending on which type of security you want to implement in your own personal network. Thank you. So in conclusion, there are options available for everything that you want, depending on how you want to use them in your network. And I want to finish by just putting this slide back up again. As I said before, one of the most useful documents available, whether you're setting up your IPv6 network from scratch, or whether you've already got one up and running and you want to dig more deeply into the security options available to you, I strongly recommend taking a look at RIPE 772. It's been written by people with decades of experience with IPv6, and it absolutely goes into a huge level of detail in all areas of your network, all categories of devices, and all possible options. With that, I want to say thank you very much. If you've got any questions, please feel free to come up to the mics or feel free to approach myself, Jad, Gerardo through the rest of the event. And yeah, and online, obviously, we're available online. And just before I hand over to Gerardo for the quiz, I just want to say this has been a brief introduction to IPv6 security. What I strongly recommend you do if you want to take it further is go to our academy, academy.ripe.net. We have a self-paced e-learning course there for IPv6 security. You can then, if you want to, join one of our more extensive webinars or face-to-face courses. And finally, when you feel you're fully ready, you can go and take one of our certified professionals exams and then receive a certification on IPv6 security as well. With that, thank you very much.
Great. Don't applaud yet. You have to take your exam. We'll see if we'll be applauding. So, I guess you know the drill. I'm going to start sharing my screen here, if they allow me. All the slots for the requested. Oh no. Yes. Good. So, can you see that? Does it look familiar? Yes, because you'll be seeing a lot of this week. Now, this exam is just to see if everything that we've been explaining has come through, and you can check it yourselves, okay? We're going to have 8 questions, 1 per myth, and I'm going to show you 4 possible answers. Now, you're going to have to choose the correct answer as fast as possible, because I'm only going to give you 30 seconds to answer. Oh no, what happened? Did I get kicked out?
Just share it again, Gerardo.
Yes, I'll share again. Here we go again. That doesn't happen in a real exam, right? Anyways, so you have to go to www.kahoot.it. You put in the PIN number 9124973 and put in your nickname. If you want to earn a free voucher to take a certified professionals exam, you should include your registration number for the RIPE meeting so that we can validate your result. We have here on premises Mark Vuldings, who is helping along with my colleague Ulka to take the exams today. But you can get a voucher to take the exam at your own pace. So I'm going to give you only 30 seconds to find the correct answer. And these are long answers. They're not like in my other quizzes where I do a really short answer and you can really press fast. And if you press random, of course, you'll probably get the wrong answer. So are we ready? It's like when you're taking a real exam, right? Are you ready? Like, I guess so. I studied last night, but now I don't know. I see some people still joining. Let's give them a couple more seconds to join. I like the names. I was late. Very fab. I like that one too. And well, they all fall down. Anyways, time to put your skills to the test. I'm going to start this quiz. Oh, I don't know. Wow, it goes up and it goes down. Oh no. I'm glad we have time. 68, 69. I'm special. You are special. Everybody's special. Okay. I'm cutting it in 3, 2, 1. Let's go. So the first question appears in a couple of seconds, and it is: IPv6 is fully supported in every IPv6 enabled device, says the vendor. So which statement is a fact? And the good thing about this exam is that you get the results immediately. You don't have to wait until the end. By the way, only if you get 8 answers correct do you qualify for a voucher. Then you're worthy. Very well. It seems we got 3 people who thought less updates for IPv6 than for IPv4. That means IPv6 is fully implemented. What do you guys think? Nonsense, right? In reply to IPv6 is fully supported in every IPv6 enabled device, you should never say, I mean, this statement is completely wrong. Devices either support the full IPv6 stack or they don't support it. I think Matt just explained that you can have some partial implementations or some people who implement the stack in a different way. So I'm not going to name shame anybody. And then not necessary to check specifications of vendor's IPv6 implementation. It's not necessary to check specification. I think that's the first thing you do, right? When you get your specifications, you check, does it do what I need it to do? Always check the specifications. The correct answer in this case would be some IPv6 stacks do not implement all the specifications in the same way. And that's why we should check the vendor specifications. So well done to those 48 who paid attention. On to the next question. The ranking doesn't matter. Later on, it will, but today it doesn't matter. Number 2, it seems there is not enough time to scan the addresses in an IPv6 network. So which of these statements is true? Only 3 seconds left. So, most of you got the answers right. 8 of you said it is actually possible to brute force scan a 64-bit address space. Yeah, not in your lifetime. So yes, even though you could theorize, if I lived for 1,000,000 years, I would do it, but sorry, that's not the truth. Assigning addresses with DHCPv6 means a scan in the network will be difficult. I think when we talked about all these protocols and having DHCPv6 actually gives information about what's happening on the network. So it makes scanning a network much more easier. Running a dual stack network makes it harder to scan active addresses. Do I have to go into that? You have already IPv4 running there, which is easy to scan. So you could just pick up all the IPv4 information and tie it into the IPv6 one. So the correct answer in this case would be, by knowing how an IID is generated, you can do an intelligence scan, which is what we were talking at the beginning. By following these common patterns and stuff people always use, we can actually do a much easier scan. We do an intelligence scan. On to our next question. If somebody says the IPv6 protocol is more secure than IPv4, what should be the reply? No copying. So I think the first myth we had was saying that IPv6 is more secure than IPv4. And the correct answer would be always knowledge of the protocol is the best security measure. By knowing about the protocol, you can already take a lot of steps to securing your network. IPv6 is available for IPv4, so it makes IPv4 more secure. That's nonsense. It's in IPv6, so if it's in IPv4, it just cancels each other out. IPsec is a must, which makes IPv6 more secure. No, we said that IPsec is a should, but not a must anymore. So it can be there, it might not be there. There is more experience with IPv4, so that makes IPv4 more secure. No, I don't think so. Even though IPv4 has been around a lot longer and we've been able to iron out a lot of the security holes in there, it doesn't make it more secure just because we have more experience with it. Actually, by having less addresses, it makes it more easier to scan. I love seeing the scoreboard changing places. Question number 4. Because there is no NAT in IPv6 and there is end-to-end reachability, an IPv6 network feels less secure. So what is a fact? So using GUAS global unique addresses and not having NAT makes the network reachable to everybody. Can I get a nonsense? Nonsense. Yeah. Using hard to guess IIDs is enough security for a network. I don't think so, right? We're just taking part of the whole security thing and fixing it, but we're leaving a whole bunch of other attack vectors open. So that's nonsense as well. Filtering all ICMPv6 messages on a link will harden any IPv6 network. Totally, right? It'll take it like completely offline. Exactly. That's the ultimate hardening, right? We just leave that host there disconnected from the whole world. So the correct answer in this case would be filtering packets protects a network from unauthorized malicious access. So not having NATs doesn't mean that it makes it less secure. You just have to filter correctly. On to the next question. So if someone knows IPv4, they can secure an IPv6 network without any changes in their security policies. What is not true? Yeah, for those of you that just went and pressed randomly a button, that's wrong. Don't you love that awkward silence during the exams? I think I know this one. Oh, no, wait, I don't. Oh, wait, I do. So routing and switching in IPv4 and IPv6 follow the same principles. Yeah, they do, but that doesn't mean that you can just apply all your IPv4 knowledge and just say, okay, I've secured my IPv6 network. IPv6 has a whole new addressing architecture that needs consideration. True. Many security practices in IPv4 can be used again in IPv6. Yes, that's what Matt finished with last. So what's not true is IPv6 is the same as IPv4, but with 128 bits. No, we just told you about extension headers. We just told you about ICMPv6. We just told you a whole bunch of things that makes IPv6 different from IPv4. So yes, you can recycle some IPv4 policies, but you have to also look at IPv6 with fresh pair of eyes. So that is not true. Question number 6. IPv6 is not backwards compatible with IPv4. Why should anybody worry about IPv6 security in an IPv4 only network? Why should anybody worry? Whoa! Almost everybody got this one right. So let's go one by one. BGP filters on the border router for all IPv6 addresses is enough security. So, right, if we keep BGP on the, IPv6 on the border, don't let it in, that just makes us completely secure. Well, somebody has never heard about tunnels. Nobody should worry, making an IPv6 connection to an IPv4 host is impossible. Right. It is not possible to have a dual stacked host in an IPv4 only network. Yeah, some people might discuss, well, if I disable IPv6 anywhere, yeah. How do you take full control of a host? Unless you have full control of the host that they can't start up any kind of IPv6 stack, tunnel, anything like that. That's true. So the right answer is IPv6 can be available on a host that is connected using a tunnel. 6 and 4, I've had it for several years. So that's the way. You should worry. It makes too much noise. On to the question number 7. There are so many specifications in IPv6 and there is no knowledge available. How can someone secure an IPv6 network? Well, for starters, you're here at this tutorial, so that's a good starting point. Again, most of you got the right answer. By trial and error, an IPv6 network can approach IPv4 security. Yeah, we could do that, right? So how much time do we need for trial and error? Anybody? The next 20 years, maybe? Yeah. So wait until the first BCPs on security are published and then deploy IPv6. Yeah, they've been published already. So yeah, you should be deploying IPv6. Configuring IPsec for OSPF version 3 is enough to completely harden an IPv6. Sorry, I have to laugh. Harden an IPv6 network. That is total nonsense, but I love it that 4 people said it was correct. The correct one is use security policies that are not dependent on the IP protocol. What we said, IP independent security protocol. So what you do in IPv4, you can also do in IPv6. Use the same principles for both protocols. Not that difficult, is it? Let's go on then to our last question. Nobody knows much about IPv6, so an IPv6 network has security through obscurity. What should be the reply to that? So, I love it. A lot of people got the right answer, but let's go with the wrong answers first. The lack of IPv6 deployment means no attacks coming from IPv6 hosts. What do we call that? Fallacy. Logical fallacy. No. There have been few documented attacks, and that proves IPv6 is secure. What is that again? Fallacy. Wrong. Logical error. There have been no attack vectors discovered in the IPv6 protocol. Just not true. Again, fallacy. Yet 3 people thought it was right. So the right answer would be, even if there are only a few IPv6 networks operating, you must be prepared. As long as there's one other IPv6 host out there, expect an attack, be it willing or unwilling. So that was the exam. Let's see who got the most points, not all the correct answers. I can check who got all the correct answers. You can also check how many correct answers you have in the Kahoot result. So number 1, we have James, 8 out of 8. Where is James here? James, congratulations, you're smart. We, Marcos, 112, 8 out of 8. Again, congratulations, you're also smart. And Jay, or you have a good memory. Jay Hindley, 8 out of 8 as well. In the house? No? Online probably. Well, congratulations to Jay as well. You're also someone with good memory. So that brings us to the end of our tutorial and exam. Have you learned anything new? Yeah? Good. And the good thing is because you first take the tutorial and then you can check your knowledge with an exam, that is part of the learning process, being able to corroborate. Did I correctly understand what they were telling me? By being able to validate your knowledge, that's how you actually firm it in. So I'd like to encourage you all, if you want to sign up for taking a Certified Professionals exam. We have a room here, and it's not going to be as easy as this one. So that will really put your knowledge to the test. But the good thing is that you'll get a badge that will prove that you know all of this that we've been talking about. So thank you everybody for staying and paying attention, and it's lovely to see you all here in the room and online again. Thank you. Enjoy the coffee break, and I will see you at the afternoon Kahoot.
Das ist der großen Auftritt heute später? Ja, ja, heute gleich nach der Opening, glaube ich, bist du dran. Ja, ja. Ja, super. Gut.
Hast du die angesehen?
Noch nicht. Gestern Abend. Hey? Hey, Manu? Oh, it's here on the lectern. It's a big thing. So, oh, is this on?
Yeah, it really depends what people are showing.
Is this already on?
And this one.
Yes.
It is.
It wasn't a minute ago. Um, Fine. Okay, everybody, welcome. Good morning. So we're going to wait a few more seconds, see if people are coming in. This is the newcomers session for RIPE 84. I saw we have quite a number of newcomers registered. I don't know if they're all here, but this is an opportunity for you to find out a bit more about RIPE and the RIPE NCC and also this meeting, how to make the best out of it. So yeah, again, welcome. This is your first meeting. This is RIPE 84. Our first meeting took place in 1989 in Amsterdam. So we've come quite a way. My name is Mirjam Kühne. I am the chair of the RIPE community since September 2020. So this is actually the first physical meeting I'm chairing. We've been like online and remote for the last 2 years. So it's quite exciting to be here in an actual meeting hall and see real people and not just a screen in front of me. Actually, I'm from Berlin, so I studied computer science here at the Technical University. It's great to be back here in my hometown. And I work for the RIPE NCC and I work for Internet Society, done a lot of community work, and now I was selected RIPE chair. And we also have a vice chair. I don't know if Neil is in the room. Neil O'Reilly, he has been selected vice chair at the same time in September 2020, and he's been around for even longer, and he's been chairing a couple of working groups also in the RIPE community, and was that did some academic work and networking operations at the university in University College in Dublin. We put our email addresses on there, so in case you want to reach out to us, but we're also around here, of course, all week. Yeah, just a blast from the past. We've been looking through it. I mean, I don't know if you remember, any of you remember the machine on the left. Actually, I was an Atari person, so I never had one of those. When I was studying, I had an Atari at home. But maybe more interesting is the one on the right, the map. It's actually the internet in Europe in 1990, pretty much around the time that the RIPE community started. They're mostly academic networks or like the national research and education networks on that map. And they would update this map, over time. Every RIPE meeting, they would go like, oh, we've added another academic institution here, another NREN there. And so these were really the kind of the founding institutions, founding people of the RIPE community at the time. Just a quick question to see who's what you know already. Do you know the difference between RIPE and the RIPE NCC? Put up your hand. Do you know the difference between RIPE, NCC? All one same thing? Yeah, Ollie, you know it. No staff, please. But so, all right, so that's good, and because we're going to go a little bit more into detail about that. So I'm going to cover the RIPE community first, and then Hans-Peter Holen, the managing director of the RIPE NCC, will cover the second half about the RIPE, of the RIPE NCC, obviously. I can't see those people who are online and following this online. I hope that my colleagues from the RIPE NCC are keeping an eye on it, because there might actually be people on chat or in the Q&A, and that also participate in the session, which is great. We have a lot of people online at this meeting as well. So if there are any questions from the online participants, Xavier here will help me out. Right, so what's the difference? So RIPE stands for Réseau IP Européen, European IP Network, and it was formed in 1989, kind of to promote IP at the time and to promote the use of the internet. And mostly what I showed you earlier, these institutions, they wanted to exchange data, research projects, studies, and they saw this new internet protocol and this internet thing, and wanted to use that among their universities mostly. And so they started getting together and coordinating some technical aspects in between the networks. Now, who has what IP address? How do I contact you? Who's the contact person on your side in case things go wrong? And a lot of things went wrong at that time still. And it was open to all. So it started as a small group, basically to do coordination, technical, agreeing on technical parameters. And still until today, it's open to anybody. It's not a legal entity, and it's mostly doing information exchange, technical coordination, and also important developing policies, basically agreement between or among the community members and how to deal with, for instance, IP addresses. How many do you get? What do you have to provide? What's registered in the database? So these kind of policies are developed by the RIPE community, by this open community that you're a part of here. On the other hand, we have the RIPE NCC, which stands for Network Coordination Center. So the RIPE Network Coordination Center, and it started a bit later in '92, and primarily as a secretariat for this RIPE community. For instance, to organize these meetings and host mailing lists, develop the database I just mentioned. But then quite quickly afterwards, people felt like, since we have the secretariat already in place, wouldn't it be nice to also have them distribute the IP addresses? And so that's how the RIPE NCC then became the first regional internet registry, the IP registry. And that's also what they're mostly known today, even though the RIPE NCC provides a lot of other services that are open to others, to non-members. Because the RIPE NCC, contrary to the RIPE community, is a membership association, and the members pay the NCC for the services, and they also elect the board and their staff, looking after all the services at the NCC. And the RIPE NCC then takes, for instance, the policies that are developed by this open community and implements it and kind of enforces their members to follow the policies that are developed by this open platform, this open community here. It's quite an intricate relationship, but we have our own areas of expertise and working really well together. So you will hear more about this later on. So dive a little bit more deeper into the RIPE community. We have a number of working groups that do work throughout the in between the meetings, but they're also going to meet here during this week. I'll show you in a bit how the week looks like. So we have 12 working groups at the moment. Some you might think, yeah, that makes sense, address policy, routing, database, but there are some others that may be a little unusual. For instance, cooperation. That's a working group that has been set up specifically to also involve kind of the non-technical community members. So it's trying to, or it's set up to interact or help engage with the community, government representatives, law enforcement, and bring them together with the technical community. The IoT working group, that's a relatively new working group. And then we have also a working group called RIPE NCC Services Working Group, which is really, almost like the glue between RIPE and the RIPE NCC, or one of the really important interfaces, because that's where the RIPE NCC reports back to the community, and also where the community can provide feedback about VIPE NCC services. Not only there, but that's kind of the formal place where this can happen. And you see a link there with some videos. Some working groups have set up some introduction videos, and there's also more information about each working group on the ripe.net website. Yeah, each of the working groups have mailing lists. When I said we started in the 90s, so that's our preferred method of communicating today. And one of the benefits of that is, of course, you can find everything in the archives, right? You can basically look back to old history and see what has been agreed and discussed. Has something already been discussed before? You know, maybe you want to read up on that. So you can subscribe to these working groups. They're all, these mailing lists, they're all open and free, and all the archives are publicly available. And, you know, look at the list of working groups, see what you're interested in, and then maybe look at the archives or subscribe to the list and then follow the work of the working group. And maybe a good place to start is the RIPE list, which is the overall kind of list for all RIPE related announcements. Also during the week, we'll be sending some information to the RIPE list about the meeting, and you can subscribe to that. There is some information on it. All these slides are already up on the RIPE 84 presentation archive, so you can find all the links there. Right, so let's look into this meeting, actually, see how you get through the week. And this is the meeting plan. I don't know if you can read it, but it's also on your badge, and it's in the it's on the website. So today and tomorrow is mostly plenary sessions, and then on Wednesday, Thursday, the working groups meet, mostly in parallel, so you have to choose. And then on Friday morning, there's another plenary session, and then the closing ceremony, closing plenary. We also have some other things on the agenda, like the birds of a feather. Today and tomorrow, there are 2 birds of a feather meetings, like it's just a one-off meeting where people get together talking about a specific topic that they're interested in, and it's open to anybody. So have a look at this meeting plan on the website. It's all interactive, so you can click on it and you see the agendas of each session. And tomorrow we also in the evening, there's a task force of the best current operational practices group, and they are coming together to look at some best current practices documents for this whole community, like informational. It's not a policy, but it's more like things people agree on as guidelines and to follow. And tomorrow, I don't know if I have a slide on that later on, but there's a Women in Tech session during lunch, which I would also like to encourage you to participate in. And we'll have some interesting presentations there about the gender data gap, and also some measurements that we've done during the RIPE history and during the last tens of meetings. And so it's open to anybody, and you also get lunch. Well, there's a number of ways you can participate, and this is also interesting for online participants here, because you're going to be on the MeetEcho platform. And also, I think here in the room, you've also received a mail with a unique link to that MeetEcho tool, if you will. So you can ask a question, you can put a question there, or you can raise your hand in the Q&A on that platform, and then the chair of the session will see that on the screen, and they will be able to, give you a microphone time. There's also in the MeetEcho app, there is a Q&A button you can use to type in your question, and then the chairs will read that out. And there's also a chat functionality if you want to chat with each other, or you have just a general comment that it's not a question you don't want to have read out. Yeah, why participate? Well, you're already here, so you have already made a decision to participate and to come to this meeting. But just to summarize, or to stress some points here, that I think it's a really great group of a lot of experts that come together here, and you can really dive into a lot of history and expertise and a lot of technical knowledge and passion that's been going on here for 30 years already, and by that, of course, also build your professional network. and meet new people. But contrary, also, we would like to hear from you. I mean, this is really good to have so many newcomers at the meeting, and I hope you all continue to participate in the meetings in the RIPE community, either online or maybe see you at the next meetings, because we also need to hear from you and what your concerns are, or how you see the internet develop in the future, because that really helps us all to keep the internet open and free as we want it to continue to be, of course. To come back to the meeting, this is the program committee. They are responsible for putting together the agenda of the plenary sessions that I showed you on the meeting plan. I think we have a number of those program committee members in the room. So they would really like to hear your feedback also during the week. What do you like about the agendas, and do you like, if you have any ideas for next time? The task of the program committee is basically to put together the agenda for the plenary sessions. As I said, they're selecting the presentations that are submitted to the system, and they're actually elected by the community. And there are elections going on this week, so there are two new seats, or 2 seats will become empty, will become available on the PC, and you can all vote for new members, and they'll be made known during the week. And then, yeah, you can vote. Another thing the PC would like you to do is to rate the presentations, because again, that helps them to further improve the program over time. And you can go onto the website and go to the presentations archive, and then give some feedback and rate the presentations. You have to log in there. You have to create an account and log in. That's really easy to do. And you can even win a prize if you do that at the end. So maybe that's an extra motivation. This, I don't know if this is actually happening, because this is only going to be a social, I think, later today. If you have an academic background, or you're interested to meet up with other people that come from research networks or academic institutions, they'll be meeting. It says, yeah, this is today, this is correct. They'll be meeting here just informally. And there is the Women in Tech session I already spoke about. Sorry about that. But yeah, here's more information on that. And hopefully see many of you there on Tuesday during lunch. And not in this room, but in the other room, in the side room, this way, I think. And we also have a RIPE code of conduct. We have a code of conduct for the RIPE community, but also for the meetings, but also other communication channels. And this is just a summary here of the code of conduct. It's a lot longer. You have hopefully seen it when you registered, and it's also on the RIPE meeting website. And we basically, want you to tolerate each other and show respect, independent of background, religion, culture, what have you. This is a very diverse community in some aspects, not so diverse in others. We're still working on that, hence the Women in Tech session. But there, we would like to, hopefully all feel like comfortable and safe here during the week. And there's the website, yes. And should there be anything that you feel uncomfortable about, or you think this really violates the code of conduct, or something that you don't like, you've been mistreated, we have these wonderful people here that have been trained as trusted contacts or confidants, and you can go to them and report any anything that you experience that you don't like. And we have actually one of them here in the room, Leah, she's sitting right here. And so you've seen at least one of their faces, but the other people will be also around during the break, and you can find them. And there's also an email address, and all the information has been treated confidentially, so only they can see it. Some more on how to find each other, how to network with each other. There is a social platform or tool that we've been using during the online meetings called Spatial Chat, which we will also offer here at this meeting, so you can interact with those people who are at home or participating online. And we have some ideas also during the breaks how we can include the online participants a bit more into this meeting here. And there's an app on the phone you can use, a networking app, that you can find also attendees list and the agenda, and you can make appointments with each other as well. talking about, finding each other. There are some social events during the week, very important, not just a boring work, during the day, but there are some evening events. Today, there's a big welcome reception for everyone here at the meeting. It's here at the on-site. Tomorrow is a networking event in the evening, again, to get to know each other a bit better. And then on Thursday, we have the traditional RIPE dinner where we actually go somewhere else. There will be buses, and we'll tell you more about that. And that costs extra. There's a ticket. And if you're registered for that, you should find a ticket in your badge already. Social interaction is just so important. I mean, that's why I noticed we have so many registrations for this meeting. Everybody was dying to see each other again and to actually, have some proper face-to-face time, which is great. But also for the online people, we've organized some social events so they don't feel left out, hopefully. And this really, we're trying to make this a true hybrid event. There's a booth, a stand kind of outside that we're going to use during the week to kind of link the online people with the on-site people. And we also do like a little virtual dinner on Thursday, which was quite popular during the online session. So we continue to do that as well. Yes, we'd love to hear from you during the week also. There's a feedback form, but also you can follow the RIPE meeting on Twitter and provide us feedback during the week, or just share your impressions. And you can, of course, always come talk to one of us, like me personally, or Alexandra Voss. She's our main meeting organizer here. She will be at the registration desk most of the time. And there's also a whole team of like technical, administrative, and communication support in the background that you can talk to. Here's some mail addresses that you can use if you have any questions. And last but not least, this is actually the great team that will be around all week. That they'll be recognized by their red t-shirts. So Leah is also wearing a red t-shirt, so she has two roles. She's a meet and greet and trusted contact at the same time, which is actually a great combination. But there will be others. So be careful if you're wearing a red shirt. Not everybody who's wearing a red shirt is actually a meet and greet contact. There's also a stand outside. You can find them, and they know everything. They know where the sessions take place, where the toilets are, where you can find water, everything, and also, where the socials are. And they're all very experienced RIPE meeting support staff. So don't feel shy to go and ask. And I think that's my part. Unless there are any questions, we hopefully have some time for questions in the end. We have some minutes now if you want to ask anything now. Otherwise, I'll hand over to Hans Petter, the Managing Director of the RIPE NCC. Going once, going twice. Javier, anything online? No questions? Okay, well, we'll have some time at the end also for questions. Thanks so far.
So thank you, Miriam, and welcome everybody. My name is Hans Petter Holing. I'm the Managing Director of the RIPE NCC. The 5-6 years before I became the Managing Director of the RIPE NCC, I was RIPE Chair, so I was giving the first part of this presentation. This is the first physical meeting after I became Managing Director 2 years ago. So this is the first time I give this part of the presentation. So let's see how that goes. So the RIPE NCC was set up as the secretariat for the community, as you can remember. It's a membership organization run by RIPE NCC staff and an executive board elected by the members. We provide services and we implement policies. So we have a strategy, a 5-year strategy approved by the executive board last December, where the first objective is to support an open and inclusive and engaged RIPE community. So that's why you, as the community, set us up as a membership organization. And we do that by operating a trusted and efficient and accurate resilient registry of IP addresses and ASN numbers so that all of you can provide internet services on unique addresses. If the addresses aren't unique, your routers don't know where to send the packets and internet simply wouldn't work. We want to enable our members and community to operate one secure, stable, and resilient global internet. And in order to do so, we need to maintain a stable organization with a robust governance structure. And the only way to do this is if we attract and employ engaged, competent, and diverse staff. So the registry, we maintain the RIPE database, which is where you look up what resources are registered. We allocate and manage internet number resources, and if you're a member in LIR, you can log in and update these through the LIR portal. We do investigations for hijacks and policy violations, and we support and facilitate the policy development process with the community. And my colleague Angela will speak a bit about, will introduce herself at the end. We also secure routing with something called the RPKI, Resource Public Key Infrastructure. How many knows how BGP works? Quite a few of you. How many knows who RPKI works? Almost the same. This is good. So where is the slide? It's gone. Okay, I'll come back to that then. It should be after that. Okay. We also do information services where we develop and maintain internet measurement services. So we have a measurement network, RIPE Atlas, with more than 10,000 probes, and you can run your own measurements in that. So if you want to see how your website in Luxembourg is visible or has the network delays from Kazakhstan, you can set up those measurements in this network. But you can also look into others' measurement through RIPE Stats that also has information from the registry, the database, and RIS, which collects all the BGP data, and we keep that over time. So if you want to do research back in what the routing of the internet looked like 5 years ago or right now, you can do that in RIS and through RIPE Stat. And you can also look at a visual visual view of IP addresses on the IP map. We operate one of the root name servers in DNS. Normally we would say that we only do numbers. We do actually operate one of the root name servers, the KRoot, which is one of the 13 name servers. One part of DNS is the reverse mapping of IP addresses. So if you have an IP address and wonder what URL or what domain name, fully qualified domain name that points to, you can look that up in DNS as well, and we maintain that reversed map. And we also provide secondary services to our members. So if you are in need for that, we have offerings in that area. So here's the RPKI slide. Yes, so normally in BGP, you or your router would tell your neighbors that this prefix you can reach by sending packets to me. And the trouble with that is that if you think about it, then anybody can actually make that claim and send it in GDP. So that's why RPKI was developed. So we have a certification service where we can issue you a certificate that you can use to sign your route, so that when somebody receives a route, they can look it up in the RPKI repository where you publish your statements that these addresses are or can be authorized from this AS number. So it's really an infrastructure to secure BGP. Community and engagement, we want to make sure that you can meet and work together. So we arrange these RIPE meetings twice a year. We also do regional meetings. We just had one in Ljubljana, and we are planning other meetings locally in countries and around our service region. We offer training courses in person again, also virtual on the net, but also asynchronously to e-learning, so you can sit down and do training courses whenever you want. And in the end, you can also get a certification and take an exam so that you can document that you have these competencies. We contribute to public policy and internet governance discussions with governments like in the EU, but also in the Middle East and other parts of our service region. We contribute with facts about how the internet works and how to still be able to have an open, interconnected global internet. We publish and curate articles on RIPE Labs. So if you have interesting research or experiments or anything to share with the community, you can contact the RIPE Labs editor and have your content published there. And we run the community project funds, which is a fund where we actually give grants to projects that benefits the good of the internet. And there is a separate committee selected by the executive board with community members that makes these decisions. To manage the RIPE NCC, I have a management team with me. Felipe is the Chief Operations Officer. He is running the registry and software engineering to develop the systems supporting the registry. Kaveh is the Chief Information Officer, and he runs the parts of the organization supporting the information services and IT and so on. Hisham is my Chief Community Officer, organizing events like this and public policy interactions and the training and e-learning. I'm really happy to announce that I have signed a contract with Eleonora as our new Chief Information Security Officer. She's not here yet, but she will start on 1st of July. So that is part of a ramp up of more focus on security and compliance in the RIPE NCC. We also have a Chief Legal Officer, Athena, an HR Director, Caroline, a Finance Manager, Simon Jan, and a Facilities Manager, Regina. And to glue all of this together, I have an Executive Assistant in Daniela that facilitates work for the board and helps me manage the RIPE NCC altogether. And she's sitting at the back there and waving. So if you want to talk to her about how the RIPE NCC really works, then you can do that. The executive board, the chairman is Christian Kaufmann, the treasurer is André Philippe, the secretary Piotr, and then the board members Remco, Maria, Raymond, and Job. We have a service desk out here, so if you have any question and want any help from us, you can contact them. We have a general meeting on Wednesday. This is the formal general meeting of the RIPE NCC Association. Only members can participate. You must register separately, and members can vote online. So also members that are not present at this meeting can actually vote on the GM. And if you have any questions about that, you can email agm@ripe.net. The policy development process is then managed by or supported by Angela. So I'll hand over to you, Angela.
Thank you. Thank you, everybody. I'm that one with a longer tail. I'm Angela Dallara, Policy Officer in RIPE NCC for the last couple of years before I started in 2014 as Internet Analyst. And I joined this organization really with a goal in mind to be useful for the RIPE community and to help have a smooth working of the internet. My role in as policy officer is to be a bit the trade union between the community and the RIPE NCC. You as a part of the community, because the RIPE community, as you saw before, is everybody, you can decide what the RIPE NCC has to do. And if you all agree upon a policy, I'm going to be very happy to assist the community in keeping track of the policy development process. It is a process that is very well organized, has different phases. I'm communicating which is the status of a proposal to the whole community and to the relevant working group. And I'm keeping track of how the discussion goes, and I'm helping eventually proposers to have a very well-written, together with the communication department, a very well-written proposal, and with any questions that can arise. Whenever you have a question about policies, if something is possible or not, if you can use your IP addresses in a certain way, if this is compliant with the policies, please don't be shy, come to me, send an email and ask your question. I'm gonna be very happy to assist you. Here you see that decisions only take place on the mailing list, so probably you are already subscribed to different mailing lists in the working groups of your interest. Please participate, say what you think, be part of the discussion, don't be shy. I mean, everybody has to know a new community, and of course there are people that are experienced, that they are there for many years and they know how everything works, but everybody has to learn, and everybody is welcome to provide his input. And in our community, decisions are made only on the mailing list. So your opinion counts. Whenever you post it on the mailing list, you are going to be listened to, and you will receive an answer. So if you have questions, of course, you can come back to me, but we have one policy proposal that is going to be discussed in the database working group on Thursday, and is regarding the publication of personal data in the RIPE database. So you can imagine that this is regarding everybody that holds resources and is looking for the holder of resources on our database. And possibly we will have another discussion. I mean, for sure we will have another discussion. It's not an official policy proposal yet, but it's going to be about the registration of IP assignments, IPv4, for IPv4. And this is going to be on Wednesday in the Address Policy Working Group. During the Address Policy Working Group session, I'm going also to give an update about what is going on in our region, but also in other RIR's communities. I try to keep in touch with, I keep in touch with all my colleagues in other RIRs, and we periodically update a document that is containing the main points of all our policies. So you can also make a comparison. All these details are going to be in my presentation on Wednesday. So I hope to read all your comments on the mailing list soon, and I'm happy to welcome you in the community if there's newcomers, and I hope you will enjoy the meeting. So now I give back to Miriam the microphone if you have any questions. Thank you.
Thanks, Angela. Yeah, policy development is a really integral part of the RIPE community from the beginning. So it's important, and Angela is doing a lot there to support it and make it smoother for the community. I wanted to make one comment about what you said about participating on the mailing lists, maybe just to motivate it a bit. Of course, you can also speak up and participate here during the meeting. I mean, that's why we have the meetings. But in order to make it fair to everyone and those people who cannot be at the meetings, all the decisions are made on the list. So things are usually then reconfirmed on the list, even if already a conclusion was drawn during the meeting. They are then confirmed and repeated on the mailing lists to make it sure everybody can participate, and also to have it in the archives, findable in the archives. So that's why it's important that Angela said that the main decisions are on the lists. Are there any questions at this point? There's a lot of information. I mean, if you're really new to this, then you might have some questions about this. In the room, no questions. You have to get up your courage during the week to get up to the mic and ask some questions. I hope to see many of you participate actively. Well, if you have no questions, then we have some for you. The last bit is coming now here. One of our colleagues, Gerardo, has prepared a quiz. Now, Xavier, are you running this, or? I know, but I don't know how to switch them on. So, Gerardo, are you there?
I'm here.
Woo, okay, good. Take it away.
If I can share my screen. There we go. Now, the questions for you, they're coming. we go. Welcome, everybody. My name is Gerardo Vivier, and I am your quiz master. This is the Newcomers Kahoot quiz. So the instructions are really simple. I have a series of questions for you and a couple of answers, and you have only 20 seconds to give the right answer. That is 20 seconds, not more, not less. So sign up with your registration number if you want to earn a goodie bag, and otherwise just sign up and have fun. We're gonna be starting as soon as everybody has been able to sign up. That's right, kitty cat, as soon as everybody has been able to sign up. And this takes a little while because we know that it takes some time to choose a really nice nickname. And you know what? I'm going to be giving a prize, a special prize for the person with the funniest nickname.
Whatever.
No, it's not whatever. It's an honor for me to be able to read out really funny nicknames. So I'm seeing already some of them out there. Remember to go to www.kahoot.it, sign in with the game pin 7961130, and then put in your nickname. I see 75 people. We have people online. We have people everywhere. It's kind of coming to a still stand. Whoa, more coming in. This is going to be fun, I think. About 85, 86, 87. Well, as people sign up, let me repeat to you what the game is about. I'm going to show you about 12 questions about what has been just presented. So we want to know if you paid attention. And after that, you're going to see 4 different answers, each one in a different color. And what you have to do is press the answer the fastest as possible. And the person who presses the right answer the fastest gets the most points in that round. And we're going to check at the end, whoever has the most points will be number 1. We have about almost 100 people signing in. That is amazing. And I think we have enough time to wait. Yeah, 100. We reached 100. Okay, I think we're going to start in 3, 2, 1. Let's go. This is the first Kahoot quiz of the whole RIPE meeting, and it's for the newcomers. We start in 3, 2, 1. First question, and it's multi-select. Where can you find the RIPE NCC support desk? Where, oh, where is the RIPE NCC support desk? Are they on Facebook? Are they on Snapchat? Are they in the coffee break area? Or are they on special chat? Spatial chat, not special chat. So where can you find them? If you go around and ask, you will find them in Spatial Chat, Facebook, Snapchat, or the coffee break area. And that's right. You can find them in the Spatial Chat or in the coffee break area. So if you need to talk to one of the RIPE NCC support desk people, just go around there. On to our next question. But before that, let's check the scoreboard. Matthias 13DE is at the first place. Eva Lauren, Maui, Flo, and Joe 5.
Initiate countdown.
No, we did that already. On to the next question. Who is the RIPE chair? Is it Niall O'Reilly? Is it Hans-Peter Holland? Is it the RIPE chair team? Or is it Miriam Kunis? So one of these 4 answers is the RIPE chair. That's right, Turkey. There's only one correct answer. But, of course, you could discuss it, but you won't. So choose one of these 4. If you don't know, you'll find out right now. Correct answer is Miriam Kunis. So Miriam is the RIPE chair, and Niall O'Reilly is the vice chair. Together they form the RIPE chair team.
5.
No, not 5. Scoreboard says Joe 5, Flo, and Windows 95 again, still booting, and IOB 6. Wait, what is that? IOB 6. Anyways, good nickname. On to our next question. True or false? Working groups discuss RIPE policies on mailing lists. Is that true or false? True or false? True or false? So RIPE policies on mailing lists, working groups discuss that. What is it? You only have 1 or 2 possible answers. 1 of 2 possible answers. And the right answer is true. working groups discuss the right policies on mailing lists. That's what Angela just said. Let's go on to our scoreboard. Joe 5 still in the lead. Windows 95 coming up or booting. Abe 6, Gary, and JP. Question number 4. Who makes RIPE policies? Is it the IETF? Is it RIPE? Is it RIPE NCC? Or why should I care? You know what that means, right? That answer can never be wrong. I mean, right. So, RIPE NCC, IETF, or why should you care? Who makes the RIPE policies? And of course, you're here at the RIPE meeting, so RIPE makes the policies. What does the RIPE NCC do? You'll find out soon. On to the scoreboard. Joe 5 still at the lead. Albert 6, Windows 95 going down, typical. Gary, Waldy, and on to the next question. Number 5, which of these is not a RIPE working group? Is it the open source, the big data, the IoT, or the DNS? So one of these 4 is not a RIPE working group, and I think we mentioned some of them. That's right, Fido. I said that the working group that is not a RIPE working group, and it doesn't even exist as a working group, is big data. We don't have a big data working group yet. Maybe an idea for the next time. Scoreboard says Joe 5, IOB 6, Gary, Nam, and Rolf 21 NL. Those are tongue twisters. And does RIPE have a secret working group? What is a working group? Now the quizmaster has to die. There are no secrets. There is no such working group. Or if it's a secret, we would never tell. Hello.
Good luck.
Trying to find out. Does RIPE have a secret working group? The right answer is, if it's a secret, we would never tell.
Are you crazy?
Of course, I would be crazy to tell anything about the secret working group. On to the scoreboard. Joe 5, Harry 12GB, poof, CF 432, and Ab 6. Question number 7.
Oh yeah!
What does NCC stand for? Is it Nerds Computer Club? Is it Network Carbon Copy? Is it Nordic Construction Copy Company? Or is it Network Coordination Center? Is it Network Carbon Copy? Is it Nerds Computer Club, Nordic Construction Company, or the Network Coordination Center? Yes, you got it right. NCC stands for Network Coordination Center. Scoreboard says Joe 5 still at the top. Harry 12GB, poof, CF 432 sounds like an interface. And now B6. Question number 8. Oh! What does the RIPE PC do? Select the working group chairs, ensure that there are parties and celebrations at each RIPE meeting, choose the presentations for the RIPE meeting plenary sessions, or choose the presentations for the working group sessions. This all sounds so difficult for me. Select the working group chairs, ensure that there are parties and celebrations, choose the presentations for RIPE meeting, and that one is the correct answer. Choosing the presentation for working group presentations is not the task of the RIPE PC. It's choose the presentations for the RIPE meeting plenary sessions. Scoreboard says Joe 5 still at the lead, Harry 12GB, poof, Catal, and Abe 6. On to question number 9. Which of these came first? The fall of the Berlin Wall, RIPE 1, the RIPE 1 document, Voyager 2 closest to Neptune, or the first working World Wide Web browser. So around the same time, all these 4 things happened, but only one of them came first. Which one was it? Yeah. You have to be a donkey to not know that RIPE 1 was published before any of these other historical things happened. So one piece of history at a time. RIPE 1 was the first one. Joe 5 still at the lead. That's 6. Harry 12GB, poof, and JP coming up and down, up and down, up and down. Oh! You need to become a member to join the RIPE community, the RIPE meeting, Hells Angels, or the RIPE NCC. I wouldn't know what you need to join Hells Angels, but in order to become a member, no, You need to become a member to join the RIPE meeting, the RIPE community, the RIPE NCC, or Hells Angels. So which one is it? That's right. In order to join the RIPE NCC, you need to become a member. You don't need to become a member to join the RIPE community. You are. I don't know about the Hells Angels again, but I think 2 people do know. The 6 took the lead. Harry 12 GB, Joe 5 taking a dive, and Katal. I wonder if I pronounced that correctly. Question number 11, and we're coming to the end. Which organization was the first regional internet registry? Was it the RIPE NCC? Was it ICANN? Was it ARIN? Or was it Internic? So which of these organizations was the first regional internet registry? And if you remember, like the elephant, this should be an easy one. The first regional internet registry was the RIPE NCC. ICANN is not a regional internet registry, duh. Eb 6 at the front, Joe 5 coming in again. Katal and 20 seconds. Yes, 20 seconds. On to the final question. Who implements the RIPE policies? So we talked about who discusses the RIPE policies, but who implements them? Is it RIPE? Is it the RIPE NCC? Is it the RIPE chair? Or is it everybody all together now? Okay, I won't sing anymore. But if you tell me who implements the RIPE policies, I will let you know if the answer is correct. And the right answer is the RIPE NCC. The RIPE discusses the policies, makes them, and then the RIPE NCC implements them. And let's check our scoreboard now. And we have on the podium at number 3, Wolf 21NL. Number 2, and at number 1 we have Ab6. Well done, runners-up, Ryder and the rest. So well done, everybody, for playing this game. We hope you had fun. Thank you for participating. Back to you in the main room.
Thanks, Gerardo. That was a great start of the week, and I'm sure we'll see more of that later. And also watch out for that secret working group. You might find out more about that later during the week. There's lunch. There's a lunch break now. We actually have a room for newcomers specifically to have lunch. It's a tutorial room. I don't know exactly where that is, which way around, but it's this way. Okay, but you can of course also join others, in the general lunch area if you actually want to hang out with the not so newcomers. It's up to you. So hope you'll enjoy the week, and I'll see you around during the week.
Warum?
I'm on the app. Apparently. Are they going to light you up? I don't know. I don't know. Can you do something about that? No, I don't think so. I think it's going to got some dark.
Okay.
Good luck.
I've got my flash in case.
Okay. Oh wow.
No, it's got a little diffuser. So
Okay.
It shouldn't be too intrusive.
Do you have presenter notes?
No.
No.
No. I have a piece of paper. Very old fashioned. Yeah, I didn't actually got it. You said we can make a slide. Except it's not a lot of light. We'll wait a few more minutes for people to come in, but please start finding a seat. I hope there's enough space for everyone and even enough maybe distancing space if you feel more comfortable with that. Wow, yes, now there's more light. No, it's okay, it's okay. No, it's fine. No, I mean... Test. Now it's on. Hey, I was just going to say, please take your seats in the back. There are still some seats on the outer parts of the room. This is a bit of an awkward layout from here. I can't see you all. And then we can get this show started. Well, welcome to RIPE 84. Yeah, my name is Miriam Kühne. I am the chair of the RIPE community, and this is actually my first meeting I'm chairing in person. And it's the first face-to-face meeting we're having since RIPE 79 in Rotterdam. I think, was it May 2020? I don't know. October, well, a long time ago. Since then, we've only had online meetings, and we've actually learned a lot during those online sessions. And I hope, so I'll get back to that a bit more, like how we try to incorporate the online participants as well. But I wanted to introduce you also to the RIPE Vice Chair, Neil O'Reilly, who also started with me in September 2020 and has only done things online so far. We've actually only met yesterday for the first time. No, I mean, for the first time since we started as a RIPE Chair team. So we've done everything online too.
So I'm really excited to be here in person again after so long. And it's great to be working with Miriam. So welcome from me too to RIPE 84.
Right, we have an amazing number of 1,163 registrations in total, which is bigger than I had expected, to be honest. We had like 685 on-site registrations, of which have now checked in already 453. So there'll probably still be more coming. I hope we're all going to fit into this room here. Looks a bit cramped already. But I think you're leaving enough space. And then we'll have also over 400 online registrations, of which we have now 388 checked in and probably watching us now online and participating online. So, as I said, we've learned a lot in the during the pandemic and during the online events, and we've really tried to put together a truly hybrid meeting. And so for the events team of the RIPE NCC, it's been kind of double work to organize an on-site and an online meeting in parallel. And we're trying our best to also make the online participants feel included. And that's why we're also using the MeetEcho platform still during this week, so that people online can participate and ask questions. And we'll see how it goes. It's a bit of a challenge for the session chairs to keep track of the queue, which we'll try to make it one queue online and on-site participations. You can see here also how many countries, people from 62 countries have registered for this meeting. So it's quite a diverse meeting in terms of nationalities, which is great. On top of all that, I'm actually from Berlin, so it's really cool to be back in my hometown, birth town. I remember there was another RIPE meeting in Berlin here, kind of across the road, many years ago. We were a lot smaller then. So yeah, it's a lot coming together. Seeing all these people face to face and being back in Berlin, and it's really exciting. So, quiet. This is the first time I'm doing this in such a large room, so give me a minute. It still feels a bit uncomfortable to be here with all these, with all of you together in the room instead of just having a big screen in front of me. So that's actually one thing I wanted to point out. Even though it's fantastic we're all here together, there are still a few things going on, I think, that that are, at least keep me awake at night. So maybe I can say a few words about that. First of all, I think I really have to learn how to, or relearn how to socialize again with people. I know I want to hug you all, but I'm still a bit careful also because of COVID. So it feels a bit uncomfortable. And so the second thing, yeah, obviously COVID is still among us. I just heard another community meeting last week where a lot of people got sick in the end. So I really hope that's not going to happen here. So I would like to, urge us all to be gentle, tolerant with each other, respect each other's choices, also when it comes to distancing or wearing masks. I'm still wearing a mask also because I feel more safer for myself, but also kind of as a sign, it's still okay to wear a mask. I don't feel bad if you feel more comfortable, right? So there are still people wearing masks, and that's totally fine. And we're handing them out here at the registration desk. They're also lying out in the hall. And we're also handing out self-tests. I think they can also be, you can pick them up at the registration desk if you want to do a test before you come down to the meeting. And I would really like to ask you to take your responsibility for yourself and for other people's health as well. And then the last thing, another big thing that kind of keeps me awake at night is, of course, the war that's going on in our region here. And then I'm sure we have people here from both Ukraine and Russia, and we're all part of this one community, and we're all colleagues, and I hope things will go well, and we might have some discussions, and I'm sure you'll hear more about it. There's a lot of topics, a lot of presentations on the agenda this time that refer back to that war. But I also want to stress that not only have you kept this internet running during the pandemic, which I still find amazing, and I still would like to applaud all the network operators who made that happen. And kind of in the background, the world was kind of relying on you all. But also now during the war, it's quite amazing how the operators on the ground in these difficult circumstances keep the internet running and up and running in Ukraine. But I think it's also fascinating to see that the infrastructure in Ukraine is really very decentralized. And that's really, I found, maybe one of the reasons why it's still up and running. And I think you also hear more about that later today. Yeah, give an applause to all the operators out there trying to keep the network running. I have a slide here. Wait, I had a slide here with the code of conduct, but that's disappeared. Maybe we moved it to another place. Now, actually, this is a good time because I wanted to pause here and give the word to Vesna Manojlovic, who wanted to say a few words to you. She is a long-term community participant, and she's also the senior community builder at the RIPE NCC, but she's still stuck on the train, or maybe she's already made it to Berlin, but she's on the bus and she can't be here. So I'll do this for her. She's done this a few times at other meetings, and I thought it was really powerful and brought the community together. So I'm trying to do a Vesna here. Bear with me. She's a lot more natural at this than I am, but she sent me the text, so I'm going to read it out for you. It's about the minute of silence. I'm inviting you to join me in acknowledging all our losses since the last time we've met. We've lost lives, health, connections due to war, climate catastrophes, and the pandemic. Let us honor our grief, mourn for those who have died, be sad for all the suffering and experiences ourselves, our families and friends, and our communities. You're not the only one who feels this way. You're not alone, and we are all in this together. So let's join in a moment of silence as a vessel to hold our sorrow. So I would like to actually let you all get up, if possible, and keep a minute of silence and remembering all this. Right, thank you all. Now we can move on. We've gave this a place, and may you be kind to yourself, and may you show kindness to each other. And thanks to Vesna for preparing this. I'm sorry she can't be here, but she will come in shortly. She might still pop in any moment now. Yeah, thanks. Right, so one of my biggest worries during the pandemic also was that we kind of die out as a community. Everything is, well, not literally, sorry, that maybe was a bit harsh after this minute of silence. I mean, as in, because we're so dependent on our human interaction with each other, and we're based on trust and social interaction, and we just couldn't do this in the last 2 years. And maybe those people of us, or those of us who've met it before and have known each other for a long time, it was a little easier because we could build on that. But it was hard for new people, I think, to enter. So I'm really happy to see a lot of new faces here. We had a newcomer session earlier today. Many people are here for the first time, which is great. And I hope they'll come back, and we'll all be nice to them and include them in the community. Yes, so I wanted to say something about the social interaction. That's why I'm bringing this up, because we have prepared also some social interaction for online participants in the hall so that they feel also included. And I know we all really happy to meet each other and talk to each other again, but we shouldn't forget our online participants as well. Now let's look a bit more into detail. I don't know if you can read this. This is a bit ugly. This is the meeting plan. Well, you've all seen it, and it's in your badge. I just want to point out a few unusual things, or a few things that are maybe out of the ordinary. You see, we have 2 BOFs in the afternoon today and tomorrow. Today, the BOF is about what we want from networking protocols in the future. It's kind of a wish list of like today's and future internet. So more like technical BOF. And tomorrow, the RIPE Code of Conduct task force is meeting to talk about the recruiting process for the RIPE Code of Conduct team in the future, and also still gathering feedback on the process and reporting for the Code of Conduct that they have sent out to the community. So they're still gathering feedback on that. Tomorrow we also have for the first time the best current operational practices task force meet again, and they have a really interesting agenda. Also again linking back to a sustainable and reliable internet in times of crises and wars and catastrophes. And I think another topic is about sustainable networking, and as in like environmental sustainable mostly. So that will be exciting. You can see, yes, today and tomorrow, as usual, there's plenary talks. Tomorrow we have also, I don't know if I have a slide on this, we might. I'll show you in a second. We have a Women in Tech session again. I'm really excited about this because we didn't really have those during the pandemic, because we didn't want to have things during the breaks and just felt unnatural. But this is really exciting, this session. Let me just see if I can find the slides. I'm sorry, I think it's coming later. Maybe I shouldn't have done this. Go back. Oh well, just ignore all this. We're going to remove it from the recording to go back to the meeting plan. I'm telling you, this is the first time I'm doing this in real life. Anyway, we'll have a Women in Tech session with some really interesting topics. We're going to talk about the gender data gap, what that means, and also we'll have Shane actually talk about the measurements he's been doing over the years of like diversity in this community and what we can learn and how we can improve it in the future. And then as usual, like Wednesday and Thursday, we'll have working group sessions, the RIPE NCC general meeting in the evening, and then on Wednesday, and then on Friday morning, we'll have plenary talks again and the closing plenary. Right, so this is the program committee. Some of them are here, some couldn't make it, and these are the people that put together the agenda for the plenary for you, and they've done a fantastic job. I think it's a really interesting program, but they of course always welcome feedback from you, and please rate the talks during the week and on the website. And we'll also have elections going on again. 2 seats will become available on the PC this time around. You can still put in your nominations until tomorrow. And then voting will take place until Thursday, and the results will be announced on Friday morning. I'm sorry, I kind of have the feeling I'm ignoring you over there because it's such a wide room. It's kind of hard to see everyone at the same time. This is a list of all the working group chairs we have at the moment. Again, not everybody could be here. There are a few new people also, new kids on the block that have been selected in the meantime, and they will start the new term at this meeting. You can see on each working group's page is also who the working group chairs are and what their terms are when the next nomination comes around. So you will see many of those during the week, and they're the ones putting together the agendas for the working groups, together with the working group, of course. Yes. Big applause. And they're all volunteers and doing this in their spare time. Now, most important part, maybe social events at the meeting. There's a welcome reception today, as usual, Monday, when after the plenary, like after everything finishes today, here in the hotel. And there's a networking event tomorrow. And then on Thursday, we'll have the traditional RIPE dinner again, in the real world. So it's going to be exciting. I know the venue. It's really quite a nice, beautiful, like traditional Berlin style venue, hall. We also have some events specifically for our online participants. They can participate in the welcome reception, and then we also prepared a small online RIPE dinner. They were quite popular during the pandemic, and so we thought we're going to continue that. And we're also going to use again the spatial chat social platform that we've been using during the online events. And there's some staff, RIPE NCC staff out there at the coffee area they're trying to kind of engage a bit more between, like, link between the on-site and the online events participants. This is our code of conduct. I already mentioned the code of conduct task force. They, together with the community, have worked on a new and improved code of conduct that came in place at the last RIPE meeting, I believe. And so this is not everything. This is just a small snippet, but you should have, seen it all when you registered, and it's on the website, on the RIPE 84 website, but also on the generic RIPE.net website. So I'd like to again, ask you to treat each other with respect and tolerance. And this is such, I need to speed up. Okay, finally, thanks, Jan. These are the trusted contacts. In case there's something that bothers you that you feel uncomfortable with, or you feel mistreated, you can reach out to the trusted contacts. They are trained staff, not only staff, 3 RIPE NCC staff, 1 community member, Rob Evans over there. And there are a few more people there. And there's the email address, and everything is dealt with confidentially. And last but not least, I would like to give a big applause to our local host, DKIX, and all the sponsors who have made this meeting, help us to put this meeting together for here in Berlin. And I would also like to thank the staff of DE.NORG and BKIX, who put together a fantastic pre-social event last night. I thought it was a really good, initiative. And I think that's it. That's us. This is us. If you want to reach us during the week, we're around, Neil and I, and I'll hand it back to Jan and Franziska. No questions. I don't know how they're going to upload your slides, and then you just click that button.
I don't know what to do. I have been told the slides are uploaded, so I guess they will just magically disappear.
Yes.
Here. Thank you. I need to change your body pack. You need to change my body packs. He needs to change my body pack, so please go ahead. So it works now? You hear me? So slides are coming up. Perfect. So also warm welcome from my side. My name is Thomas King. I'm the CTO of DKIX, and it's great to host a RIPE meeting again in Berlin. It's actually the 3rd time that we meet here in Berlin for a RIPE meeting, and it's the 2nd time that DKIX is hosting a RIPE meeting in Berlin. And we did it the last time in 2008. And when I prepared for this presentation, I actually looked up some of the pictures which we took in 2008. And you might remember some of the people from back then, because some of them are in the room today, which is great, right? But what is even better from my point of view is that we have so many new people in this room, and that the community was growing over the last 13 years like crazy, and that's great to see. And that's only one example of how important it is what we do as a community for the society. And I want to give you another example, and for that, let us quickly highlight how DKIX was looking in 2008, because back then we were mainly providing peering as a product, and we had only operations in Frankfurt, Hamburg, and Munich. And we were pushing about 500 gigs of traffic. Back then it was a lot of traffic. Nowadays we push about 15 terabits of traffic in 34 metro areas all over the world. And this shows you, how far we have come in the last 13 years, because now we of course still provide peering, but also cloud connectivity, closed user groups, and security features like Black Holing Advanced to different target groups like wholesale and also enterprises. And what is the reason for this development? And you all know that, right? Digital is now everywhere. Look into the cars, the displays get bigger and bigger because we all want to consume digital services while driving. We have learned during the pandemic that we can run a whole company just by jumping on Zoom calls all day. and in all the other areas of, of what we do in our life, there is digital. And digital is for everywhere, for everything and everyone. And I believe we are just seeing the beginning of what the journey will be. And especially if you look at the interconnection industry, we see that latency is the new currency, because now content needs to be very close to the users, and to make all these nice applications like cloud video gaming and streaming and virtual reality a reality. This is why edge computing is nowadays all around. And I hope in 13 years down the road we will meet again here in Berlin, and we can talk about how great our future was, looking back then, because I believe we have a very bright future ahead of us. So I hope you enjoy the stay here in Berlin, and you have a very successful RIPE meeting. Thank you very much.
So, welcome everyone. My name is Hans-Peter Holen, and I've already seen on Facebook that somebody thought I was still the RIPE chair, but no, I'm not. 2 years ago, I started as managing director of the RIPE NCC, and I was volunteered here today to give some meeting logistics on behalf of our meeting team. So, Meetecho is the main platform for this meeting. It requires registration. Bookmark your unique link and use it for all sessions. And you can do questions in both the Q&A and using audio. And there is a live transcript available, just as you can see on the monitors here. There is also a live stream page, so if you don't want to log in and be active participants, you can watch the whole performance online. The sessions are also recorded, so if you fall asleep during the sessions, you can watch them later if you want to do that. In Meetecho, there are different buttons for audio and video. When you want to ask questions, there is a Q&A icon where you can type your question. Please remember your affiliation. There is stenography here, and as you probably know, they write what I'm saying on the screen behind me, or what I should have been saying. I never know what comes up there. There is a chat group, so you can interact one-to-one. And a poll for questions for polling during the talks, and also a participant list. If you want to participate on site, we have brand new meeting application. So it's a web application that you can go to. It's a link in an email you've received, one for each of the rooms, where you can participate easily in the chat, and you can raise your hand in order to ask questions. Now, in order to ease the logistics, please then also go to the microphone, but then in order to enter the queue, you need to raise your hand in this new fancy app, so that we get one queue and don't prioritize people online or offline. Network. This is not about shifting IP packets, but this is about talking to each other. We have spatial chats, so it's a virtual arena that you've used if you've been to our virtual meetings during the pandemic. It's open all day, and you can use the link and password to participate in that. There is also the networking app that we've had for several meetings, where you can schedule meetings with fellow attendees, and the attendee list on the RIPE website. COVID is not quite gone yet, so please be careful. Please test each morning. We have tests available at the registration desk. Please stay in your room if you test positive. Please wear face masks if you feel that's appropriate for you. There are no hard rules to do that, but it's quite okay to do so, as Miriam already says. Masks are, however, mandatory on public transport and on the shuttle buses to social events, so please remember that. We have in the room here added extra distance between the seats, so that you should feel a bit safer than you have on previous meetings. More information is on the website, and we're really happy to have this in-person event again, so let's do our best and keep each other safe. There are also some stickers on the available that you can put on your badge to indicate whether you still prefer and would like people to observe distancing. Use the red one. Yellow elbow bumps are okay, or green ones for hugs and handshakes. I was looking for the black one to signify the Nordic 5-meter distancing, but we have missed out on that one. But anyway, thanks for coming and good luck with the meetings. And then back to the meeting chairs.
Are you turning? Yes. Okay, welcome also from the program committee side. This is now officially taken over. This session is now officially taken over by the program committee, chaired by me and Franziska, and this is Jan. And without further ado, we start with a block on a topic that is on all of our minds these days. And with that, I give you Emil Abend from the RIPE NCC, who will present us with measurements on the resilience of the Ukraine internet. Welcome.
I hope you can all hear me. I'm not on mute. No? Okay, yeah. So, hi, people that care about the internet. I'm Emil. I work for the RIPE NCC, and I want to share some observations that we did on the internet in Ukraine. Yeah, it's great that we can be here. It's been 2.5 years, and in the meantime, we had this pandemic, and then there was another thing that kept a lot of us in the minds of a lot of us, I think. At least it's in my mind. And that's the internet in Ukraine, or Ukraine, of course. But as people who care about the internet, we, of course, also care about what's going on in Ukraine, specifically for the internet there. And I've been obsessively looking at the news and at measurements since the war there started. And it was actually my expectation, and maybe a lot of you had the same expectation, that the internet in Ukraine would actually not hold up very well, given all of the things going on there. I expected a rapid deterioration of internet conditions there, cyber warfare capabilities and all such. But the reality, at least in as far as you can see in measurement data, it's still functioning. It's damaged, but still functioning. And I think that the best indication of that is a project that is visible in this project called IOTA. And the picture is here, and this gives you like a 90-day overview, because we are already like 19 days into this. And what you see here is that things have kept mostly on a bigger scale, have been online working. If you see that there's like 100% line at the top, that's like the pre-war conditions, pre-February 28th. And you see the green line, for instance, is BGP. That's like the number of /24 equivalents visible in the global table. And that's basically, well, it's a little downward trend there in the beginning, but mostly it's been at a stable level. If you look at the blue line here, that's like IP addresses that are seen active, so that they're seen responding, ICMP responding. That's actually gone down a little bit. It's like, if you look at, it's at 85% of the pre-war levels. And that can, of course, be explained by damage, war damage. But there's also an alternative explanation here, in that a lot of Ukrainians have left their homes, are displaced. In a country of 44 million, millions have been on the move, fleeing. And what that could have also caused an effect of people just shutting down equipment like their home or office, and that could also explain a little bit of that effect. The orange here is systems that do like it's internet background radiation, basically, and that's a little bit more erratic signal. We also see that go down, but it's a little less clear what that actually means. Going to a measurement platform that I know a little bit better, RIPE Atlas. Of course, we have like 11,000 RIPE Atlas probes deployed worldwide, thanks to many of you in the room here. And also, we have them in Ukraine. Before the war, we had 220, 225. And we see the same slow downward trend in the beginning, and it's being kept stable for weeks now. We actually made an online interface where you can in near real time see the number of RIPE Atlas probes connected for a particular country, for a particular autonomous system, or for a particular city with a radius. And you can visit that on the URL that's on this on the slide. And that's actually an open sourcey thing that you can modify yourself, use it in however you want. And I invite people to actually use that. You can look at other events with this. You also see little downward, little downward spikes, which actually means multiple probes at the same time go down, which typically is a signal something is actually going on. And I want to zoom into a specific event that we saw. It's the network called Triolan, AS13188. And you actually can see in the same interface, you can see that we had 11 probes there, and it went down 3 probes all at the same time, and then recovering in 2 days. This is an interesting case for a couple of reasons. One is that the Triolan people documented what happened here, and this was, according to the documentation they put on their website, this was an act of sabotage. So there were attackers getting admin passwords and then just causing chaos in their network. And it's actually amazing that they got this back up in 2 days again. The other thing is that like this is well quite a dramatic drop, but if you look at it in the big picture, it's roughly 2% of users in Ukraine use this network. So in the bigger, if you zoom out, it was not a huge amount of damage done by this network being down. But this is actually one of the examples of damage that happened there. There's other cases like this, but as you can see, things go up again. People made things function again. But let me get to the worst thing that is going on there currently. That's the situation in Mariupol, described by the Red Cross as dystopic. Things are really bad there, and of course these are circumstances where the internet breaks. There's no power, no fiber, and that basically makes that things stop. Internet is a human-made system, so it breaks at a certain point. And a case of that is this: the Illich Iron and Steel Works. They have their own AS, and it's located in Mariupol. And what you can actually see in the data collected is that at the beginning of the war, they were still online. They had 2 networks they depended on. As you can see, there's 2, a red line and a green line here, that are the dependencies. After a little while, one of them was left. So March 2, you see there's only the green line, which is their major dependency. And after that, they just dropped out of the global table. So there is a breaking point to this. But with that, if you zoom back out, what I said in the beginning, things mostly kept functioning. And that was like, I was surprised. I spoke with others that were quite surprised by this. So why did it not break in more massively? And when we looked into this, there's a couple of layers that we discovered in the data. One of the things, a very important thing there is not in our data, and that's people like this, well, repairing your network in these types of situations. That's, for me, deserves a massive amount of respect. And this is a very important part. People just keep working to keep this connected. And yeah, this is amazing work being done by people on the ground there. So it's humans, dedication, courage, actual real people like you in the room here doing this type of work. What we had in our data is other signals of why things might be maybe kept working. And one of them is ISP decentralization. So there's not really a very dominant market player here. It's quite decentralized. There's diverse interconnections. There's lots of IXPs we can see in measurement data. Another thing is high independence at the transit level. And we have the IHR, the Internet Health Report. There's a link here that can actually show you what networks Ukraine depends on for its connectivity. And Telegeography had a nice article about the diversity of fiber path, just the physical diversity, but also multiple organizations. So you see multiple levels and in all of these, or multiple directions, and in all of them you have this redundancy, this resiliency. And let me focus on two in more detail. The first one is the ISP decentralization. And now I have to Herfindahl-Hirschman Index, HHI. Yeah, something that comes with age that you cannot remember these terms anymore. This is an index used by in economics. And it's a scale from 0 to 1, where 1 means an absolute monopoly, and 0 is like a totally dispersed market, very small, lots of very small players. And if you just calculate this based on data that APNIC is providing, and we have this data, there's a GitHub repository online that you can find through the slides. If you look at this data, Ukraine is 4th in the world in lowest HHI, so it's very dispersed. And we also have a visualization of that. And what you see here is, this is a full circle. The full circle represents all of the end users in Ukraine. But for this visualization, we chose to only show the networks that have over 1% of market share. So you can actually see 55% of them is not shown, which actually shows you how dispersed the market is. And what we show here actually is the elements that interconnect these networks. We measure this with RIPE Atlas, and you also see a lot of elements there that do this for the main networks. And the orange ones here are the IXPs, and the blue ones are other networks. Yeah, there's a couple of links there. This is measured with RIPE Atlas, and there's some visualizations on that also open. Well, the other thing that we looked at is IXP abundance. You see, if you look at PeeringDB, there's 19 IXPs in Ukraine. And if you just measure between all the Atlas probes, you see 13 of them we actually see between the probes. And the other thing here is that if you just look at the colors, each color is a different IXP. There's not really a dominant color. So there's not a single dominant IXP. It's just like very, very dispersed, which helps in resiliency. Now I'll take a brief detour what happens in occupied territories. This is an interesting thing we saw happening around May 4th. in Kherson, and Kherson is a town in the south. It's relatively close to Crimea. And what you actually see is, well, maybe it's not very visible it's too small. You see the dominant ISPs here are mainland Ukrainian ones, and it switched over to using a network called Miranda Media. And that network is very well known, documented, that provides internet connectivity for Crimea. So this is sort of like a rerouting of traffic. Instead of going this way, it now goes this way. This switched back, but it's a signal of what's actually going on in that town right now. And it's part of a larger thing that has been happening. And this is a study that I want to briefly touch upon about the what we called an internet interregnum, an unstable period in between stable periods, which happened 2014, 2017, and in 2014, Crimea was annexed by Russia, and we took a deep dive and studied that together with Roman and Ksenia. And Ksenia is a sociologist, and she actually did some field work in Crimea. And what came out of that actually is a lot of evidence of people in Crimea working together, both the Ukrainian and the Russian side, to make this internet work. And we use something called AS hegemony. That's like how dependent is a network on other networks. Well, there's a link there, so you can look at that for your own network, and it depends on BGP data that is in RIPE-RIS. And what you see here is that like the network went from, say, Ukrainian influence to Russian influence, not in a single event, but this actually took 3 years for it to completely move over. And this is sort of like an indication of that. In the top here, or the colors indicate how dependent a network is on or how dependent a set of networks is on another network. So the darker, the more dependent. And this is a timeline. So in the top, you can see the Ukrainian networks, they depend on a particular set of networks, and that doesn't change that much. Russia, it's the same, but if you zoom into Crimea specifically, you can actually see changes happening from 2014 up until 2018. With this is Rostelecom and Miranda Media really taking a very dominant position in this. So it's like significant changes to the connectivity there. It was a long transition, and it was a good match. The internet data was a good match with the timeline that we got from the interviews with the locals, actually. And it's a topological choke point reflecting geopolitics in the region. So with that, I come to conclusions here. Takeaways, we try to get some, or to provide insight on top of our data, apart from all of the established interfaces that we have, RIPE-RIS, RIPE-Atlas, and RIPE-Stat. On top of that, we also built some prototypey things. This is open source. It's open to tinker with and to improve. And it's built on top of Atlas and RIS in many layers. And it remains a human-made system that has its breaking points. This is not the most important part of my talk. The most important part of my talk is actually this, and it's actually the next talk. So I'm not going to spill a lot about this, but this is the really important work that's been done. And yeah, that's what the next talk is going to be about. So thank you for your attention.
Does it work?
Do we have microphones?
Does it work? Yes, it works. Thank you, Emil. Thank you very much for this. Can you hear me? Yes. Now we have Q&A. Is anyone in the queue? So this is an experiment now. Everybody in the room needs to need an app that needs to go into the queue, and then we will call your name to come on the mic, and
Rüdiger, you can just come up to the microphone. That's perfect.
or you can just come up to the microphone and be done with it.
Thank you.
Rudiger, thank you.
Yeah, at IETF, I worked out that I
We
don't
remind you,
need an
please,
app.
to state your name and affiliation at the microphone.
Oh, sorry.
We are not
Rüdiger Volk, no affiliation, but just myself these days. Emil, one question I have is, some publicity was around by the beyond oligarch rich people supplying support for Ukraine internet. Did you see anything about that?
I did not see. I'm guessing you're talking about Starlink.
Yeah, sure.
Yes, that's correct.
Yeah. Yeah, no oligarch is actually matching Elon Musk. We know.
Okay, yeah. Yeah, there was a lot of publicity around that, but and I was for a while I was also like I share your skepticism that I sense, but then again I saw some images, for instance, in Bucha. There's a documented case of like GSM was disconnected, and it was connected through a Starlink terminal, which allowed a lot of people to just send like maybe like your 140 characters is enough to tell your loved ones that you're safe. So it's like it's not what I saw is not like providing massive amounts of bandwidth, but in these really emergency situations, it did make a difference. And also in Mariupol, there's also like in a besieged part of town, the only connectivity left apparently is Starlink. So that's in the grand scheme of things, in measurement data, you don't see it, but it's there and in providing probably a very important role.
Yeah, my guess would be that if we see a video link into Azovstal, it cannot be much different than the Elon Musk thing.
Yeah.
Thank you. We still have 5 minutes for questions. Any other questions? Nobody is in the queue. And 3, and 2, and 1. Thank you very much. Thank you, Emil.
Thank you for your attention.
It's so good to be back. Hey, yes. My name is Jan, and welcome to Berlin. And with pleasure, I would like to introduce the topic that is very close to my heart. And René Fichtmüller will tell us how to react to the issues that Emil explained, and then we heard what is the situation, and now we will hear how to fix it. Thank you.
We try to fix. But first, Emil, thanks for the link and happy birthday. So, yeah, I'm René. I'm working for Flex Optics normally, and normally I wear a different color of shirts. Normally this bright orange shirts what Fergus is wearing right now. And yes, how I can explain, it's like, sorry, but I'm a little bit nervous. We can start how it works here. This one. So we heard about it this 24th of February, the war in Ukraine started, and I was a little bit shocked. It's 900 kilometers away from Berlin, as an example, to the border to Ukraine. And I have one mindset. Our industry, our branch don't think in races, don't think in colors, don't think in borders. And that's the thing why we are one family. Means When I'm traveling, I'm talking to you guys and ladies, sorry. I'm talking to my second family and not only to some guys I know from the community. And that's the reason I had, after 2 weeks after the war started, it was the second week of March, I met a friend at Facebook, Patrick, and he was sharing, oh yes, I want to organize a humanitarian goods trip to Ukraine. I have a truck, also possibility to have a second truck, and he was driving the 40-ton truck, I was driving the 7.5-ton truck. And after 2 days, I think everything was fixed, and we started to pack our clothes into the trucks and started our journey. We drove from Berlin via Poland to Ukraine, to Kochovo border, then to Ukraine, and we handled the stuff over. We drove 11 hours. We had on the first day 2 hours of sleep. Then we met during the night some people. And we handled everything back-to-back trucks, back on back, over into the other truck. And it takes only 2 hours, and our trucks was empty, and we're going straight back with, how I can call it, local workarounds to get very fast back to the Polish border. And we drove back to Berlin. And then when I was staying at the castle, and we had some challenges between the border from Poland to Ukraine, my buddy was or forgot his passport. And normally I'm travel 2 times more the year, and I'm a little bit experienced in travels, and you need to have your passports with you every time. So, and he started this trip with a normal ID, German ID, and it's not enough to go outside of Europe to other country, you know. And then we stuck between the borders for a couple of hours, and then we prepared the beds in the truck for proper nap. But then you have seen, and it was the second week after the war started, we have seen all these women are coming out of Ukraine with only a cabin trolley full of clothes and with babies, and the babies was crying. The reason was the refugee camp was direct on the border from Kochovo. They're organizing trips, bus trips to Krakow, etc., to getting tickets for trains to leave Poland to all possible destinations. And then I was back, I think, Jan, it was 13th of March. I was back, then immediately I had a board call with my board colleagues of the Global NOC Alliance. And normally we are supporting NOCs, means when you want to organize a NOC, we get everything what you need, like software in Indico system. We are selling on our service, a cloud system. You're getting Zoom license during this COVID pandemic, etc. But now it changed a little bit, and I shared my experience. And at some point, we decided to create a task force, and Keep Ukraine Connected was born. So the goal of our task force was to check what we can do. It's good to have an idea, you can start something, but what? And then we started with Facebook, and we started with Twitter and Instagram to post, yes, we have a vision, we want to support. When you have some equipment, you can donate, ship it to René. Yeah. And yeah, but 1 week later, I had a business trip to CloudFest, and my wife was calling me and said, dude, it's very nice what you're doing, but right now we have a lot of pallets in our front of our house. What we are doing with it, yeah? So she was a little bit unhappy. And also we had this scenery like Jan, René, Sander. Idea. Perfect, cool. But sometimes it's not a good consolation. We was, after 2 days, we was completely overloaded with incoming mails of donations, requesting, a lot of people requested support, like equipment, money, etc. And then Sander was, I think, 2-3 nights, very, very active, and built up our own supply and demand database. So right now, and up to from this point, we had this structured way for the inquiries, but not from the real organization. And then I was happy, Jan, you was it, or Sander was it, had this idea, hey, Natalie, you are welcome. And I'm really, really, really happy she was joining us immediately and said, guys, it's nice what you did, but not on this way. Stop it, and we will figure out some organization details. And then right now, everything worked really, really smooth. And yes, with the first version, oh, or not, this is an example from Ask Your Neighbors for More Space. Dropping packets into the van, going to next to your neighbor, deload the stuff, and this happens every day, I think, for 2 weeks. So this is our first version of supply and demand database. Means all the donators can create an account. All the requesters can create an account. Donators can put all the donated stuff, all the donated equipment into the database. We have requesters getting an account. They can create an account all by yourself, can claim what they need. And then we have Jan and Sander. They are looking also, it fits or doesn't fit. Also, when we have some special requests, we can look what is compared to this, what you requested, and we can offer it. And yeah, then this is a version 2, version 2 with the own registration page. The first one was like you need to ping us via mail. We create this account for you. Also, it's more structured. You can see here, you can see what is claimed, what is rejected, what is received, and also we can put in the delivery address, the deployment address, etc., all information what we need to make sure this equipment is also going directly to this address who claimed it for the company. Everyone asked me, what is the goal? The first goal was collect equipment, and then we had equipment and what we're doing with it. So it was hard work. We worked at first. We pinged some people from the Ukraine Internet Association, like Natalia. She is also responsible for the Ukrainian Content Owner and Rights Association, and then we found this DEPS crew, and in the end Natalia is also working and a good influencer to the Ministry of Digital Transformation in Ukraine. I won't explain why DEPS. DEPS is a local distribution. Normally they are working like a reseller or whatever. They're reselling equipment in Ukraine. They have a stable and working supply chain in Ukraine. They have own drivers, they have own couriers, means we meet this guy behind the border, handling everything over, and they're doing everything without any questions. They're getting addresses from us, they're grabbing stuff also during the weekend in private cars, they're pulling this in, going to the cities where the need is, and handling over to the local people. Why we're doing it? Or why we're doing this, and why the internet is so important of Ukraine. You have seen it with the presentation of Emir. Normally, January 2021, 85% of Ukraine's, welcome. 85% of Ukraine's population older than 15 years had access to the internet. Means mobile access, fixed access at home, etc. We have, or Facebook or Meta has 10 million users counted on January 2021. We have also 7.3 million of Instagram users. The internet is very, 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 very important also during the war. One of the mediums for communication, it's very important, like Facebook Messenger, Twitter, normal email, WhatsApp, etc. And this is also a picture, it's not a high resolution picture, but these are a couple of destroyed parts of, you know, it's Kharkiv, or I'm not sure, it was from Atacom, but you see all these guys are splicing the fibers in front of tanks. You see destroyed offices. I don't want to be in this situation to splice fibers or whatever. It's crazy and amazing what all the people are doing there. And you can see they're splicing in front of it. It's crazy. This is one of the, it was one of the last Mariupol 5G towers. It was a couple of weeks ago. And what happens in April 2022? Some guys organize this nice event in Slovenia, call it SEE 10. And Jan had this idea, hey, you can come with a truck and you can pick up some stuff on the way to Ljubljana. Yeah, nice idea, but it's a long ride. So I started 8th to 14th of April. I started 8th in Berlin. It was Germany, Czech, Australia, Slovenia, Austria, sorry. Slovenia, then back to Austria, Czech, Poland, Ukraine, Poland, and then back home. It was all in 3,100, 3,200 kilometers and real driving time for 44 hours. Then before I left Berlin, I was picking up stuff, and thanks to the colleagues of B6, I was really happy. They donated stuff. Also, I've seen Matthias. Thanks, Matthias, from TU Darmstadt. A lot of Cisco gear. Yeah, empty house, happy wife. Yeah, it's true. Trust me, it is. So then I was going to Andre, picked up stuff there, including he arranged a last minute interview to Sergey. Then I met, Adam is not here. No, I've met Adam from Nixiset at the gas station. Yeah, we handed over some antennas. So, and then next stop was Slovenia. And the most important topic was in Prague, yeah? Sorry, but in Prague, I met Sergey. Sergey and me, we know us a couple of years. And he said, oh, yes, I want to join you to Ljubljana. Yes, no problem. But only for the record, also for you, for the future. Never leave the highway. So the truck was nearly full with 2,000 kilograms, 2 tons of equipment. Yeah? And the truck wasn't really ready for winter scenery. We had 18 degrees in Czech Republic. We expected in Ljubljana 20, 25 degrees. So never leaves the highway. It ends up on a high mountain with snow, ice, and all this kind of stuff you don't need at this time. And also, only for record, when you're going up, you need to go down on the other side. How long we need? 3 hours for 15 kilometers? I think so. Yeah. So then we arrived in Ljubljana. We collected the service from Six Connect from Jan, also the most needed splicer. It was the first splicer we bought from our donated money. And yeah, fully loaded with 14 pallets of equipment and weight. It was over 2 tons. I was on the scale at the customs was saying, okay, leave, dude, leave. So next stop, border Ukraine. And normally you have this, I have this experience. I've seen this picture 2 times, trust me. When you're staying in this area, you need only 7 hours to get around the corner to the way scale. And this is 11:30 a.m. This is 6:20 p.m. I arrived. You can see this is a Polish border here, and you can see here is the entrance to the Ukraine border. It's a no man's land. The guys call it no man's land. So, and you can see here the border of Ukraine, and you also, but this is the second part. You have one part for clearing at the Polish side, like customs and clearing, like tax clearing, Isidro, and also on the customs side of the Ukrainian side. So it takes time. And then finally, I arrived 11:30 in the morning, and I was at the meeting point 7:30 p.m. So we deloaded the stuff, like back to back. I know it exactly. It's very easy and useful, this situation. And yeah, happy Ukrainian people. Trust me, it's very cool to see in this eyes. And this was also one thing I said, okay, before we starting with volunteers and before we are starting to do more in this with this project, with this task force, I want to have a level of trust with all the people we are working together. What happens afterwards when I was back? We worked instant, not me, Jan and Sander was working on a lot of things. We added the request directly out of our systems on our website, out of the supply demand database. Everything is high need, high requested equipment is going to push directly to the website. We have a full Ukrainian language support website, also supply and demand database, multi-language on the website. Our daily keep Ukraine connected work. Oh no. Working on a stable concept for the future. Before we started this this task force, we had a board call, and Nisha mentioned also, guys, we are global NOC Alliance. We are not Ukraine NOC Alliance. We are not Europe NOC Alliance or NOC Alliance or whatever. We need to make sure everything is also prepared for the future. I'm sure with this project, what we started from the scratch, we can also be an example for the future, also for other disasters. We have experience how we can establish a supply chain or whatever, and who we needs to talk, who we needs to bring in, like local network engineers, local companies like distributors to build up a supply chain in the disaster region. And this is also our goal to fix what we call it. It's like Jan, what was the name? It's like a blueprint to support also other disaster areas. Yeah, perfect. This is like possible workflow, how our system is working with requesting donations, and when we don't have this compare equipment or the same equipment what is requested, we can we have good contacts to a lot of vendors. We can request them directly at the vendor stage. Conversation with donors. Right now we are expecting what is really finished as a conversation is around 15 up to 20 millions of donated equipment. We are talking about 35 pallets of switches and routers. Conversations with additional partners, like in Germany, we have also like in Netherlands one initiative. It's Cloud for Ukraine with Simon Westermann. I'm happy to cooperate with other people, other foundations that are doing the same like us. When we combine our powers, we can have more success, like when we are going alone this way, only by ourselves. Conversations with the Polish and Ukraine government and customs. It's very important to have a green corridor. Normally we have from the Ukrainian government, we have all this paperwork that makes possible the Polish side can open the doors and let us in the country without any customs or any ask or questions or whatever. But it doesn't happen right now. And normally day work and family. So who is behind the task force? It's a lot of people are thinking I'm doing this by myself. No, it's a honor for myself to work with a great team together. First of all, Corinne, she is doing all our marketing communication channel. It's a pleasure. Many thanks, Corinne, for your cooperation and for your work. Natalie, many thanks. He is not here, but ma'am, many thanks. I'm really happy to have you on board in our team. Sander, well done. Many thanks. Jan. And at least the driver, I know. Trust me, I'm not done. I have 9 minutes and a couple of slides. So, so that's the most important part. For me in person, many thanks, Natalia from APPK / Ukraine Internet Association, Bogdana, Dimitri, and the whole team of devs. Amazing what these guys are doing for amazing work. Do it 24 hours, 7 days a week. They're delivering this our stuff to the needed places and the data centers and ISPs. Team Ukraine Association. Team Ukraine Ministry for Digital Transformation for all the paperwork what they're preparing for us. Julia Trojan, she helped a lot of also with paperwork, amazing. Then also Marcin and Leon from Poland, PL NOC guys, there are also volunteer drivers for the next steps. And Daniel, and we need to respect the rules of VAR in Ukraine. We can talk about it right now, but I think I'm sure the next days or next week we can say a little bit more about the situation, what happens the last weeks, or I don't know. Also, big thanks to all our donors like B6, Andre, CZNix, T6 for power generators. Many thanks. It's I shared with Thomas a couple of videos, or one video. They are showing this in the field. Flex Optics for boxes and for transceivers. Thanks, Markus, Thomas. Matthias and CEDAT team and TU Berlin, Global NOC Alliance for everything. NetArt also for Technic, Nixie also for the technical equipment, US Internet also for the technical Unimus, and ZeroT. These are our donors, and who wants to support us with money, splicers, equipment, drop us a mail. You are welcome. What we need and what are the most requested tool at the moment, splicers, to make it possible to rebuild the infrastructures, the optical infrastructures in the destroyed regions like Mariupol, Kharkiv. One of our splicer is directly in Kharkiv. It was delivered, I think, after 2 or 3 days to Kharkiv. Yes, we are looking on a clear way, money to buy splicers. We bought from the last donation round, we bought 3. They're already in 4. Yeah, that's better. And yeah, and we will ship them, I think, the next time to Ukraine. Thank you. That's it. I'm done. Time for beer.
Thank you, Rene. This was awesome.
It's a pleasure.
Okay, now we have a queue. Itamar Cohen. Is Itamar in the room?
On remote?
You see, we are using our time preciously. Okay, Itamar is not here. He's just playing with buttons. Jen.
Hi, Jen Linkova. Thank you very much for doing this, first of all. And I have a very practical question. As someone who spent last 4 weeks dealing with all this logistic chaos of delivering stuff across the border, I'm very impressed with your system, with this database, because I started crafting something like that. So are you going to open source it, make it available for others?
It is already.
Perfect. Thank you. Sorry if I missed it in the presentation. Awesome. So we'll be in touch. I'm very curious. Thank you.
No problem. No, you can use it. It's available via GitHub, I think, when I'm right. Sander?
Yes, it's on GitHub.
Yeah. So, and free to use.
Thank you. Do we give priority to reality or to the queue?
Up to you.
Okay, Michael Richardson.
Hi, Michael Richardson. So interesting. This is really cool. So lots of pictures of switches going places. And I'm guessing there's some mix of new, used, and maybe semi-obsolete stuff that was donated and went there. And I guess I'm wondering what happens to it in 6 months when it's probably still there. Do they get firmware upgrades? Because that's what's kind of worrying me a little bit about, you know, we give them a whole bunch of good equipment and 6 months later there's a 0 day and the infrastructure gets owned. That would really concern me if that was the case.
We are actually working on that, but Sander will give more precise answer.
Sander Stefan, I'll quickly jump in. I am actually talking to high-level executives of different vendors to get exactly that for the Ukrainians.
Thank you.
Thank you. So technically speaking, we have nobody in the queue.
Blake, go ahead.
Blake with Zayo. Once
Please.
again, thank you. This is really great. Do you think in parallel there could be some efforts around peering with the Ukrainian networks that are providing connectivity to the networks that you're setting up or that are being set up behind this? In particular, for example, like not everybody obviously has capacity into Ukraine, but I think a lot of these networks are present particularly in Germany. But maybe they just don't have that much connectivity, or maybe they need some help, like with language assistance, whatever, or just like handling their peering queue or something like that.
It's I think we had other priorities the last weeks. And we started this conversation about how it looks like in the future when the war is over, and hopefully it's very fast over, with guys from the Ukraine Ministry of Digital Transformation and the telecommunication to sit down together when everything is a little bit settled down, and also the complete destroyed areas are rebuilt, and talk about like the IXP infrastructure or the landscape in Ukraine. Right now you have also from the Ukrainian Internet Association one proper IXP, and then you have, I think, 15 different small, medium-sized IXPs. They're doing own stuff without to interact really near with each other. And I think it's time after the war, and I'm sure also the Ukrainians have a lot of other things right now to discuss on the table to work on it, and not to talk about possible peering sessions. But I'm sure when we have this context and this information, when the need is there, we will directly share with the community. Absolutely, this is why we are doing this project. Yeah, and I'm happy when someone wants to join, like for a different topic, like peering focus or whatever. You are happy. I'm happy. You are welcome. Trust me. It's less work for us, and right now it feels a full day right now with work for this task force. But yeah, also we can have a chat later after here, and we can discuss some things. Also with Thomas King, we can set up something for the future. I'm happy when we can arrange in Ukraine with the Ukrainian Internet Association, like a workshop, how proper peering looks like for the future. Also with a better part of redundancy. It's also the next topic for the next generation of the local infrastructure there. Next one.
Thank you. Constanze.
Yes, I didn't get the app, how it's working, so sorry.
worry.
Next time.
Hello.
Tell us who you are.
Constance from the Ministry of the Interior, Germany. I really want to thank you from the bottom of my heart. It's extraordinary work, and I followed you online, and I say absolutely thank you. Jan, René, Sander, Corinne, it's so great, and we can't imagine what's happened there. And it was a really touchable presentation for me, and thank you for all this. Thank you.
Thanks, Constance.
All right, on that side.
Hi, my name is Marlene Marta.
You can lower the mic a little bit.
Sorry. My name is Marlene Martez. It's my first RIPE meeting, but
yeah,
I
welcome.
just wanted to say that I was just discussing with some members of the community today about moral ethics, and I think that when we're working with our companies and working in this industry, I think it's very easy to lose the human aspect of technology and internet and networking. And I think that when you present something like this, I think it's not only inspiring, but I think it really brings back the notion that we can do a little bit more
to help each other and help the world in terms of global connectivity and even like helping with the Ukraine, but there are a lot more other places that also
Yep.
could use help. So I
Absolutely.
think, if anything, this is inspirational and a call to arms for anyone else in the community who wanted to do something in support of any other country to do the same thing, in addition to the Ukraine. So thank you so much.
No problems. That's the reason why we published also this at GitHub, our supply demand database, to make it public for everyone who wants to use it right now for other kind of disasters or whatever. Also, when you're running some donations or whatever, you can use this tool, and we can deploy this tool, etc. And also again, many thanks, Sander, for all your hard work you put into the tool. It's amazing. But thanks for your feedback, and I'm happy when we also can build up a blueprint for other kind of disasters, and we can also support other kind of disasters. Yeah.
Rudiger, please.
Rudiger.
Well, thanks, great work, and good luck. I would like to take a look at some of the not so technical stuff. You reported that the paper war stuff at the Ukrainian-Polish border was worked out quite easily.
Yeah.
Which is something that has been reported to have happened for a lot of these supplies under the very specific circumstance. Obviously, that's going not to be as easy with other potential targets of help when we move on. On the other hand, I would like to point out for a positive note that you didn't report any bureaucratic problems at any of the borders your truck was crossing, which I think is actually noteworthy. Kind of, we all, I guess, have been guilty of complaining about EU regulations and rules and bureaucracy. But sometimes it really works smoothly and it is very helpful.
Yeah, but
we really should appreciate that. And yes, hopefully we can extend that.
It needs to have a proper conversation with some ambassadors, and it was scheduled, but our project was not high level enough to have immediately appointment with the Polish ambassador, etc. I don't want to go into a political discussion or whatever. It's not the platform for it, but we scheduled everything, and we're working with the Ukrainian people together. The Ukrainian side, it's very smooth when you're working with Ukrainian people and government together, but most challenging part, it's the Polish part.
Oh, sure.
I can say you have a plenty time of meditate. Yeah, you can 7 hours of doing, so but it doesn't help you to get grumpy or whatever. And we had a RIPE house call during I was entering the Polish border. And when you see the guys with the guns, you don't want to complain, Trust me.
Yeah.
So, Sander,
what
I can do for you?
Then we close the queue.
Non-existing queue.
So, yeah, speaking as a member of the task force, the biggest issue we're having is like we're getting lots of help from places, but the biggest issue is the logistics. Getting storage in Poland, because putting everything in Ukraine right now is risky. Even the local people there say we can't maintain proper security, stuff gets stolen from warehouses, so we try to only ship things to Ukraine that can immediately be shipped out to the operators. So we are trying to work with lots of different parties, but big organization, everything takes time. So a big struggle for us is actually getting enough storage space, like for 20-30 pallets of equipment in
a little bit more at the moment, a little bit more.
Yeah, even more than that. So that's one area where we could really use some help. The other one is donations from outside the EU, where we have to be very careful, because if somebody ships over $10 million worth of equipment from the US and we get the VAT bill, we're not going to survive. We don't have the funds for that. So if people have experience with logistics, storage, import laws, stuff like that, please get in touch, because that we also want to make sure that we actually have longer term storage, because now the stuff we ship to Ukraine is for the short term needs, but their problems are not going to be over. Even if the war would stop today, they will have to rebuild for years. So we try to also store stuff that will be useful in the future. So if anybody could help us with that part of the work, that would be really welcome.
Yeah.
Thank you. And I see no people running to the mics. René, thank you very much.
Thank you.
Thank you. And with that, I would like to remind you that to support the work of the PC, you can do multiple things. A, please do rate the talks so that we know how you like them and what we may change in the future. And until tomorrow, you can put in your name and volunteer for the PC elections that will happen during the week. So if you want to be part of the people who create the nice plenary sessions, or if you feel we are not doing a particularly good job and you want to help us, you're cordially invited. Please send your nomination to pc@ripe.net. And I'll see you in half an hour.
Yep. Thank you.
Welcome to our first RIPE 84 Kahoot quiz. My name is Gerardo Vivier and I am your quiz master. We are broadcasting today from behind the main screen. Can you see me? This quiz is sponsored by AVM and the topic is network security. Oh! I know it's a difficult topic. Let me explain how to play. You have to go to www.kahoot.it and put in the game pin that you see here, 6247769. Every game has a different pin. Yeah, suspenseful, huh? So I am going to show you 12 different questions with different possible answers. The person who answers to the right answer the fastest gets the most points. And at the end of all the questions, we will see who has the most points, and that person will be not a turkey, but the winner. And if you put in your registration number from the RIPE meeting, then you have the possibility of getting a goodie bag. So put in your nickname, put in your registration number, and try to play the game and win. So again, 12 different questions, 4 different answers, sometimes there's only 2. It's a trick thing, right? And anyways, the person who gets the right answer the fastest gets the most points. So wake up and smell the cappuccino. Come and play the game. We're going to start in 5 seconds. And I said
5
seconds,
4
seconds,
3
seconds,
2
seconds,
1
second. We are going to start. Network security is a topic, remember, so keep that in mind. 3, 2, 1. Data leakage is the best source of gossip at the water cooler, a data bladder issue in an organization, when your network has a poorly sealed gateway or unauthorized transfer of data to the outside world. So data leakage is the best source of gossip at the water cooler. Is it a data bladder issue in an organization when your network has a poorly sealed gateway or unauthorized transfer of data to the outside world? This is really easy. Just press any number, any color, everything is fine. And we see everybody has the right answer. It is an unauthorized transfer of data to the outside world. Scoreboard says Javier MG, Scroobius Pip, Rule 21NL, and SM7. On to the next question. What is meant by pen testing? Is it testing for exploitable pens? Is it checking exploitable vulnerabilities? Is it checking if all pen still writes? Or is it that's fantastic said by a smiling person? That came out so wrong. That is just fantastic said by a smiling person. And the right answer is very easy. It is checking for exploitable vulnerabilities. Everybody got that? That was kind of easy. On to the scoreboard. A at the top, Scroobius Pip, Demo, GPF 239, and Wolf 21NL. Next question. A method used by attackers to access a network is called an educated guess, a vulnerability, an exploit, or a bad night for you. So a method used by attackers to access a network can be a bad night for you. Is it called an exploit? Is it called a vulnerability? Or is it an educated guess? That's right, you got it all right. It's an exploit. An exploit is a method used by attackers to access a network. And a vulnerability is then what? We will find out. Scroobius Pip at the lead, Rules 21NL, Lara 309, Jai Hindley, and Mika 39. Question number 4. What characterizes black box testing? Is it the box is tested for its blackness? Is it the internal structure is hidden? Is it the internal structure is known? Or is it the program code is tested in a box that is black in color? One of these things it is. That's right, Daisy. One of these 4 is the right answer. And I guess it is, boom, the internal structure is hidden. When you have a black box, you have no idea what's inside it. And that's why you put it and call it a black box. Oh, Scroobius Pip at the lead, Lara 309, RFC 289, RFC 1036, and L. I'll have to look up that RFC. Question number 5. Yeah! WAF is an acronym for WAW as FARC, Web and Freedom, Web Access Forwarding, or Web Application Firewall. These are all kind of like tongue twisters. Whoever wrote these questions? So, Web and Freedom, Web Access Forwarding, Web Application Firewall, and WAW as FARC. I wonder what will we win? And the answer is, of course, Web Application Firewall. Well done. On to the scoreboard. Lara 309 taking the lead, Scroobius Pip, RSC 289, RSC 1036, and L. Question number 6. What does MITM mean? Is it man in the middle? Is it man is the middle? Is it middle in the man or middle man in the middle? Let me repeat that. Middle in the man is the middle, man in the middle, man in the middle, and that is the right answer. I hope I have my tongue left over the next one. Scoreboard, Lara 309 still at the front, Jay Hindley coming in, RSC 289, Mika 39, and Christoph 71. Question number 7. ... refer to the weak point in software code which can be exploited. Go to the lines, vulnerabilities, application failures, or CRLFs. So blank, 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 refer to the weak point in software code which can be exploited. Remember we talked about this? So what fills in the blank? Yes. Remember we talked about vulnerabilities and exploitations. Well, vulnerabilities is the weak point. Scoreboard says Laura 309 at the front, Jay Hindley, RSC 289, Christoph 71, and P290. Question number 8. What is the use of salting? Is it to replace hashing? Is it to safeguard passwords? Is it to make the meal taste better or to make your password shorter? So why do you use salting? So to replace hashing, to make your password shorter, to make the meal taste better, or to safeguard passwords. One of these 4 it is, and if you press randomly, you'll find out. And otherwise, you'll know to safeguard passwords, of course. Use salting and hashing and all that, and you make your password more difficult to crack. Laura 309, Jay Hindley, RSC 289, P290, and Christoph 71. On to question number 9. Ouch! What is CIA? Is it the clear intelligence availability? Is it confidentiality, integrity, availability? Is it confidential, integral analysis, or is it the Central Intelligence Agency? And a lot of you might say, this is questionable. What is CIA? But the answer is really clear. It's really easy. And it is confidentiality, integrity, availability. Whatever happened to my tongue? Whatever. On to the scoreboard. Laura took the fall. RSC 289, P290, Laura 309, Jay Hindley, and Harry 12GB. On to question number 10. Multiple select. How do you prevent a brute force attack? Do you set a limit on login failures? Do you increase the password complexity? Do you set a password of a good length? Or do you pay the brute their money? That's how you stop a brute from attacking, right? So set a limit on login failures, increase the password complexity, set a password of a good length, or pay the brute their money. Any of these answers could be right. And everybody got it right. Yay, except 2 who would pay the brute, and I don't know why. Scoreboard says Laura 309 still at the front, Harry 12GB, L, Jay Hindley, RC 289. And we're on to 2 more questions. A solid network system helps reduce the risk of unsuccessful security updates, bad breath in the morning, disk space shortages, or data loss, theft, and sabotage. So a solid network security system helps reduce the risk of... And somebody has lost it. The right answer is, of course, data loss, theft, and sabotage. Wouldn't it be great if it also took care of your breath in the morning? Scoreboard says Laura 309 at the front, Harry 12GB, L, Jay Hindley, and RSC 289. And the last question. That's right, Mishifu. Last question. What is 2FA? Is it they wrote no limits in the 80s? Is it 2-factor access? Is it 2-freaked authentication? Or is it 2-factor authentication? So which one of these is it? Don't be a donkey, press the right answer. 2FA means yes, 2-factor authentication. Who was that? I don't know, whoever was that pressed the 2-factor access. That's one who goes really fast and doesn't read. Anyways, at number 3, we have Jay Hindley. At number 2, we have Harry 12GB. And at number 1, we have...
Oh, here comes trouble.
Laura 309. Congratulations to all of you. We hope you had fun playing this game. And thank you to AVM for sponsoring the quiz. We will be back tomorrow with another challenge. Until then, I'm off.
Okay. So, take a seat. Get comfortable.
So people get in or decide to keep out, take your seats. We would like to kick off this plenary session.
All right. So I'm Wolfgang. I'm a member of the program committee, and welcome to this Monday afternoon plenary session. So might you perhaps close the doors in the back so we get the chatter, keep the noise out. Thank you. And as a first speaker, I would like to introduce Constanze Bürger. She's working for the German Ministry of Interior and Community, formerly called Bundesinnenministerium, but actually it's the German government. And she's going to talk about IPv6 in the IPv6 deployment in public authorities. Constanze.
Thank you. Hello, I'm really happy to be here. My first RIPE meeting was also in Berlin. It was RIPE 56. I came here fully overdressed. The first, I went home, took my jeans and my t-shirt from the board and came back. This was my first action in the RIPE meeting 56. And after that, I found very, very good people in this community, friends and advisors, and I'm thankful and really happy that I can be here and to tell you our story. My name is Constanze Bürger. I'm working for the Ministry of the Interior. I studied computer science years ago, and the first slide I want to show you and to introduce you is that stuff you know. That's the IANA structure. And what is embedded in, it's our local internet registry. Because the government, the German public administration is operating a local internet registry. That's very special. And we are proud to do this. I do this for 10, 12 years. And it's really fun, and I learned a lot over the years. It's, you see this in this part. First of all, we have a very interesting and complicated heterogeneous state structure. After the World War II, the alliance separated the power, and therefore you can find here in our state structure, okay, sorry, go back. Women in Technic. Can I go back one slide? No. Yes, yeah, okay. You see here our structure, where it's really heterogeneous. We have a federal level, we have federal states, we have authorities, we have municipalities. And after the World War II, the power was separated. And therefore, after our constitutional rights, we have a lot of independencies in our administration. And therefore, we had been really proud and really happy that we overall got an address space for the whole public administration of Germany. We have an address space in /23 with unique worldwide addresses. We are independent of network providers, and we are going to manage the addresses centrally and secure. We have transparency over the addresses. And this is a new fact. The local internet registry is managed by the Federal Ministry of the Interior and the Agency of Frequency Digitization. We designed address frames for the federal level, for the states, and for municipalities. This is a really heterogeneous structure. And from this heterogeneous structure, we want to hand over the independency of our administrations. And therefore, we developed this organizational picture, what you see here. We are going to lead the local internet registry by the ministry and by the agency. And we founded a new organizational part. And these new parts are called sub-LARs. These are small LARs. We hand over the blocks of our address space. And these blocks are able to use in an own manner. They have the possibility, the countries, the municipalities who can justify the address space, all of them can run a sub-LAR in our environment. You see here, we have 17 sub-LARs from the states. We have a sub-LAR from the finance sector. We have a sub-LAR from retirement sector, from the polices, from military, and from the federal level. All they are, they can be independent and they can make independent decisions. But the first main point is RIPE policies are valid. And then we hand over some other policies because of security issues, laws, and administrative requirements. Overall, we have a small expert working group, and I'm happy to find many of our experts here today because the RIPE meeting is in Germany, and they advise us in themes of address policy, security, and so on. This is the next slide. On the first slide, you had seen the technical issue. And we have here the address range, and we separated our address range in themes of security, laws, and administration requirements. And for instance, we have the basic German basic law. It's called interconnection law. And we have here, you see in this red block, the separation of our address space and the communication background. The exchange of data between federal government and the states takes place via this interconnection network. You see, we separated the space for the federal states, for the governments, and we have also non-governmental blocks. This is a technical challenge, and in many themes, we are not so far as we want to be. Some people from the RIPE community ask me, Constance, you have this address space for 9 years or for 10 years. What are you doing with this? What's about the implementation? What's about the deployment? It's so slow. And I can tell, yes, it's slow. It's slow because the federal structure is really slow, and we have to have many convinces. We have to convince people. We have to work in the multi-stakeholder nationwide and worldwide. So we have to convince and to find really good solutions for all. heterogeneous infrastructure are followed by a heterogeneous IPv6 deployment. We have the federal government, and here we find a federal program for IT and network consolidation. We founded a timeline in 2020 to bring in and to deploy IPv6 in the core infrastructure. We want to make this transition to dual stack by 2025, and we want to make the IPv6 only transition until 2030. Because of the federal structure, this leads us to increase complexity and variability of the network infrastructure. And the V6 migration status at the state level ranges from very far to not yet started. But I have, in case of constitutional reasons, no power to make pressure and to change it. I just can convince the people to work with us together. The public administration has to provide IT services for everyone. So we have to care the employment or deployment of IPv6 everywhere without discrimination. And this makes IPv6 mandatory for all, for the federal level, for the federal states and the municipalities. And now let's have a look at a really technical slide. I have 3 slides. The first slide is the slide, it's our wish slide, our ideal slide. The second slide is the worst case slide, and the third slide will be the idea of a solution. We have a problem. We can't regulate, and we don't have the power to make laws. So therefore, you see on this slide the ideal situation: routing by one single provider. We have n public administrations with different prefixes, and we have one provider aggregated route in one AS. This is the ideal situation because we have worldwide one AS entry. This would be cool. And I would be happy about this situation. But in the worst case, this is the same situation in the worst case. We have n administrations with these prefixes, but I can't aggregate this administrations. You see here, this is administration 1, 3, 5. And if I assume 2 providers, I can't aggregate them, and I have at least worldwide n additional AS entries. And this would be a catastrophe. So we know this is the worst case, and we have to work on this. And yes, we have to engage the people to find a solution. What could be a solution for this challenge? This is an example, an idea of a solution. We have 2 providers with maximum aggregation. We are going to, on the strategic level, to decide and to identify aggregatable blocks. We are thinking about which blocks could be aggregatable. For instance, for the police, for the schools, for the finance sector. And if we assume 2 providers, we have here the block and the administration 1 to 25, or here 33 to 36, or to 50, 56, and we can aggregate them. And at least we have 2 additional new AS entries. So this is one solution of one of our problems we have because of our federal and really heterogeneous infrastructure. We work on this, and I see many people in the room who help us to solve all these problems. On the next slide, I can show you a wonderful service, and this service is a really good success story, because the ELSTER is a service from the tax environment. ELSTER stands for the German Electronic Tax Declaration, and ELSTER is full implemented of IPv6. They implemented V6 from core to edge. They started the project in 2016, and the IPv4 reachability had been in August 2020. This was a project for my Bavarian colleagues, and they worked together with also, I think, with GET. And this is a good success story, and you see here the V6 deployment had been successful. Connection statistics for October last year. We had traffic, IPv6 traffic of 52% and IPv4 traffic of 48%. And the URL is, you see here. Last but not least, why is IPv6 not only a technical issue? We learned a lot over the years, and the deployment of IPv6 is infrastructure development. IPv6 forces us to think beyond our organizations and our processes. We have to work in new organization forms. We have to engage within open multi-stakeholder groups, and we have to develop internet standards and policy common with you. We have to learn from the community, and I'm thankful that we have a good base in this community. What we also learned in these days is the standardization. V6 leads to new fields of action in the standardization for IT networks and regulatory authorities, as well as administration and politics. Because of the war, we see how important sovereign networks are, and democracy in the culture of developing things. And we stand for RFCs who will be developed in a democratic way. So I think our goal is to develop sovereign, scalable, and secure network infrastructures. Thank you for your attention. And if you have questions.
Thank you, Constanze. So, do we have any questions? We are very good in time. Yes, we have Paolo in the, is he in the audio queue or in the room? Oh, please go to the microphone. He's in front of you in the queue, so.
So, Paolo Volpato, Huawei Technologies. First, thank you for your presentation. I'm currently involved in writing a paper in RFC in the V6 Ops work group of ATF dedicated to IPv6 deployment status. And I have to say, you mentioned that in Germany, the adoption of IPv6 is probably a bit disappointing for you, but actually, if you compare to other European countries, you are in much better shape, I would say. And anyway, by the way, I will share some findings of our paper on Thursday in the V6 session. I'd like just to understand your point of view, looking from the public administration. What are the challenges or the issues you're facing which are delaying the adoption of IPv6? Thanks.
Thank you. Yeah, this question is really hard to answer. I think infrastructure development is not to be seen on political level. And the political level is seeing apps and websites running, and they understand there had been a new feature online, but it's too hard to explain how does it work, how an IP packet is transmitted. And this gap, I have to say it, unfortunately, I can overcome this gap as well. It's really hard to say. I can't go to my state secretary and say, hey, we need IPv6, and therefore we get a new structure, we have new address frames. No one would understand it. Yeah. I think the wording is really important, communication is really important, but we don't have time for communication because we have to work, we have to run the LIR, the LIR, yeah, that's one of our problems, yeah.
Okay, next Cynthia, then Tom.
So my main question was kind of like how this, you talked about.
Could you please tell us who you are? Sorry.
Oh, sorry. My name is Cynthia Revström, representing myself mostly. I'm just here for fun, really.
Which is the best reason?
Well, my question would be, since you talked about how you want it to be aggregated and only use one ASN really, how does this interact with how you currently have deployed for IPv4? Like, is it in a similar way, or is it completely spread out over multiple things for IPv4? So, like, do you want them to like kind of make the network structure similarly for v4 and v6, or do you want them to, I guess, have very different structures?
In our networks, v4 is the main protocol until now. And we have to overcome this, and we have to find solutions to do this. And we have to find a mixture between v4 and v6. But the pressure is really hard to find the way to go forward. But I can't, there are so many key players in this game, and I can't advise and say, hey, you have to turn it, and you have to turn it. I have no chance to do this.
Yeah, it's more specifically also like how one of the earlier slides, you mentioned how like it would be just one ASN for all the v6 would be the ideal thing, and one aggregated route, I believe.
Yes.
So my question was like, is that how it currently looks for v4 in German government with just one ASN, or are there multiple ones for the IPv4 stuff?
We should do this
Okay.
afterwards, and I can't explain. I'm sorry.
Yeah.
I need my colleague to answer this. Yes.
Okay, Tom, please.
Yeah. Hi there, Tom Hill from British Telecom. I wanted to thank you actually in particular for the response you gave to Paolo, because I think you very clearly and very well articulated a problem that we all face, especially in service providers and every organization around the world who's looking for a good reason to deploy IPv6 when faced with the sheer benefit of it. It's very difficult to justify. So I like that you very clearly said we can't just explain how this is how IP routing works. We have to have another reason. That's very good. And again, it's been very delightful to have such a forthright presentation from a government department speaking about this, because there are not enough government departments that are speaking up about this. And I really thank you for coming and speaking to us about it, because that's brilliant. Just the fact that this is recorded is going to be incredibly useful throughout the world. So my lasting question to you was, have you any plans to solicit this with your counterparts in other countries? Please do it in the UK.
Okay. And what I do, we learn from each other, and we should learn how to support each other as well. Yeah, thank you.
So next one, Maria.
I'm Maria, I'm from CZNIC. I'm a developer of iRouting software, and I'd like to ask you why are you aiming for an aggregation to a /23 route when there is a routing software that can route all your deaggregated routes to these places where it is needed. For example, if you have one place in Hamburg and another place in Munich, why is it needed to aggregate these two routes when it may be possible to route the Munich by one route and to Hamburg by another route through different geographical places and through different network places? Is there any good reason to aggregate the routes for such a big place, for such a big country as Germany is?
It would be a wonderful idea, but in case of that federal structure, they can be independent and they can decide, oh, I don't want to aggregate my road in your eyes. So that's the first point. They are able to say no, and we don't trust you.
And I think Gerd wants to jump in quickly on this one.
Okay, okay.
Hi, Gerd Döring, well, long-time IPv6 person. I think the main reason why Constanze wants to do this is because she has been listening to the internet ISPs out there. Because look at how big their address space is. They have a 23. If they deaggregate to 48, that's 20, something like 10 million extra routes in the global routing system. So please do all you can to keep my routers from exploding. So this is a public benefit if you do the aggregation. Thank you for trying. I understand it's hard.
Yes, but I'm not on the end for this colleague. The first, I can't decide. I do this over one eyes. That's the first. I see the problem if I have the worst case. I don't want the worst case. I have to be carefully with these internet resources. I want to have a transparency. In the former times, every municipality, every administration could order address space at RIPE NCC, and no one had a clue which IP addresses had been to an office, to an administration, and there was no overview. All systems had provided to everybody. So, and there was no structure, no organization, nothing. So, and the first thing we wanted to have transparency, structure. We wanted to force the people to set up their old, historic, grown-up network structures in a new world, in new frames, new designs, a new ordered address space. So therefore, many reasons on the political side, on the organizational side, but they have to match with the technical reasons. So this is my task. Yeah.
Next one.
Jörg, danke.
Yeah, thank you so much. My name is Alex. I represent Interlear company. As you can tell from my outfit, it's my first RIPE meeting as well. I have a quick question. First of all, thank you so much for your presentation. But in your presentation, you talked a lot about V6 networks. But is there government policy towards V4 networks? Will they be abandoned after all, or what's the government viewpoint on that? Thank you.
I would love not to see V4 anymore, but I have no chance. So I told you that I can't do a law, but so many administrations are independent and they can decide, I do this in my way. So I can convince them. And if I have good arguments, then I can bring them on my side. And this we try to do. So we will run before, I think, the next 10, 20 years. So I fear,
Yeah.
Thank you.
Okay.
So
Okay, there was one more written question, and there was about the AS numbers on the slide, but I guess the two AS numbers were just an example.
yes.
Okay.
Yeah.
So-
They after the RFC.
Yeah,
we
and
learned
also
this.
ASs are supposed to be separate networks. Why are using one for everything? And I guess that also has been answered. Like you said, the AS numbers on the slide were just an example, and the entities are free to choose the AS number they want to go with.
Okay. Thank
Okay.
you.
Thank you. Now you can all thank Constanze. Thank you for the good collaboration.
Thank you.
Our next speaker is Massimo from NTT, and he will report on experience of 1 year of RPKI operations.
There we go. So, good afternoon, everybody. My name is Massimo Candela. I'm really happy that finally we are back doing these RIME meetings in person. It was about time. And I'm a senior software engineer at NTT. NTT is a large company that offers a lot of services, among which we are a tier 1 provider, and I work in our global IP network. As the name suggests, the global IP network is a large network, so we need software to keep it under control, and that's what I do together with some amazing colleagues. Some are also in this room. We do automation and monitoring of the network. Last year, exactly 1 year ago, RIPE 82, I presented a system that I created to reduce human error and to ease our internal RPKI operations. And at the end of this presentation, I got a question from Randy Bush. He's always on point with his questions. And the question was, yeah, okay, but what type of errors you were trying to reduce, what type of human errors, and how many were you doing it, how many are you doing now? And I thought this, at that time I didn't have these numbers because, I mean, the system was brand new. But I thought it was a really good question, and I thought that it deserved an entire presentation, which is this one. And I think that we all do errors, and by sharing this, I think we can all learn from it, and this can be helpful for somebody that is embarking in their RPKI journey, or that they just embarked and they have to deal with it. So, the presentation is 1 year review of RPKI operations. But let's start with some facts. The 24th of March 2020, this is a screenshot I did. We started doing a route origin validation. So this means that we started rejecting RPKI invalids. And together with creating the ROAS, these are usually mentioned as the 2 steps to implement RPKI. Now, this is, maybe this is the overall message of this presentation, is like, one does not just implement RPKI and after it's just get finished with it. In reality, you will have to maintain it, you will have to keep an eye on it, and it will involve your daily operations. In particular, it will for sure require some additional knowledge in your team, but it requires also some additional procedures. And while for other technical solutions, we have already in place some best practices for RPKI, as a community, we are still develop some of them. So when I say errors, or in this slide, mistakes, what am I talking about? I'm talking essentially to doing RPKI invalid announcements. So imagine that you are an autonomous system, you implemented RPKI, so basically you created your own RAW, you're doing route origin validation, and but at the same, so you are RPKI aware, at least, but at the same time you announce occasionally RPKI invalids. And there are various reasons, of course. There can be a typo and whatever, but I think the main 2 logical reasons are, the first one is that you want to announce a prefix and you forget completely about RPKI, and after an invalid happens, and often I got this as a feedback, like, oh yeah, but it was a new prefix. It was supposed to be unknown, right? Like, so life was going to go like RPKI never existed. But did you check? So the reality is that it can happen that there is a raw for a less specific, and in that case, you're going to do RPKI invalid. At least you should check. The second case is that you know about RPKI, you did everything, but you forgot about there is some timing involved. There is some timing that is the publication time. So before a raw that you created is in the publication server, depending on the trust anchor, it may require sometimes some hours, up to 24 hours. And there is also some propagation time, which is like the normal time, the natural time that other players of the internet, they will need to just download again the repository and validate it. And we will come back on the topic of the timing in a bit, but just this is to give an idea of what we are talking about. So what I did is that I did a review of our calendar year 2021, in the year where we were already doing route origin validation, and I collected all the RPKI, all the alerts that we received from BGP Alerter, which is an open source software that we use for BGP and RPKI monitoring. And in addition to the alerts, I took the various tickets and conversation that were created after the alerts, because my goal was to really understand what was the reason behind it. And I divided in 3 categories. The first one is wrong max length, which is essentially what I initially thought and I said before. So I don't know, we had a /20, a raw for a /20, and we started announcing at some point a /24. The second case is we start announcing a customer prefix because we have a service going on, but they had no ROA for 2914, which is our autonomous system. You may think, well, that's customer problem. I don't really agree with that. But anyway, at least it shows that there is some margin for improving communication with the customer. And third category is we migrated prefixes from one autonomous system to another, and we forgot about the ROAs, or at least we forgot to do it in time and properly. We had 71 cases of this, and when I plot them on this pie chart, as I was expecting, the biggest one, almost 60%, is the max length, and the announced customer prefix without the customer put in a ROA is 17% almost. And I'm surprised actually that the migration, which I was not expecting, is 25.5, but it was mostly one single event. So we have already an idea of what are the percentages of the various errors. So now let's go back on the timing that I was talking before. As I said, there is some timing with the publication and propagation, and you may think, well, it's fine, right? At some point, it's going to be valid. Well, that really depends on you, on what your service you have on those resources. If you are managing resources for a large CDN, the fact that they, for some hours, they will have suboptimal routing in the best case and reachability on those prefixes in the worst case, it is something that, at least for us, is important. But even if you do not care, because it's a new server, there is nothing on those resources for now, how do you define transit? How do you know that it's going to be okay if you are not monitoring? So let me explain better this question. I took here all the RIPE-RIS data. RIPE-RIS is a project from RIPE-NCC that collects BGP data from various points of view. And I also took the historic RPKI data that also RIPE-NCC has. And I did an analysis of 2021 only of the RPKI invalid for max length reason. I only took this one, the max length, because in my mind, first of all, we saw that in our case, at least, is the most common error. And I think also other organizations have the same, are in the same situation. And the other thing is that also, again, in my mind, is the reason more prone to human error, let's say. When you analyze this data, there are a lot of exceptions that you have to take into consideration, which I'm not going to go into details, which include how much, for example, you can trust what you read in an ISPAT and whatever. But this is just to give you an overall idea of numbers. So in particular, you can see that 40% of RPKI invalid for max length, they get resolved in less than a day or 1 day. The granularity here is 1 day. And so, okay, that's good. What is not good though, it could be a second, could be 20 hours, 1 day. What is not good though is the fact that the rest, the 6%, is actually takes more than 1 day. And there is one bump at the end of the time window of 1 month, which means that it took basically at the end of the 30 days, the announcement was still invalid, and it has been invalid for all those 30 days, which the window was 1 month. So it could be that it's still invalid now, or it finished 1 day after, we don't know. But it clearly gives you an idea that there are clearly some organizations that they are doing RPKI invalid announcements and they don't realize that. So what did we do to address our situation? We introduced a new automation platform, the one that I presented last year. We improved our monitoring. We introduced some RPKI specific monitoring, and we released it open source in BGP Alerter. You can benefit from it in the open source tool. We introduced a strict procedure that we have to follow, and we improved communication with the customer. So while these are 4 points, they are actually all integrated together. I give you a practical example. When we have to start announcing a prefix for a customer, we input that in our automation platform. The platform says, hey, the raw is missing. So basically, we ask the customer, add this raw. When the customer add the raw, the monitoring and automation, they is able to see it and says, now everything is good, green light, you can proceed. So you can see that there is a procedure, the communication with the customer, and all of this is supported by a technical solution of automation and monitoring. So now, I repeat, the cases were only 71 in the previous chart, and for the number of operations that a company like NTT does per day, 71 is basically nothing, it's a blip. But still, maybe it's this thing that we are originally a Japanese company. We really sometimes obsess about things, and we want, I don't know, to reach perfection about stuff. So at some point, this became a really hot topic. We had to address this. It has to be addressed. And the 26th of March, 2021 is when the blue dot that you see here is when we deployed this solution in place. And we achieve a reduction. This is a time window of a few months before, a few months after. We achieve a reduction of 87% of involuntary RPKI invalid announcements. Of course, we are trying to reach 0. There are some occasional ones that they happen because procedure is not followed correctly, but we are almost there. I would say it's a good result. A quick overview. This is the platform I showed last year. Basically, I put here, there is a dashboard with a list of resources. And when we click on these resources, we can do various changes, among which there is this is where we manage our RPKI. I divided this page in 2 columns. There is the one on the left, which is the current status of our RPKI for that resource, and the one on the right, which is the future status. So the current status is according to the public RPKI. The future status is what it is going to happen after all these ROAs here that we edit and change, other remove, are going to be applied. What it will be the future status. And how this is calculated? Well, it is calculated. I had some trial and error, and in the end, I came out with this, what I call the 4 stages of ROA. And if you want to make that joke that the first stage is denial, it was already copyrighted, already made it millions of times. So now, the first part is when we create this ROA. The ROA is staged and it's just fake raw. It is existing only in our database, and together with the real raws, they concur on calculating the future status. And if everything is correct, so if what we are announcing or what we would like to announce agrees with the future status of RPKI, then in that case, we can commit all the raws. Now, when they are committed, it means that they can be sent to public repositories, and when these are visible from public repositories, they get marked as public, which is the third step. From that moment on, we will start monitoring forever these raws, forever. However, after 24 hours without any issue, we mark it additionally as stable. Nothing really changes, but the stable one is mostly to close, for example, automatically tickets and stuff like this. Is like, okay, this is done, at least for now, everything is fine. Life goes on. Now, the logic and most of it is implemented in BGP Alerter, which is an open source tool that you can find in this repository, does real-time monitoring both for BGP and RPKI. And it is an application that you just run. You do not have to, you just have to input your autonomous system number, because it does use public repository of data, so you do not have to provide your own data. You don't need to. And there is also an auto configuration, so just self-configures. And for the BGP part, there is a huge list of things that alerts for, among which hijack detection, visibility loss, path monitoring. But for the RPKI monitoring, which is the part that we are more interested today, you will get notified if, for example, your autonomous system is announcing an RPKI invalid prefix, or if your autonomous system is announcing a prefix that is not covered by a raw, you can disable the alerts that you don't want. If your raw disappear, they can disappear because maybe somebody deleted it, or one of your colleagues, or because there is some malfunction, or because you ignore the expiration warnings and now they expire. Or you can get informed for any change that involves any raw impacting any of your prefixes or any of your assets. For example, we have it in a channel. It's really nice that if any of your colleagues changes something, there is a place where you can see all the diff every time. There is also, okay, I take it as a feedback. There is also like trust anchor malfunction alerting in case, we will discuss briefly about it, why it is important, and corrupted VRP file. The VRP file is the output of your validation, and it's an important file for your RPKI implementation. And last but not least, if a raw is expiring. Raw do expire, and all the certificates in the chain of validation, so you want to be informed if something is expiring and when it is expiring, and you don't want to just put stuff in your calendar and hoping for the best. Now, this is an example of what you can receive as alert. For example, this one is the diff I was talking about, while the last one is when RPKI invalid is announced by your autonomous system. Now, some shout outs to some amazing projects that they make my life much easier. The first one is RIPE-RIS, in particular RIPE-RIS Live. RIPE-RIS is a project where there are various route collectors distributed in the world, and you peer with these route collectors, and they pretend to be a router, but what they do, they store the routes that they receive. And they can be used for various reasons, among which the monitoring, that's what I do with BGP Alerter, or for research. And if you want to peer, here is the link, and I'm sure that there are a lot of RIPE NCC people around here that you can talk to have more information. The second one is OpenBSD RPKI client, which is an RPKI validator, stable, robust, that we use internally, but it's also the only, at the moment, that is exporting various metadata that I find really useful for monitoring, in particular for monitoring, for example, for raw expiration. And thanks to Job Snyder for implementing these features. And of course, manners, the mutually agreed norms for routing security, which I recently became one of the ambassadors. I think it's really interesting because it has a list of really concrete actions that you can read and implement for ISPs, IXP, CDN, and recently also hardware vendors. And especially there is a good community. So if you're embarking this RPKI adventure, they can help you also with that. And now let's go before to close. Why it is important, why there are alerting for trust anchor malfunction, why you can be interested into that. Well, first of all, trust anchors are an important part of the global RPKI infrastructure. And if something happens, then you may be impacted and you want to be aware of it. And another reason is that you don't want to waste time trying to debug something that is not related to you, while you would be much better spending that time to report to who is in charge so that they can fix it. And you would do also a community effort. Now, the first that we record of this trust anchor malfunction is 12th of August 2020, where we see that basically various users start reporting also on the GitHub repository that some of their prefixes no longer are covered by ROA, but they didn't delete the ROA. So what's going on? It must be a false positive. So we spent some good amount of time trying to understand what was going on. And after Job Snyder with the RPKI client team and the ARIN team, they do a call together and try to debug this more deeply because it was involving only ARIN resources. And they discovered that indeed ARIN was publishing certificates with some corrupted certificates. So you can find more details in the repository there. At that time, the main lesson, especially for me, was the amount of time that we spent at the beginning to bootstrap the entire investigation, and that possibly we needed some trust anchor monitoring feature specifically for that. So I started implementing that, and the 6th of February 2021, some of these features, they start to be useful. We have Twinic ROS disappearing, BGP Alerter sends alerts, and in this case also later gets reported a hardware failure. So the 18th of March 2021, we have that during a validation cycle, some ROAs were missing. So basically before we had a certain amount of ROAs, 15 minutes later, less ROAs, and after they are back to normal. It already happened once in the past, but we didn't give it too much attention. This time we do, and especially thanks to a colleague, my colleague Colin Petrie, which did some digging in the logs. We discovered that some manifests were containing reference to not available certificates. We do a report to RIPE-NCC, and basically, as also explained in this announcement after, basically they were doing updates in loco in the repository, and if you were doing rsync in that moment, you maybe were downloading old and new files at the same time. The 17th of June, I went to the 17th of June 2021, we discovered LACNIC disappearing over rsync. This is a nice one because we send immediately WhatsApp to our friends a LACNIC, and they fix it on fly, not even 30 minutes. And basically nobody possibly ever noticed this. And it was something with load balancers. Now, the 1st of February 2022, we have a JPNIC partial trust anchor malfunction. Some of our ROAs, we received this blob of alert and that says, hey, these ROAs are expiring. But that was weird, and we start digging, and we do a report to JPNIC, and they discovered that indeed they had a diskful issue that was preventing certificate renewal. And they do the report, and the funny story is that they managed to fix it 1 minute before expiration of this ROAS. And the 16th of February 2022, this is the RRDP of RIPE that becomes unreachable. And well, when basically we also get too many connection to rsync because everybody was trying to go on rsync. BGP Alert detects the issue, but when we do an email to RIPE-NCC, they were already aware of it, they were already fixing it, they almost got, basically it was a DNS misconfiguration, and you can read more about it there. So this was the last, and my presentation is over, you can, if you have questions, you can ask now, or you can also send by email, and I will be available the entire conference. And you can also follow me on Twitter, and sometimes I share useful information, other times not. But I'll do my best. Thank you.
Okay, so we start there.
Hello. Nice to see you, Massimo. I am Kostas Zorbadelos from Canal Plus Telecom, and we're also a good customer of NTT. So one question I would like to ask is, we have this need to create on-demand announcements, for example, for anti-DDoS reasons or whatever. This could generate alerts to BGP Alerter due to ROA missing and stuff like that. The question is, two questions actually. Doesn't entity support this kind of stuff? Customers doing on-demand announcements depending. And the second is, do you have any best practices to recommend to your customers that have this kind of need in order of how to configure the ROAS?
My answer is I don't have an answer for you, and we will have to talk about this later.
For sure, we will discuss it offline.
With some of my more knowledgeable colleagues about the specific topic.
Thank you, Massimo.
Yep, over there.
Hi, Massimo. Stavros from AMSIX. Nice to see you around after 2 years. Okay, you mentioned you use BGP Alerter. We know what it is. You mentioned you use RIPE-REASE. We know what it is. My question is, what do you do with the false positives? For example, because I also have my tool, Artemis, that I monitor prefixes, and we also have a lot of false positives with customers. And I have, for many months, chasing customers. Okay, guys, I see that you announce this prefix with this origin AS and Y, and you actually make some false positive, like you appear to be a trusted provider of AMSIX while you're not. That's an example. And well, you're not. Why you do it? And they told that we don't announce it to the public internet, but we announce it to RIPE-REASE because it's a collector. I guess you have similar situations like this, right? So you cannot force the customers to not announce things to RIPE-REASE because it's a nice collaboration tool that we all base to make tools. But then in that case, the customer is legal, the guy is legal. He doesn't announce anything to the global internet. So if you go to global table, you don't see it. So have you come into this problem and how you fix it?
Yeah, so first, okay, I get what you mean. So essentially you mean like there are some routes that they are only announced to RIPE-REASE, and that those, they create noise in the monitoring. Yes, that is true. And we already dealt with this basically at the beginning of the project. And I have to tell, the reality is that these are not a lot, and occasionally they still appear back, but mostly what we did at that time is, and we still keep them updated, we define thresholds. So most of these routes, they are visible only from 1, 2, or a small amount of peers, and you can safely discard those based on thresholds. And basically, if you look on the BGP Alerter configuration, you will see that in the config file, I periodically update thresholds for most of the alerting that removes this kind of behaviors. Fortunately, they are not a lot though. So that is a good.
Yeah, we do exactly the same approach. So good to see that you do the same stuff.
Cool.
Perfect. Thank you very much.
Okay, last question.
Job Snyders. I wanted to reply to the engineer asking about DDoS mitigation and ROAS. If for any purpose you have a need to be able to immediately deaggregate in BGP, the best current practice is to pre-populate RPKI data such that you can deaggregate. So that means create your ROAS for say /24s ahead of time before you need to pull them through a DDoS mitigator.
You should never have moved too fastly.
Okay, thank you, Massimo. And I can only recommend to follow his Twitter account. He has really cool stuff up there. So thank you.
Okay. Perhaps the people in the room haven't noticed, but this is a hybrid meeting. And so the next presenter will be a remote presentation. I see him already very big behind me on the screen. Duke, you have the you have the stage somehow. Yeah. Thank you.
Let's see. I cannot share my screen yet. It's still got Massimo's stuff up. Okay. Well, all right. Hello, RIPE. My name is Doug Midori. I'm from Kentic. It's a talk I put together with Job Snijders about measuring RPI using NetFlow. And I wanted to thank everybody for allowing me to present this remotely. Unfortunately, I was not able to make it to Germany this month, but hopefully I'll be in attendance at the next conference. So in this talk, I believe we have this is a good news talk, I think, around RPI. With some stats around looking at where we have where we've come. So where are we with ROV adoption? So RPKI stands presently as the internet's best defense against hijacks due to typos and other BGP mishaps, like origination leaks. And like any distributed security mechanism, a challenge is to you need many individuals to make take an action, make a decision to adopt, to participate in the system. And at the outset, you have a chicken or the egg issue of, why would you bother going through the process of rejecting invalids if no one's creating ROAs? And why create ROAs if no one's rejecting invalids? And I guess I'd like to present some data to officially close that phase of the RPKI evolution. So in the past couple of years, we've had a lot of movement on both sides of that question. So there's been a lot of adoption of RPI, rejecting RPI invalids from the tier ones. So Aurelion, Lumen, and a bunch of other companies that have yet to go through a rebranding. And then on the other side of it, and the creation of ROAs, there's been an inflection point as of a couple of years ago, where the stats are moving in the right direction. So this is a graph from NIST, is a U.S. government agency that keeps statistics on a lot of things, and they have a web page that's an RPI monitor that they keep up to date. That's very handy, and it does a lot of graphs along these lines of looking at temporal trends. And in this case, you've got the yellow line is how many routes in circulation in the global routing table have no ROA, so therefore cannot be protected in the RPI system. And then the green line is those that have valid routes, and so those are moving those guys are moving in the right direction. And then if you squint your eyes very closely, you can find there is a red line that looks like it's the x-axis, and these are the persistently invalid routes. There's a very, very small number due to some misconfiguration or another. This is the V4 plot. The V6 one looks very similar. All right, so it takes 2 steps to reject an invalid BGP route. So as we mentioned, on one side, someone had to create, the owner or the person responsible for the address space had to create a ROA to assert the valid origin and prefix length. And then on the other side, you need networks that are dropping invalids. On that step 1, we have like the NIST website I mentioned. RipeStat has got some neat tools for tracking similar stats over time. We'll look into those in a minute. And on the flip side, this is an active area of research that is a known hard problem. How do you passively determine what ASs are dropping invalids? In this talk, we're looking actually more on the left-hand side here. We're going back to the measurement of how many ROAs are created, because I think we've got some new data to bring to bear that might help our understanding of where we're at with the progress. So if we were to look at, again, pulling up just a recent day in V4 on the NIST monitor, NIST RPKI monitor website, we see something like 34.1% of the BGP routes in the global routing table are valid, to about twice as many are not found or unknown. I may use those terms interchangeably here, routes without a ROA. So it's 2 to 1. Unknown to valid, but I guess the question is, what proportion of traffic is safeguarded by that 34%? Because I think we all know that not every route is created equal, and not every route carries the same amount of traffic. Again, if you were to pull up the stats for V6, they look pretty similar to V4. At this point in the talk, I'll make a little detour to go back and tell a bit of history here. So back in 2019, a long time ago, long before the pandemic, another world, Job Snyder, my co-author, along with Paolo Vicente, were trying to alleviate some of the concerns around RPKI adoption. Specifically, would a network lose important customer traffic as a result of rejecting invalids? And was there a way to allay those fears by answering precisely what it is that would be disrupted had they took this measure? So they worked together to extend the PMA CCT tool to incorporate a RPKI evaluation along with NetFlow analysis, so you could answer that precisely for your own network, decide, have that information, and before you make that decision. And after they did this, Joe brought out an email to the Nanoglist, possibly the RIPE as well, and then put out a call to action to the premier, NetFlow and analytical platforms that they ought to adopt this feature because it would be good for the customer base and good for the internet. So I'm at Kentic now, and Kentic heeded this challenge, and within a few months we had this feature in our product. And so a lot of this data is going to be based on that, using that functionality and some of our aggregate data and what we can tell about RPKI. So again, going but way back to 2019, that email was February, and then the following month in March, Job, who was at NTT at the time, gave a talk at DKNOG about this development, and then also running it over NTT data just to get a sense for if they were to look at the volume of traffic they handle, how would that break it down in the various buckets? And so in this was a graph presented at the time. You can see that the amount of RPKI unknown or not found traffic was the majority, vast majority. There's the orange or yellow is valid, and then there's a very small sprinkling of invalid along the top. And we've come a long way from here, so remember this breakdown because it's going to be different. And then finally, he gave maybe a provocative slide here saying, well, maybe not everybody needs to do RPKI. Given the consolidation in the internet industry, if you were to get a bunch of the content providers, a bunch of the largest eyeball networks, and maybe some of the DNS service providers, if you had like a very secure core, that would be a small number of companies that could deploy this, but with a very large amount of benefit, because they handle a lot of traffic and a lot of the most important internet functionality. Right, so why does Kentic have anything to say on this? So Kentic has 300+ plus customers that we do net flow analysis for. About half of those have opted in to have their data be allowed to be used as part of aggregate analysis. And this is what I do use. I in the news for reporting on a country going offline, like if Myanmar is offline, I'm using our aggregate net flow data to make an assessment on is a country or a particular network up or down. It's important to note that this any of this analysis and the work I do with this data is subject to the biases that are that exist in our customer set. We have NSPs, CDNs, various types of digital businesses that are in there. But we do skew towards the US in our customer base. And so it's worth noting. I still think this data is still pretty informative. And as we mentioned earlier, we adopted this feature at the request of, at the call of Joe several years ago, mostly just to answer that question of what would be your, if you were to start dropping invalids, what would happen to your customer traffic. But what's neat is I can take that same functionality on this very versatile analytics platform and then answer a variety of questions like, you know, how are we doing in traffic volume on the various states of RPKI. So let's see. So as was done in the PMA CCT tool, there are 4 cases of RPKI evaluation. There's valid, unknown, invalid, and then there's also invalid but covered by a valid or unknown route. So Joe wanted me to emphasize that this is not part of any kind of IATF standard or RFC. This is simply the analysis plane. On the right here is a screenshot of bgp.ag.net. Many of you guys probably recognize this format. This is an example of a /24 that is RPKI invalid. If you're trying to send the traffic to this particular IP, this .48, it would use the /17 route, which would be unknown because there's no ROA, and that's how you would deliver that traffic. So those are the 4 categories. And this is what we came upon. So looking at data from, I picked a week from a couple of months ago, we're seeing that the majority of traffic is going to valid routes. And this looks a lot better than the 2-to-1 thing of unknown to valid, if you remember that from the beginning of the presentation. So we're seeing 56.4% of traffic is valid. Yeah, the persistent invalid traffic is, again, very small and very likely not a reason to not drop invalids. But if you don't want to take my word for it, feel free to take a look at the PMA CCT tool or our tool. You can run the same analysis to see if you would be losing any customer traffic. But let's take a look at, let's pivot now, and we can use the RipeStat tool that has this neat RPKI by country functionality, and look at, you know, how do these things differ from when you're counting either routes or counting IP space versus looking at net flow to a country. So when I run, so I'm based in the US, and when we run this, we see a big difference in these stats. So we see for V4 and V6, we're seeing 24% of the IP space is covered with ROAS, but then we're seeing 58.5% of bits per second measured from net flow, combined V4, V6, and going to routes with ROAS. We're calling it valid traffic for lack of a better term. And so why is that? What's happening there? And it's the result of some major RPKI deployments. So in the US sector, Comcast and Spectrum are major access networks. These are eyeball networks, and they have done tremendous work in RPKI deployment, and they are seeing near complete, almost all the traffic going to their routes is going to RPKI valid routes. On the flip side, for content providers, Amazon and Google are at 100%. Cloudflare is very high, again, due to recent RPKI deployments. And so while these networks may account for just a minority of the BGP routes or the IP address space, they account for a very large, maybe not majority by themselves, but a very large amount of traffic. And this is what is pushing up the stats. And so we can take this technique and kind of travel around the world. Again, we looked at US, where the number is, in this graph here, the blue is, this is the net flow base bits per second, combined V4, V6, traffic to routes that are valid, RPKI valid. And then in orange is V4 space covered with, V4 space covered by ROAS. Gray is V6. So Canada, Brazil also look better in net flow. Mexico goes the other way. It's actually a little bit lower. We skip around Europe. You can see a variety of outcomes here. So you have Turkey and Ireland have big RPKI deployments. That shows up both in the those RIPE stats of covered V4 address space as well as net flow. This presentation this conference is in Germany, and so we're seeing again another improvement. The numbers look better in net flow than it does in just looking at BGP alone. The largest contributor there, or the biggest destination, is DTAG, which isn't a big surprise. And then and what's pushing up the stats there is a huge RPKI deployment on DTAG. And then on the as you go down this spectrum here, Great Britain here in GB is another example, maybe one of the bigger ones in Europe, where the stats for traffic to the country looks better in net flow than a strict BGP analysis. If you go over to Asia, these numbers are all over the map, just like Asia. So we have Taiwan and the Philippines have big RPKI deployments. The numbers agree both in both NetFlow and BGP analysis, and then South Korea and China have very little RPKI as it stands. Also with this, with the ability to do NetFlow analysis with RPKI, you can kind of look at traffic in different dimensions. So one of them is just by protocol. We break it out by V6, V4. We're seeing a much higher percentage of traffic to valid routes in V6 than V4. You can form your own theory. Let me know if you've got a good theory on that. If we go by protocol, or sorry, by port, you see port 443 has a very high percentage, and I would theorize that is probably related back to a few slides ago when we talked about how the some of these major content providers are doing RPKI. That's going to push up a lot of the 443. I'm happy to discuss that with anybody. Another thing that was neat within the RIPE stat thing is, so with this temporal plotting of how things change over time, I was able to pick out times we could see movement in that stats and movement in our stats. So in this case, there was a big deployment in RPKI deployment in Poland in late September of last year, where the percentage of IPv4 address space covered with ROAS went from 39 to 64%. And at the same time, we saw a change from 46% to 60%. So it's not a one-to-one movement, but they're related. These things are correlated. So in the previous talk, Maximo was talking about some of the outages that have taken ROAS out of circulation. So there was an outage in Taiwan, the Taiwan NIC in September last fall. So I looked into that when it occurred, and we saw no traffic seemed to be disrupted, which is good. And then we were just in our system, we just were classifying all the traffic going from valid to unknown as it's supposed to fail appropriately, and then transitioning back to valid once the system was back up. And that's how it looked to us. There's also some interesting phenomenon when you break it down by the hours of the day. There are the breakdown between RPKI valid traffic and unknown, which are the two main categories. Does not stay consistent during the day. So there's a little bit of an undulation. And I think the theory, the explanation there is that the breakdown is different on fixed line providers as it is for mobile carriers. Not all the mobile carriers have got large RPKI deployments. And so as people shift their daily activities from during the day, maybe more on fixed line to the evening when they're on their phones, it changes this distribution. But it's just kind of another interesting observation when we were digging into this data. So to summarize, I would reiterate the best current practice is to reject RPKI invalid BGP routes. By rejecting these invalid routes, you are protecting your outbound traffic from not getting misdirected by you accepting a route that you shouldn't. This is due to a typo or a leak, origination leak, and we'd argue that it's not a legitimate, it's not a risk to legitimate traffic. But again, you don't have to take my word for it. We've got tools out there. You can check this for yourself. And then the other recommendations is to not link things like local pref or communities based on validation states. The concern there is, especially for much larger networks, is that if there is some sort of a loss of connection to the validator, and your routers are going to then announce potentially a lot of routes in a different state, this different community or different local pref based on this the transition from valid to the unknown, and we're going to create a lot of churn if people do that. So that is a concern. And if you have any questions, please reach out to myself or Job. We are the B2B A team, according to Job. It's me, him, and his cat. They're pictured on the right.
Thank you, Doug. And let's open the floor for questions. And I think Jen was the first in the queue. So go ahead.
Hi, Jen Linkova. Question, so if I got you right, you were looking to the destination addresses, right?
Yes.
So I'm just have a theory that maybe situation for invalid even better, because I'm curious if you looked at the sources, because I guess some of the traffic is just a white noise in a scan. Some just random traffic sent to some random destinations for scanning or something. So it's not a real, actually bidirectional flows when you see actually some responses in the invalid prefixes.
Oh, okay, you're thinking that's pushing up the traffic scans, or
yeah. So I'm just curious if you looked in the sources, if you see any actual like bidirectional flows between when someone is sending traffic to invalids and getting some responses back.
I did not I did not try to filter for bidirectional flows. I guess my assumption is the vast majority of the traffic is actual traffic, and I don't think the scan would amount to the same amount of traffic that a network carries. That's my theory. But it's a good point.
Next one.
Hi, my name is Cynthia Redström, and my question was mainly regarding the, I guess, temporal awareness you saw, which I found quite interesting. And I'm wondering, was that looking at the entirety of the world, or were you looking at some specific place? Because, like, of course, like, I would assume it's going to be more similar if you look at the entire world because of different time zones, but like you might see more interesting data if you just look at, like, for example, Western Europe or something.
Yeah, you're right. So I think what's happening is I'm looking like I was looking at the whole world as far as what we see. So you're right. You're talking about like everything's gonna be out of phase of like human activity is gonna be out of phase if you're looking at the whole world. And so I think what we're seeing is just overrun by U.S. Traffic, because we probably got a lot more of that. But yeah, if you were to isolate a different country, then it would probably be even more pronounced if I were to just take Germany, which is just in one time zone, and it would likely be more pronounced. That's a good point.
Yep. Thank you.
Next.
Peter Hessler with the OpenBSD project. My question is so we're familiar with the Aaron Tal situation with RPKI, and I wonder how much of the traffic you saw is covered under the Aaron Tal and would be unknown in many locations who are not willing or able to agree to the Aaron Tal license.
Peter, I don't know the answer to that question, but that is an excellent future investigation. I like that idea, but I don't have the answer.
Thanks.
Okay, I don't see any people queuing at the microphone or virtually. This is your last chance. Otherwise, thank you, Doug.
Thanks.
I'm tempted to wave at the big monitor, but that's totally useless. Okay, housekeeping, please stay tuned. So again, please do rate the talks and do nominate yourself for the RIPE PC if you're interested in working with us. You can nominate yourself until 3:30 tomorrow by sending a mail at pc@ripe.net. Until now, we have received 1 self-nomination for 2 open slots, so please don't let us die there alone. And yes, with that, we will close this plenary session. And after this 30-minute break, there will be a BOF on future internet and protocol design and what we expect from the internet in the future. It's hosted by Jelte Jansen and his colleagues, and I think it's going to be quite interesting. So see you back in half an hour. Is it in the side room?
I think it's in the side room.
Okay,
Yes,
I think
it's in the side room.
Sorry.
So that's this way.
Okay, so that direction. See you.
Staat er daar zaten? Oh ja. Ja.
Can I just put it here?
I raise the level as soon as I see that you want to speak. It's switched on, so you don't have to press a button or something. Welcome.
Goed dat we het nog even proberen.
Sorry. Yeah.
Oh.
Did you switch it? No, I didn't switch it. Oh, you switched it. So if you want to, yeah, okay. Now we change position. You're very tall. No, I'm just jumping behind you.
Finicky things. Yep.
Fly like an eagle. right around the left.
It feels fine. My head's too big. Uh-oh. Oh, there's. Kijk. Nu. Oh, typo on slide 1. Kijk. Hallo. Kijk, ook iemand aan de andere kant gaan zitten. Ja. Hey. Hey.
Sister will have stickers. I don't know a sticker either, so we can do the. Why are we going to the open dance?
Het idee dat hij inderdaad op wegzakt.
Yeah, Mike. You lost the right ear. I was like wondering what happened.
Apparently I move too much. That's going to be a problem because.
Already? I thought it was going to happen a little bit later today.
Okay, I'm just gonna. Yeah, probably. And otherwise, yeah. If it isn't, I can always switch to the lectern microphone. But I tend to prefer to wave and shout and jump and. How are you? Good, dear. Well, don't thank me yet. We still have to do the session. And I don't have any idea yet on how we're gonna do the discussion hybridly. Yeah, I just heard. I'm not sure if it's gonna be transcribed. I do have somebody to take normal notes, but.
Okay.
No screen now. Okay, that means the screen is going to be switched off. Yeah.
Okay. Did I already lose it again? I'm not even touching it.
We're gonna swap. Okay. We're gonna swap the other headset. We still have 2 minutes, you know. Move your head again.
Yeah, that feels better.
Okay.
So just to be, is my microphone going to be on all the time, or?
It depends what you prefer.
Well, in the beginning, of course, I'm just going to give a presentation, but after that, it's going to be a sort of open discussion. Yeah, I'm going to be moderating it. Yeah. So.
I need to watch it and then.
Oh, sure. Oh, wat een apparatuur allemaal weer, hè?
You don't get.
Can you
Steeds werkt. Er zit zelf vertraging in. Okay, if everybody would like to take a seat. Welcome. Oh, yeah, okay. Welcome to the future. So, we've gathered here today to discuss the properties of the internet now and in the future. Why are we here? Well, I will discuss that in the next slides. We were having a lot of discussions at SRDN Labs and with other people about future internet technology or improvements to current internet technology. And often we kind of veered off into this high-level discussion about what features do we want from the internet? What properties does the internet have, and what properties should it have? So we were starting out with a discussion on, say, path tracing, and we ended up like well, this is a problem of transparency. This is a problem of control. And often that was what we ended up with, and we did not discuss path tracing all that much. While we were doing that, we also had this nagging feeling about, but what if this nice, cool feature gives us something we don't want? What are the unintended consequences here? If we have full transparency, does that also give more power to surveillance systems? Things like that. I was already mentioning path tracing, so it adds transparency. So suppose path tracing is showing you the route a packet actually takes and the route the packet takes back to you. It's trace routes, but more advanced. It gives you transparency. You can see whether your packets go through other countries, through other networks, things like that. And it's a step up to path control. Like maybe you can tell the packets where to go instead of the router letting it deciding for you. But also, if you can see where all the packets are going, maybe others can see that as well. And if you give control, do you get the control? Do you give the control to your network administrator? Do you give the control to your government? Do you give the control to other networks? It's can be very tricky to decide that while you're still on the level of, well, this byte needs to be, well, if this bit needs to be 1 or that bit needs to be 0. And also I was discussing some future technologies we are researching with other people from other organizations, and often I get questions like, well, why don't you just use MPLS instead of Psion to do whatever you want to do? Or maybe that protocol sucks because it does this, or that protocol is terrible because it does not do that. And those can be very valid arguments. But you often use, yeah, but that's not the goal. We don't care about this property. We only care about that property. But maybe we should care about this property, but we don't. Maybe you do. Maybe this is a very important property. And if you don't have that clear beforehand, then it can be very hard to discuss the individual merits of any given technology. And the final big reason I'm standing here today, and most of you might be sitting here today, is that there was this feeling like there's many research and development going on, there's many new protocols being deployed, and some people would like to discuss those. Yes, he's sitting over there. Emil sent a message a while back saying, I would like to discuss some of these as well. I would like to discuss named data networks. I would like to discuss quantum networks. I would like to discuss environmental sustainability, also a very important topic. And those are very wild, different topics. Each of them could probably have an entire working group on their own. But so I was trying to find a way to converge those into one hour discussion. So bear with me, it's going to be right. So how do we frame that? How do we talk about very different things? And how do we talk between very different people? I still assume most of us here are network operators. I'm a research and development myself. I know there are a few full-on researchers in this room, and I see many, many actual operators. I already saw some governments here today. So how do you talk about, I care about bits and bytes. How do I talk to somebody who cares about governance? How do I talk to somebody who cares about human rights? They tend to approach the internet from different angles. ISOC also realized something about the internet, because the internet is computers, it's bits and bytes, but it's also a cooperative effort. It's also the properties that make the internet are the internet. So they defined what they think are the critical properties of the internet, which are an open architecture, decentralized, using common global identifiers, like the IANA things and DNS, and it must be technology neutral. And I think that's a very good way to look at the internet, but for my purposes here, or for our purposes here, it's a bit too high in abstraction. There's also a very interesting paper by O'Hara and Hall. It's called 4 Internets, and they came to the conclusion that we don't have one internet at this moment. We have at least 4, and maybe even more. They consider the way people and operators and governance approach the internet, they divide it in roughly 4 different types. The first is Silicon Valley. They call it Silicon Valley. I would prefer to call it the original networking people. So it's an open internet, partly value-based, but mostly it's just made of TCP/IP and other low-level protocols that allow anything to be built on top of that. There's also, in their view, the Brussels internet, which is mostly based around the people that are using it. And they say there's also the Chinese view on the internet, which is more of a method of control. And there's the Washington DC's commercial internet, where the internet is a way to make money and everything else should allow for that. And well, maybe not all of them, but for most of these approaches, there is something to say. And finally, there's some other interesting reading called Wither the Public Internet. And they also divide the views on the internet in roughly 3 different kind of groups. The architectural view, like the internet is made of protocols and systems, and out of that comes what we view as the internet. There's the network complementers, and they kind of see the internet as something that consists of whatever it brings. This is a hard one to define right now, but it's just like whatever the technology itself does isn't that important. It's what you can build on top of that technology. And finally, they view another group, that's the customer experience. The internet is just your browser, your computer. It is what the people that use the internet use it for. And that's even further away from the technology. It's just, it doesn't matter how my browser loads a website. I want to load that website. And depending on what your view is, you kind of see things about what the internet is differently. But talked about that a lot, scratch all that. I want to talk about the properties of the internet the way we see it. There are many, many other properties you could think of. Transparency, I already mentioned, sustainability. Maybe you think it's very important that we have more and better ways to protect against abuse. Some people would like more mobility. Some people would like to prevent all form of hijacks. Or maybe that's a subclass of spoofing, prevent all kinds of spoofing. Or maybe you would like to discuss anonymity more, or accountability, responsibility, discoverability. The list goes on and on and on. So what I would like to know is what properties we, you, us, RIPE, the community, what do we want from our internet? And how do we discuss that? I think there's roughly 2 approaches to this. One of them is top-down. So we start out with the properties the internet has, the property the internet does not have, and what properties we would like to see or not see. Or you can do it bottom-up, like we say, we take 1 or 2 protocols that kind of compete and say, oh, well, this gives us these lists of properties, and this gives us that list of properties, and just see which ones we find important. So my personal goal here is to have a kind of way to discuss things like that. I would like to do things, depending on how it goes today, I would like to do things like this more often. And my other goal today is I want to figure out what the RIPE community wants. We do a lot of research, we're in different research groups. We do a lot of protocol development, and sometimes you come up with the most awesomest things that nobody's ever going to use. And that's always a bit of a waste of time. Although it is fun for me, so as long as I get paid for it, it's fine. But it would be better if it's actually something useful and that everybody wants. Okay, we're gonna do an open discussion in a few moments. I already said there's a top-down view and the bottom-up view. I have some suggestions for potential new protocols that we could discuss. But actually, I want to kind of keep it open. So I would love to just let you decide what we're going to talk about. But I do want to talk about it in terms of the properties. And of course, I already clicked through this one. If we're going to discuss, let's keep it civil, no throwing of chairs. Let's keep it nice. Do we already have remote attendees? In that case, Jen, take it away.
Hi.
Oh,
I can just speak loudly enough. One question and one comment. So in your references, I do not see did not notice a document which I believe might actually be a good starting point for discussion, because about like 14 years ago, IAB published an RFC 5218 about what makes a successful protocol. So I'm just curious, you intentionally did not put it on the slides because you think it's not relevant, or you just don't like it, so I shouldn't even mention that? Or?
No, I did not leave that out intentionally. And I will probably, let me quickly see what it was about, because I didn't think I saw it at some point.
Yeah, it's basically like about success factors for the protocol, and yeah, why some protocols are more successful than others.
Okay, so sure, that's also very important to discuss, probably if you have something that you would like to see deployed.
Yeah, I kind of assumed we're going to talk about something which is going to be deployed.
Yeah.
If I'm wrong, I'll just
so yeah, I'm kind of more thinking of discussing things to prevent the retrospective sentence. We were so busy trying to see that we could, that we did not think about whether we should.
Okay. And okay, I got it. And then I have a comment. I kind of pessimistic in terms of, I do not think we all might have a common interest, because sometimes people in this room might have completely different opposite interests, right? Because I'm quite sure that endpoints developers, which are in this room, would like their traffic to be completely hidden from transit operators, while I, as a transit operator, love to look in my TCP dump and tell customers what's wrong there. And there are also government or other parties which would love to look in the traffic and see what's going on. So actually, I do not believe you can always find a common ground, because sometimes you want completely opposite things. You just could not agree, right? If you want to do X and someone do not want you to do X, you might not be able to do this. So, and I'm not sure we really have a common internet, because it's not, a lot of protocols are not even now designed to be in open internet, right? A lot of people want to run something in the what's called limited domains now. But it's sometimes hard to define what is limited domain when it's not so limited domain, and when it becomes unlimited domain.
Yes, let me break down the second question first. I actually would love to see that. I think that the interests misalign is actually something that's inevitable, and that's always going to be there. You and I probably have some interests at this line already. But the goal for me then is to find a way to discuss those and to see where the compromises should be, or maybe whether your interests are more important than mine, or vice versa, or maybe that we can solve both our things in different domains.
or get both of us equally unhappy.
Yeah, that's generally the result of compromise, right? I can't even see who's there.
Hi, it's Chris Buckridge, by NCC. Good stuff. I really enjoyed the presentation, so thank you for that.
Thank you.
And I think there's a case to be made that you've taken this to the side of. The last slide you had up on the there,
sorry,
is not the worst basis for a primary kind of principle for what we're trying to do here. I sort of, I'm a little bit like Jen, I was going to also reference past work that maybe is in line with this, and it was the presentation I did at the last RIPE meeting, virtual RIPE meeting, on possible RIPE principles and whether we want to develop those further. Now, I think this is a slightly different approach, and maybe it's a better approach, or maybe it's a complementary approach. And I'm not sure we've gotten much closer to a sort of final answer yet, but I also wonder if maybe just constantly having this conversation or trying to come at this conversation from different angles is a step towards what you're saying there, where we don't let that idea of what we're actually trying to achieve and what we're trying to retain as the internet evolves just slip into the rear view because we're so busy doing our day-to-day jobs. So, yeah.
I consider this complementary to what you were trying, and maybe both of those, and whoever's gonna do the third complementary thing next time, maybe at some point it is time to have a more structural discussion about what the future of RIPE networking. That's probably a question for the end of this session. Hello.
Rüdiger Volk.
Rüdiger is probably now.
Okay. Did I miss an explanation what scope or what semantics of the term internet we are actually using? When I look into public discourse, I'm seeing people talking about internet, and what they actually mean is regulating the content on certain content services. Right. For me, as a pure level 3 guy, of course, that is ridiculous. On the other hand, and so kind of my first try obviously would be I'm limiting my scope to layer 3. And maybe the interfaces were the universal interfaces where applications and users can link to it. On the other hand, I remember the times before 1990 when IP internet was much less available worldwide, when at an IETF someone explained that the internet, yeah, there are different scopes, and for example at that time the broadest scope of a true internet was the reachability of email with RFC 822 addresses. Do you have a definition, a scope limitation? I think such is necessary, as we are discussing, and hopefully also as a means for offering that for public discourse, for decoupling stuff that really is different and should be considered and developed differently.
So I gotta say that I kind of intentionally not scoped it because I would then be, so right now the scope is unlimited and it could indeed be anything. I was kind of afraid that if we're gonna scope it, then we can probably already fill like 5 sessions determining whether that scope was right or not. So for me, the internet is packet routing, because you can do anything on top of that and you can implement it in any way. So that's for me the center of the hourglass. But I think that goes for a lot of people here, but I'm already assuming there. So I kind of left it out because I also would love it if we have a discussion on sustainability, which is not necessarily packet-based or routing based. It could be, and you can have a routing protocol that takes sustainability into account, but that's then for that routing protocol. So I think that for us, for most of us, it would be one of the slides, like say we are, most of us are operators. So we kind of define the internet in terms of the way we deploy the protocols, and that brings us whatever it brings us. I may be wrong, and I would love to be corrected. And I see somebody there who wants to correct me. I don't know if I've answered your question yet. So the initial answer was no, I did not scope it.
Okay, Stefan Megaport. I think the idea to talk what the internet actually means for most of the people outside of this room is normally applications. Applications in enterprise, applications for end customers, or how I call it, the clicky, colorful internet people like to see in the evening. And this defines the internet. And the second thing here is that we see a movement away from MPLS, directly connected networks as an example. We see more and more development in the direction that we are layering internet on internet. Say, look at the SD-WAN developments. Actually, we can build a shadow infrastructure on top of it, which is out of our control. Or think of QUIC protocol. It's actually a tunneling protocol. So I think we have not only this flat internet for 20 years ago, or like Rüdiger said, what was defined in 1999, we have now a multi-layer internet on top, on top, on top. And I think we will not stop with it. The only thing we can say is that the internet will be maybe the common factor for everything which will be transported in a network, one way or another.
Processing. Oh yeah, so yesterday I was talking to somebody else about this session, and he also mentioned QUIC, and it's essentially another layer on top of UDP. And I was thinking, well, yeah, so the web people are inventing the entire internet and all its layers on top of HTTP. So yes, we're gonna have many layers, and the layers were never actually layers in the actual internet anyway. So I'm a DNS guy that's already encompasses at least 3 layers and probably more. And it's not as abstractly clean as you would want it to be, or maybe you don't want it to be. But yes, that's a good point.
Just to sort of continue from the sort of previous comment, I think sort of if you go and talk to any of the typical users out in the street, the young people, to them the internet is this magical cloud that they sort of interact with through Facebook and sort of WhatsApp and whatever. And there, I think what we're seeing there, that a lot of it is being put into this totally proprietary universe where your DNS isn't there anymore, because they talk to an app, the app talks to sort of the same provider's servers somewhere using their own sort of things on top of the internet. But it's going to be a totally closed world, and that's actually a big dilemma for us, because suddenly you have all these islands.
Yes, so that's what I would see as a property that we would not like to have, the siloization of the internet. I think there's also been some very recent efforts to make that better. Unfortunately for some, that kind of comes from governance. And that's something a lot of people also don't want to see. But well, yeah, so the initial cynical conclusion is that the happy little free internet we used to have is gone, and it will probably never come back. But we, especially as people that are actually pushing the buttons and turning on things or turning off things, might still have some influence on where it goes. And that's my hope and dream and happy little thoughts.
Rüdiger Volk again. Simple explanation question. You were pointing to interference from governments, and I didn't get what activities and restrictions you were actually talking about.
All of them. Now, so last RIPE meeting, or maybe one before that, there was a buff about the Sion protocol. Yeah, and I mentioned it, and of course.
Is there already a government that took the bait that they can get their sovereignty?
I don't know. I'm not in government, so.
I doubt that even the Swiss government is on it.
Could be. Now, so I mention it now because some people dislike it or file it away already because they say, well, it just gives governments a big red button to shut down everything. And I'm not sure that that's true. I've only just started researching it myself, but that is one of the examples of this protocol sucks because it does X, and maybe it does, maybe that's true, but maybe it also gives us so much more on other ways that it's still worth to try. And I want to have a way to discuss those without the chair throwing and the shouting.
Sorry, if I might just sort of basically respond to Rutger. We have a working group that's actually tasked with just dealing with sort of interacting with governments. And as a co-chair of that working group, I just sort of really encourage you to come to a session where we're going to talk about, among other things, one way the governments are now really going to break the internet as we know it.
Thank you.
Franziska Lichtblau speaking for myself. What you said is we would like to keep our free and happy internet from the old days, and I think many people in this room would agree. And what I observe is that we are very good at talking about technology because this is what we do. We push packets, we analyze packets and so forth. But what I see if I, for example, talk to my former students or, for example, the people from the project that you just mentioned, they don't even get those values. If you tell them, oh, like this proprietary silo internet does violate a bunch of values that are very dear to me, they're like, what? Which one? And I think we have taken those values for granted for a long time. We try to do a lot of outreach to like a younger community, bring people here to teach them and show them our values, but we need to find a way to communicate those to a broader audience because I think they don't even know that they exist and that they could develop their like new protocols, internet, whatever, in another direction than pure functionality. At least that was my observation.
And do you have any idea on how we can do that? You're not getting off that easily.
This is where I was running away. I mean, for me, in like my former position, it was more or less simple. I tried to drag people here. That was one of the best ways to show them how we interact. There is obviously the idea we need to be like more friendly to people and whatsoever. But for example, now what I do, if I reach out to people who, for example, still do internet teaching, I always make sure that they are aware that they also need to teach those aspects because that is something that made the internet the place that we actually want it to be. So I think my like cheap suggestion would be those people who have a voice should use it and take at least, I don't know, 10 to 20% of our great technology brain capacity to also just remember to phrase our values to other people. I don't have better ideas. Please, people, come.
There are ideas. Vesna.
Hi, speaking for myself. My name is Vesna. Answer to your question, how could we do it? In addition to what Franziska said, I think we should go to them and not only expect them to come to us. And that's already like the silo mentality, like there is us and them, but that's where we are. And my second suggestion is, oh yeah, if we do want them to come to us, we could create an end user working group, applications working group, like some layer which would actually enable those users to express and coordinate their work so that we don't stay on the layer 3 if we think that that is actually important. So the governments have a working group where they can go, but where would these other people go? Even if they would come to the right meeting. So somehow the end users working group.
Yeah, I was. That's an interesting suggestion. I had not thought of that. Would, of course, the first dangerous question is: would end users show up then? So because I was kind of the direction, if we're talking about new working groups, I was kind of thinking maybe some more of a kind of a future tech working group where us researchers could talk to us operators. I'm kind of in the role of both here, so it's kind of difficult, but I talk to myself all the time anyway. But yeah, end users are the ones that we're all doing this for, so they should have a voice there. In the back, I can't see who's there.
Stefan again. Where's my red line? I think in my personal opinion, companies tend to think that they own the internet. As soon as they get IP address space, they're not talking, it's given to me and I have to give it back one day and it's not my property. They think more, this is my IP address space. You hear it a lot. And now they also say they make business with it. So they earn a lot of money with these IP addresses, with the DNS services you mentioned, all these things. Why should they send people here to these meetings if we say we want an open internet without the influence of big companies, which is a pure internet? Why should they send them here?
I personally do not think that having an open internet has to conflict with making money on it. It's unfortunately making the most money on it. It tends to be by closing it down and grabbing every customer there is. But well, the answer to your question would probably why have they been sending people here always anyway? That's not the.
How many people are here more than the first time? How many people are actually here? And the first timers who are here gets this normally for free, but the hardcore people here you meet every time. Wouldn't say 200, 300 people you have always in the meetings? And they would even come if their company is not paying. They would pay from their private money to be here.
But their companies do generally pay it.
Sometimes you have to take holidays for this. So days off.
Okay.
The question here is how to this is divergent ideas. One say this is my internet, I own the internet as a company, and the other thing is we want to have in a way an open internet for everyone. And this other point here is I want to say how many people are actually connected to the internet nowadays? How many people are living on this planet and how many people have an internet connection today?
Lots, not enough. But still, I don't think while those things might conflict a little bit, they don't exclude each other. There is still money to be made on an open internet.
I would see in the future.
So actually, that could be a property that you could say like you should not be able to make money on the internet. That's probably a bad idea, but you could state that as a community of internet operators and just say we're gonna make our own internet that's completely free and open and it's not allowed to make money there. I don't think it's gonna fly.
And who's going to pay whatever resources are needed for it?
That's yeah. So it's still there has to be some business model behind everything. So
of course we could define an internet that doesn't need resources.
Do you have any suggestions?
Oh well, do a metal cage and fill it with cement, and well, okay, yeah, no communication then.
Yeah. This is now the internet. That's a brick.
Everybody gets the same.
Very
Nothing.
Yeah, very true.
For part of the discussion, I would say, well, okay, not every venue, not every group is good for supporting every purpose that you can think of and every potential audience that you would like to address. So I think it is perfectly correct that we keep in this group to a very large extent to the nerdy interest and to the interest and the capacity of dealing with the lower layers of stuff. And if we're talking layers, DNS actually is fairly low layer. Though, well, okay, it has its own tower of stuff. For some of the discussion and the outreach into the general public, it looks to me like the Internet Society is trying to address that. And, well, I cannot really judge how well it's done. I don't know anything that's better at the moment. The one keyword that I'm seeing that we should advertise to and help ISOC to advertise is the concept of permissionless potential of innovation. That nicely also appealed to certain political venues, while not kind of predefining special interests groups that benefit from it. And for, say, groups and events like Franziska was pointing to, yes, for getting new blood engaged here, I think the most helpful thing is to allow young folks to experience exactly that permissionless space as such. That's something that can happen on the side of meetings like this, but probably not the only place for it. And well, okay, that's all for this round.
Test 1, 2, 3. Yeah, okay. I have a question from an online participant. Daniel Karrenberg from RIPE NCC asks, how about teaching internet history with an emphasis on what was it exactly that made the internet the successful technology that it is today? And of course, implying that some of these properties are worth keeping.
Yes, please do that, Daniel. No, that's actually a great suggestion. I never had any internet history because they didn't even think that was something that had a history when I was in college. But I'm not quite sure whether there's something like that now, and it should be also wider than just college. But yes, I think that explaining to people why the internet became what it was is one of the best things all of us could do.
He's replying and he is saying, I am doing it, but a single person cannot do that structurally. So.
Yeah. Well, thank you then, at least for whatever you already do. Was that the only one there, or okay? I think the one in the back was first, right?
Okay. Thanks, Rob Evans. I'm thinking that in another room in this hotel at this very moment, there's the academic meeting going on. So exactly the sorts of people that Franziska was talking about are here in this hotel talking, and we're really missing an opportunity. It's the vagaries of right meeting restricted times, but there are people here we could be having this discussion with about introducing them to the way that we work. On what Daniel says, I mean, as Daniel knows, there's also a blog post from Neil on White Labs recently about how there is kind of a disconnect as universities move towards more their internet access is all, it's a business. Universities are businesses. They don't tend to teach much about how the internet works. And I think Daniel is working with Neil and others on how we can do that, because I think Daniel's got a good point. I mean, introducing people to how the internet works when they're learning, when they're interested in computer science and trying to come up with new ideas is what we need to do.
Yeah, thank you. Yeah, so about the other session, I had not realized that when we scheduled this one, and I also had not realized that this discussion would go into this direction. So that's there's maybe next time. That's yeah.
Can I quickly comment on this one? Sorry, Franziska again. I think they changed the mood of the academic session a little bit, because now it's listed under side meetings, and if you're registered with like an academic affiliation or whatever, you get that mail. If this is the case, I think it was at the last physical meeting, and I also already talked to the meeting organizers about that. I think it's a particularly bad idea, because academics, well, we know how to network with academics. We don't need to do that as a RIPE meeting. We have conferences for that. And I think we should make sure that the academics who actually manage to get here network with the people who sit actually here. And when we organize, and that's not against the like scheduling of your BOF, I was part of that timing decision, but maybe we should actually talk to the meeting organizers and re-ask ourselves what is our relationship with the academic community in that respect.
Yes, so actually that's a more general goal that I did think of, because one of the things here are also things I noticed us saying to academics when they come up with their great new research. We're saying like, yeah, well, we tried that 15 years ago and it didn't work then either. Or we're saying, well, that's a nice protocol you thought of that nobody's ever going to use. But yeah, so I want to be more constructive to them as well. That's another side goal of mine here. Now it's your turn.
Yeah, Philip Ponder. So it seems to me that in the past, say, 4 decades, we have been trying every possible variation of doing a packet network. And I don't know, whatever variation is possible, probably somebody wrote a paper about it. So it's basically like whatever as a society we want out of it, we can probably build it. Well, we can't do everything. There's some things that we can't do. But yeah, if you want a big national-wide firewall, then there will be a firewall. Somebody will build it. If we want something else, it will come. And so, but our technology doesn't have a force of its own. So from the outside, government, other things, commercial interest, forces work onto what we do. And we are sort of stuck in the middle, making it work. But I don't think we have an intrinsic power that we can say, oh, we're not going to do that. So yeah, well, I cannot do it, and then somebody else will do it. But then there's another thing that, I mean, for me, when the internet started, when I was young, there was no internet police. I mean, everybody just had to defend their own fort, and if something bad happens, like a Morris worm or something like that, then, well, people came together and fought it, and then the dragon was gone. But now people look at the government. Something bad happens. Where is the government? And to give an example, in the Netherlands, if you have a toy plastic sword for children and you walk around that on the streets, then the police will come and they will take your toy sword and they give you a fine and they say, well, you are lucky that you don't get a criminal record. So as a society, we were sort of so risk averse that whatever happens, the government has to step in and do something. And that is such a powerful force that if we say, yes, but we don't want it, it's like, yes, but who are we that we can say we don't want it? We can try to explain it, which should be done to the general public and governments and making a lot of noise. Like what you now are going to do has so many other bad side effects for society that you really should not do it. But it will basically be at an extremely high level that everybody can understand. And if we say, well, we have this really low level network protocol, it's nobody understands it. That's sort of an end result of a discussion, whereas the real interesting discussion is at the higher level, I think.
Yeah, so Your very first point was that we do not have any force, and that I think that's an illusion, because you are working on what you are working on, and only thing that you notice is external forces. But you, with your work, you also exude force to other people. It's like, why did TCP/IP win from whatever the telecom operators used 40 years ago? That the properties that the things that we run give us are a force in and of themselves.
Not a force, but it's sort of a property that we created and that happened to be picked up by people making money. They found you can make more money with an internet than with a telecom thing, but it's not that the architects of the internet could say, and now everybody's going to use the internet because it's better than a telephony net.
Noted. Oh, Shane?
Yes, Shane Kerr. I work at NS1, but I'm not speaking for NS1. Were you trying to say that protocols are value neutral? Okay, okay.
Let me see, that was not at the mic. So for the remote attendees, Philip was saying, no, that's not what I was saying. Oh, I already. Yeah. We can create evil protocols if we want to.
I'm not saying, yeah, that the protocols are neutral, that they have specific properties, and we can definitely create properties that have evil properties, and maybe we should not do it, but it happens. But I'm saying that we can't force anything from the creation of new protocols.
I see. Okay, that makes sense to me.
Hi, I'm Miriam Kuhne. I just wanted to go back to what we just discussed about reaching out to new people. And just as a fact, we've actually started a bit of a pilot or an initiative before this RIPE meeting. We had like a pre-online session to specifically targeted to students, where we actually did a little bit of what Daniel suggested and Franziska brought up, to basically talk about the values and the properties of the internet, and also try to lure them into the RIPE community. And it was actually quite successful, as in there were many people on the call that were not aware of RIPE and hadn't heard of it. It wasn't just the same old, kind of our friends at universities. And we reached out to our friends at universities, who then invited their students. So I'm hoping we can do this more often, and maybe do this in front of every RIPE meeting. And kind of as a call to action, if you have any interesting story to tell, or you want to participate, or you want to be a speaker next time, please let me know, or Franziska or the PC. And we don't know yet. This was just a one-off, and I think it was quite successful, but this might be repeatable.
I would definitely love to have more of this. It's been a bit
recorded. It's recorded. You can also listen to it. So it's on the RIPE 84 under parallel events, just for those.
And about repeating this discussion, well, not repeating this discussion, but continuing this discussion later, I would personally also like to have actually a focus down on specific new protocols or existing protocols, and to see what we think of that the properties that protocol brings us are. So that's much more low level again, and I would like to have some specific discussions on, say, RINA or Lisp or TCP/IP or RPKI or other BGP additions or replacements, and that's kind of done right now whenever a new proposal is made, but it's not done together with it's not done structurally, let's say that. And I would love to see more of that. And I would also love to see more of this high level discussion. I'm having a great time here. I don't know about you, but
Can I go first? Because I again have a question from an online participant. Adrian Perrick from ETH Zurich has the following question. The internet is being used by an ever-increasing number of safety-critical applications. Unfortunately, new attacks continue to be discovered on a daily basis threatening important applications. Should we further emphasize security and robustness properties a future internet could provide that would provide fundamental guarantees? Is his question.
Yeah,
I guess it's a question to the room, maybe.
I'm reading the room. I'm not seeing people shaking their heads or nodding particularly. So somebody seems to have an answer to that.
Hi, Blake Willis, just speaking for myself. So kind of indirectly responding to that, one of the goals of one of these future protocols that I'm familiar with, which is Ouroboros, which is a ARENA implementation, is specifically to get any queuing that is going to happen out of the network and get it up to like the application level. So like the application will not transmit if the receiver is not ready, which is like completely different than a UDP like blast attack, right? So that intention is there in a lot of these protocols. But the question is, you know, more about adoption and stuff and like how robust one can make the infrastructure below that. But it's worth pointing out that that is an intention of some of these new designs, that it's harder to attack because the protocol simply doesn't, if you want to be compliant with the protocol, it just doesn't allow you to send traffic unless the receiver is ready.
So my personal first response to the question would be, of course, but you're stating the question in such a way that you can hardly say no. Because of course we need more security. I was also wondering, what if one of the properties that made the internet what it is now was that it was so insecure, that it was so easy to create insecure applications, and we'll see in 10 years what it brings us. It's might be a tricky one.
Derma Gavrichenko speaking for no one except myself, and speaking on the topic of academic outreach, I want to point to the fact that the BGP protocol produces 5 BGPs a year, but the protocol isn't getting any better. And what I hear when I see conversations like this is the intention may be implicit to shift the responsibility for potential mistakes from engineers to academics, governance, whoever. Well, what I think is maybe it's right to just accept that responsibility, and if we make mistakes, then we'll fix them. After all, we allowed OpenFlow to exist, so what could go wrong more than that, after all?
Hi, Blake again. If I can respond to the comment that BGP isn't getting any better, I think that what maybe a different way of saying that is that like the operators' implementations of BGP that are actually in the wild on the network are not adopting the new drafts that several people at this conference have put in place to make it better, because there are things out there that are better, that have been, and a lot of effort been put into it by this community to improve the not that great state of it several years ago. But it's very slow to roll out across, especially when you talk about bigger operators that have, you know, thousands of devices, and all this stuff requires code maintenance and so forth and blah, blah. But the improvements are there. It's more just about like how long it takes operators to roll that stuff out. And also about awareness, you know, even people that have boxes that have those new security features and so forth with BGP, maybe not are even aware of them, because it's not, you know, this is not like the big new whiz bang shiny thing that the vendor's trying to hawk, right? So there's not marketing around, you know, BGP graceful shutdown and all this kind of stuff. So
I think there's a response.
Kind of. Do I need to repeat my name? I don't know. Anyway, the academic research values algorithms, math, this kind of stuff. implementation, redundancy, resilience, things easy to integrate. That's kind of side topic for most of the academic papers on BGP. So that might be the reason those improvements are complicated to actually implement on the network operator side.
Yeah, but then it comes down to how to create a successful protocol again, which is a different but related discussion. And we were talking about not BGP but IPv6 yesterday as well. And some people think that it did not find much take up because it didn't add enough to replace all your equipment. Other people say that it actually added way too much, and if it had just been the address part, then they would have already used it. It's always very tricky to decide or to create something that actually finds take up, but that's also a goal. If you want to make the internet better, you have to actually make it better. But what is better? Which is what Rudy's going to tell us now.
Kind of on, well, okay, in the past, I have been working on routing security and the BGP stuff, and we recognize, we observe that things are moving very slowly. Congratulations to our friend Alexander that his open policy proposal after 5 years now is RFC. When I recently was triggered to take a little bit of a new look at the scene, I figured out, damned, improving security or doing security is something where one has to recognize it is not trivial. It cannot be done in a trivial way. Some parts of the slow development, now for the history lesson, of the BGP security stuff, I figured out that people are learning slowly, and when they learn a bit of the whole thing, they might actually move into activist mode and propagate the first steps that they recognized how to do and that they should do it, and actually tell everybody join the thing. In such a situation, there is a tendency that the message that is rolled out is, hey, it's easy, it's just this. And then you find websites telling people, well, okay, here you can test whether your provider has secure BGP.
Sure, yeah.
It's testing in probably not so clean ways, one feature, and infusing the completely wrong idea that this feature is making BGP secure.
Right.
While we still have a lot of stuff still to do. So kind of the question of, well, okay, what properties do we need? What properties are in the game? And what protocol features actually support this well or bad? Probably needs to be done for the routing security, over quite some time. And I'm not sure whether kind of a series of short meetings that started today is going to do it. But kind of for your question, well, okay, how do we tackle to move forward? This might be a simple and down-to-earth example. And by the way, hello, Daniel. I hear that serious history and sociology, social science people over the past few years actually have picked up to gather some of the history. That's interesting. And for example, the BGP stuff that I mentioned just a few minutes ago, I learned a lot from looking back to the history of the stuff. Okay. But for the questions that have been raised from the podium, doing history is fine, but on a foggy road, navigating by looking into the rear mirror is not the best thing to do. Okay. Thank you.
No, thank you. I'm gonna close the mic because we're already running late, and I would have one more question to you all after this, but you first. You've been.
Thanks, Christian Dieckhoff. I believe we've been talking about the internet till this point in this discussion from a very elitary perspective. We've been talking about the internet as technical properties, as an academical view, but we're not talking about the users. And that's a perspective, from my view, that has been completely missing till that point, that the internet in its property is in the end not defined by the routing protocols used and by the transport stack. And if there's something below, in the end, it's for the people out there and for the general public. It's defined by how they use it. And we should maybe for ourselves to define all those questions that have been raised. We should also involve the users in the end, and also we only can solve essential questions regarding political interests and involvements, etc., by having public awareness. It's not just like that we need academic awareness about the internet and the values. We should also ask ourselves what could maybe make awareness on the public for the internet and its values.
Yeah, hence one of the suggestions to have a user working group. But yeah, no, definitely. The users are the one that we're all in the end doing this for, right? Jan.
Hi, Jan Linkova. 2 comments. First, I think I'm a bit confused. Are we talking about protocols which do what we want, or we're talking about protocols which can be deployed? Coming back to initial question, because there are we can design perfect protocol, everyone will be happy, but there are things like benefits for early adopters, incremental deployability, which provide you benefit right away. If you don't have that, it's not going to be deployed, right? So, and it might, and it has nothing to do with features which we want as a designer or as a user. And that brings me back to my second point. I would be careful with talking about users needs to be involved into everything, because I suspect if you talk to people who drive, a lot of them do not care is it a V engine or inline engine. They care about completely different things, like the color. And most of the cases, so it's not like necessary user experience, like details in the protocol design, not necessarily reflected in the user experience directly, right?
Sure, but
so,
most of them do actually care, for instance, that there's an option in the car to make it stop.
Yeah, like They want to have an option. They don't even care like about details how exactly.
No, sure.
it's implemented,
No, definitely.
right?
No, yeah, definitely. And
Dinesh Babuta in personal capacity. Throughout the whole thing and over the past few years, I've just been thinking that all that we seem to do is add complexity to everything. So we've, when we started the internet type of stuff, it was all dynamic. And we didn't like the telco side of things because they were slow. There were so many things to discuss. Things took years and years to bring to the fore before services were released. And I thought that we would have learned from all of that, but we haven't. We seem to be going in the same direction. We seem to be going in the same direction, even if you look at places like ICANN, for example, like the United Nations. Oh, dear sir, thank you for this opportunity for me to speak, et cetera, et cetera. And you waste 15 minutes saying all of that rather than getting down to the nitty gritty. But that's, what I'm trying to say is that what we are doing is we're doing exactly the same, and we're going down that same path. And as others have said, we should be thinking about the end user. Let me come up with an example of Enum. Now, Enum was a fantastic technology, but what happened? There was no uptake for it because it was difficult to implement. So yes, I agree that there are things such as security and all those things that we have to think about. But why are things taking so much time? Why are we continuing to do? I know things do take time, but maybe we need to think about things in a slightly different way. We need to think about, actually, what does the end user want? Actually, how easy is it? Who is it easy for? Is it easy for the engineers? Is it easy for the researchers? Is it easy for the end users? So when we talk about easiness, what do we mean? When we talk about end users, what do we mean? When we talk about protocols, what do we actually mean? So I just think that things need to be simplified.
Those would have been great final words actually, but there's somebody else came up to mind. Yeah. But no, I agree, and I would say making things simple is much harder than making them complicated. So that's a challenge for ourselves, but it is an essential property for good things, right? They're as simple as possible. So yeah, I fully agree.
Just a quick comment to follow up on the previous speaker's suggestion. Jeff Houston at either the last NANOG or the last RIPE meeting, I can't remember which, made a really convincing argument that the internet is actually defined by the DNS and whether, yeah.
I'm originally a DNS person, for those of you who don't know me.
Right, look it up and check it out. That's a really good convincing argument for that.
Thank you. I wanted to close the queues, if you can be quick.
Only to stress the point that we have to decide if we want to have a tactical or strategic approach, and I would like to close with it, as there are so many ideas here floating around in there that we definitely need to break now, and the break is outside. So I would say stop now, have a good drink and have a good chat.
Okay, then thank you, and thank you all for the great discussion here today. And,